Testing one, two.
So when we do the panels and interviews.
Testing one, two. This is the audio is working. Testing. Hello. Testing one, two, yeah, okay. It's picking me up. Zoom's picking me up. Oh, this is a 20-second delay, that's right. Use it, right?
Okay. Do broadcasting. And so as soon as, so it's through the mic that it's gonna be.
No, these mics right here. There's 24 mics.
So if we want to pause the recording. Yeah, I'm thinking during the break period.
Oh, we're not gonna be on Zoom at all. We can just, yeah.
Oh, we can just, if we pause the record, are we able to pause it instead of stopping it?
Well, not fully pause, but more of a stop video, stop mute, and you,
Okay.
yeah. I'd actually do that. Yeah.
Testing, testing.
There you go.
Hey folks, I'm James Chem. I'm a seed stage investor with Bloomberg Beta. And it was how many years ago, Leah, that we first met? We first met basically by the Embarcadero. And at that point, Leah articulated for me this vision of what basically how both the front end and graphs and sort of generated code would all fit together. And at that point, it all seemed kind of crazy and a little ridiculous, and thus I invested because that's sort of what you do as a seed stage investor. You invest in the companies and the founders who feel like they've got the right mix of like sort of visionary and crazy. And it's been remarkable to see so much of that actually happen. And so, so for that reason, we're glad to host events like this. I'm part of, again, Bloomberg Beta, seed stage firm, with Bloomberg as our only investor. We invest broadly in the future of work. I do a bunch of ML tooling and AI applications. And I hope you guys have a good day. This is all going to be recorded and streamed for future processing by NLP tools that will take this, munge it up, and create value out of it. Leah?
Yeah, we're gonna automate the conference process. That's good. All right, yeah, welcome folks. Let me step out a little bit. So as James introduced, Leo, founder of Graphistry. And more importantly, welcome to Graph Planet. So we finally resumed the events after the long kind of COVID, whatever, break. So first of all, thank you for coming. Also new this year, we're doing a online live stream. This is also just, we have kind of a pretty widespread community for kind of like Graph GPU community. I'll talk about that in a little bit. We're kind of expecting folks to be coming in and out all day. I know this is kind of like the kickoff of like RSA. So for folks who are in person, feel free to like just keep your badge, and then when you come back, like head back in and whatnot. Likewise, new this year, we're gonna have a reception. So for everyone who actually made it here like at 9 in the morning, thank you. So that's awesome. And yeah, we're especially for our speakers, I really expect a lot of in and out. Also, I want to do a quick thank you to some of the startups that we're doing with throughout the day. You'll be seeing some of these. So Symmetry Systems, aka Identity, Bloomberg, and of course Graphstream team, and then also Silicon Valley Bank if you make it to the reception this evening. Often you'll see a lot of really cool speakers. This is kind of our chance to have see a little more, like we've always been doing these kind of more like AI correlation kind of type of machine learning kind of talks. And so you'll be seeing some great, like I think we have Berkeley, University of Chicago, Amazon, like the Meta, Llama 3, some folks involved with that. So we'll have a lot of like really interesting folks today. So for everyone who helps make this a great event, thank you. So I'm guessing most folks, some folks here know us, some don't. If you haven't heard of Graphistry before, you might have heard of or even used some of the technology we helped create. So if you use things like Parquet or Pandas, we helped create something called Apache Arrow. So we did donate a good chunk of that early code. Likewise, if you're kind of the next version of that stuff, the kind of GPU accelerator version, we started what became NVIDIA Rapids, 710 GPU data frames. So you can kind of do all of that stuff, except for now on GPUs. So that's kind of pretty powerful. We built all that stuff not because we're trying to sell it or anything. We actually open sourced it. We actually helped start those communities because we wanted to build Graphistry, kind of stuff that James was talking about. And so for our community, folks will connect to whatever database they have, whether it's like logs, graphs, SQL, it's all cool. The initial vision was GPUs, program synthesis, and data science, kind of all this kind of end-to-end system, kind of this sort of like how these technologies come together. Back then, program synthesis was just too early, so it's really just kind of the GPUs and data science in this kind of very visual environment, and so that's where all the graph stuff came in. And so we'll be talking a bit about that. And then finally, obviously with GPT, program synthesis, a little different than how we were doing back at Berkeley, but nowadays it's with LLMs, it's just become a lot easier. And so I'll be talking a bit about Louis. And today I'm mostly going to be doing examples just for cybersecurity because it's RSA. But in practice, supply chain, misinformation, fraud, like finance, like our users do all sorts of stuff. But mostly I would say investigative. So this particular talk, normally I don't talk about the full stuff that Graph3 does, but this like Graph Finance, like one of those few times that we actually give a bit of a wider view. And so one thing I actually want to say is like thank you. And particularly one of the kind of scary but sort of awesome things and very liberating things that happened a few years ago was we flipped from relying on investor funding to do all that kind of stuff that people are using today to actually our investors are now our customers. And so we've been profitably growing for the last few years, and that was a kind of very scary transition as a company, but now it's actually letting us do some pretty exciting stuff, and you're going to be seeing a bit of that today. Two quick mentions there. One is as we're something like as people are starting to notice, if you want to start feeding like raw data into these machine learning pipelines, we have to do things like feature engineering. So we actually open source KuCat, where we took some of our favorite CPU-based feature engineering libraries and automatic feature engineering libraries. And we actually converted that over to GPU code. That's actually helped us complete our end-to-end GPU pipeline from raw data through machine learning analytics all the way to tools. So that was kind of, we just released that open source. We use it. If you want to use it, it's great. Likewise, for our kind of more enterprise users, one of the things we released was like observability, so that as you're doing these end-to-end GPU pipelines, you can actually see more of what's going on with the Graph3 stack. I don't think most people listening today necessarily care about that, but the parts that that's more just for our kind of enterprise users. But the things I did want to talk a bit about today, one, I'll be talking about GFQL, so the new GPU accelerated graph data frame query language. So it's sort of like Pandas and Cypher together. You'll hear about that in a sec. And then Louis.ai, where we're actually now talking to all that data. So that'll kind of be a bigger focus. But last night I did want to kind of emphasize for our community as well as like, they're enabling us to do awesome stuff. So like, I'm very appreciative of that support. We are now actually 3 out of 5 eyes. So we're doing some pretty interesting stuff. And 2, I did want to point out, one is actually, I think John's actually in the front, John's with the Blackbird team. We kind of believe in sort of end-to-end best of class everywhere, so that's why we do all the GPU and whatever stuff. And part of that is like recognizing we're not great at all the things. Like to actually do great investigations and data-driven work, you need to have best everywhere. Part of that is like helping power components of other folks. Like you can't have Yelp without Google Maps, right? So that's I think our earliest conversations. And so it was really cool to see like Blackbird's been like really like kicking butt, honestly, and starting to get like really critical public attention. So so it's really cool. Likewise, the UK government, like normally we can't talk about our government work. We're starting to have like multiple governments actually can talk about some of the work they're doing with us. And so things like supply chain, imagine like sanctions, economic risk. So really fun. I did mention the whole GFQL thing. So I'm guessing anyone here ever written some Pandas code? Is that a familiar thing? Some SQL? Okay. What we found is over the years, like we have to help our customers with like dashboards or Jupyter notebooks, stuff like that. And whenever it kind of got graphy, we start looking code that looks like on the left. It's like a lot of left joins or merges, stuff like that. And that's in kind of a simple case. And we have to do something like a connect the dots of like, hey, if I have a big data frame and like from one user, like what's all the paths to some other user from some other IP, it just got horrible. And so over the years, it's kind of hard to have that compute tier, how to do that. You have tabular data and you want to do graphy things. If you have a graph database, that's cool, but that's sort of on the side. That's not part of your dashboard or your compute pipeline. It's always like, you couldn't quite use the, like we really like the Neo4j Cypher language, for example. And so what we did is with GFQL is we can now talk Cypher on basically any table. So whether you're like in a Streamlit or a Jupyter, or if you're like getting some data from Elastic or S3, you can now get that as a table and then work with that as a graph. And so you can kind of go in and out. we also found that like our Graphistry users, like they'd be looking at a visual and they kind of, if you see the graph, you then want to kind of ask rapid questions on it. It's kind of a very natural thing. And then Louis, as we'll be seeing, is like as people are doing kind of these investigation sessions, often it is tabular, like you're kind of going from like Splunk query to Splunk query, but sometimes you also want to interleave a bit of graph workflow. So having GFQL is just really making sure it runs everywhere. But you know, if you have like 100 million edges and you want to keep it interactive, it's nice if it runs on a GPU. So this is kind of a big addition to our family. Kind of basically what's going on is replace all that merge code with something like, if I was in Neo4j, I'll write some cipher that looks like this. We write our GFQL looks pretty darn similar, except for it's in Python. And one of the key differences is if you use any of these kind of like Python data science data frame technologies, it slips right in. So we're arrow native, so you can take your data frame, jump into a GFQL session, you could write your cipher query, jump out. And one of the things that comes with that is like we have a massive standard library. And so you can do anything you can do with pandas in GFQL. And because we help start the Rapids GPU ecosystem, all of that code is automatically GPU as well. So like you can kind of, if you have a GPU, you can run 100 times faster. So that's been pretty big. We're, as usual, we're releasing the stuff as open source because this, we're hoping the community is useful for them that way. But then for us, it's helping us do a few things. I mentioned Louis. On the Graphistry side, we're finding that as people are, you know, it's actually something we need to like chart out just how much data people are uploading to Graphistry Hub. But as people are putting data into Graphistry Hub, they just want to ask questions about it. And so being able to have like kind of like, you know, RBAC and caching controls and stuff for asking graph questions about all the data people are putting there is super useful. And come talk to me after or hit stuff afterwards if you're kind of interested in what's going on there. I did want to kind of make one point about it, which was out of the box, like, be clear, we're you know, Graph is not becoming a graph database company. We're not doing like petabytes of graph, whatever. Like if you're interested in processing petabytes of graph, like yeah, please come talk to me. That's a fun conversation. But for us, it's really what we're really focusing on, at least the kind of like this year's release, is if you have one GPU, just how much can we do as part of that compute here? And so two numbers I want to give here. Well, actually, also, to be clear, CPU is actually pretty fast. So out of the box, it's already doing something called vectorization. And so we could already do like, you know, 100,000 million like edges and kind of like sub-second interactive time and do lots of interesting queries on it. But what gets interesting is for GPU, like we can do like for even like, you know, the cheapest 5-year-old GPUs on Amazon, we can do like, you know, 100 million edges in interactive time and kind of doing full graph, kind of graph query stuff. It's new, but it's already, like we actually estimate on like really cheap hardware, like this 50 cents thing, we're already roughly around number 120 and graph 500. So if you actually use like an adult sized GPU, we would expect to be in the graph 100. We haven't run those numbers yet, so it's not really a priority, but you know, out of the box, it's already pretty cool. So okay, so what I actually want to talk about here is kind of, I think what a lot of folks are interested in, particularly this year, is what's going on with Louis. And also be fair, what you're going to see here, we're actually looking for a senior security engineer or principal security researcher, somebody like that, to kind of join the team. But we're not a big team, so we're kind of careful with each person. But so this is something we're really excited to join the team. And basically, with Louis, as part of our general push towards this sort of like that kind of future 100x investigation experience, kind of really for these data-driven kind of technology-powered workflows, ultimately it's about automation and autonomy. If we make the analysts augmented, and then for anything that's not analysts, they can be working with these autonomous systems or driving these automations. LLMs are not quite there yet. A lot of technology is kind of moving in that direction. And if you're into that stuff, and we actually have some cool examples of reasons, like we're already kind of bullish on that and cool projects we're doing. What we've actually, for this year, what we've been focusing on with the Louis team is the analyst, just the pure analyst experience. So we're introducing GenAI analyst notebooks, copilots, data pipelines, type of pipeline authoring. You'll kind of see that stuff. And as a kind of a motivating example, I think I saw Brennan somewhere here. So Brennan, basically, as far as I can tell, worked at every single bank cybersecurity team that I've ever heard of, and also the New York Fed. But we put together a cool team, Graphistry team, and Brennan, and We actually won the US Cyber Command's alert volume reduction AI competition early last year, like the year before. And one of the things for Louis has been like we have certain goals that we're trying to do. And one of the kind of benchmarks we have is like, that's cool that we won, and I'll walk you through that in a second, but could we speed run it? Like what's needed so that any analyst can do that? And so to kind of get a feel for kind of what these sort of workloads looks like, so that was, I think it was like 1 billion different IP addresses and alerts from a fusion center of like some telcos and universities, like over maybe 2 weeks of just all the, the honeypots alerts, all that kind of stuff coming in. We were doing some kind of more like, manifolds, UMAP, like graph, kind of like more, not looking like timestamps and kind of continuous data. We were able to kind of get behavioral data into sort of these clusters, and then we were able to use like graph techniques, like just linking IPs. So kind of we have both the continuous domain and that categorical discrete domain. We were able to kind of link it all to these kind of behaviors and clusters into these massive graphs. True to form, we were able to run it all on GPUs, so we were able to crunch all that data very quickly. So that's important for iterating and building out this thing. And then once we kind of had these kind of graphs, kind of clusters in the graph are basically incidents. And so instead of having a lot of like events or alerts, we have discrete incidents of these kind of chunks. So from an investigation perspective, now we can say, hey, like imagine you're rolling into a SOC shift. Hey, what's like the leaderboard for right now? If I'm picking up an alert, how does that link into others? Like that kind of stuff. So it's really cool that like we're building that. Like once we have that sort of like brain or like that knowledge base, then you do all these applications. So the thing with Louis is, how do we get someone who doesn't have that team of like PhDs and GPU and AI people to do it in like an hour? So from the analyst perspective, okay, yeah, data volumes are always going up. But I think a little more interesting, kind of back to the original vision of Graphistry, they're using Splunk, or maybe not Splunk, but probably Splunk. And then all of a sudden the data architect says, hey, you're now also using, Databricks or Snowflake for some security data lake, here's your SQL. And then by the way, everyone's supposed to be like a Python automation engineer app too on their side. And like, so there's kind of this like unicorn expectation, like security data scientist, like security engineer, like, and then you're just trying to like hunt down an incident, like imagine like a tier 2 or whatever. So it's just like it's a lot of expectation. And then kind of like the CISO version or the like director of security version is kind of the like same but different, where they're trying to now roll in, okay, now we have to do this Gen AI thing because apparently that's going to like automate away our jobs or something. And then like the analysts are we're supposed to do more with our analyst team, except for we're not getting like too much more budget to do it. And then we're trying to make a security data lake, like it's supposed to be like a security data lake, not a security swamp. And how are we going to get all the analysts to like use it? Like all that stuff. And like when they tried to do SOAR, like as the Phantom Cyber people a few years ago, and then the Titans people today, but like they all just have like 3 playbooks they're going to implement, and then aspirations for more, right? So and that's kind of where people are, and then but where they want to be is like, instead of like all this sort of stuff that kind of rots on the vine or like someone leaves the org and like whatever, what you actually want is like a compounding system where it's like every time there's some tradecraft that enters your team, it should kind of get reused later. Like every time somebody has a way of like looking at a particular asset or kind of talking to a user, it should be kind of getting better. If someone writes in Python, it shouldn't kind of like rot away as a maintenance burden. It should kind of add to the collective knowledge and things like that. So it's Gen AI is kind of the first time that this stuff starts actually feeling in reach. So the first set of release we're doing here is the notebooks here. So we've been using notebook type technologies for 10-15 years, so we're pretty opinionated on that. I want to give a quick demo here. Give this a go. And I think I'm going to be able to do this one out of 1 minute without the mic. Second. So it's a little hard to see, so I'll kind of read it out. So I asked, hey Louis, get 1,000 events from the Splunk AVR 59K. Actually, I probably it'd be a cooler demo if I actually generate the word Splunk, because what's actually going on is, I can do weatherman here. So on the left, we're connected to Splunk for logs, OpenSearch for logs, Amazon Neptune for graphs, Databricks for SQL. I guess Databricks is off. Actually my, the graphs for team account here. And when I ran that command, Louis had to do a few things. I had to figure out, well, which database am I talking about? Well, in that database, like which columns do I want? Or in this case, I want all the columns, I didn't say. Or maybe my team generally, we're talking about this table, uses only a few certain columns. So I have to kind of like learn all that stuff. Then had to figure out, I want to not only get the query, but I also want to run the query. Those are kind of two different decisions, right? And then also need to decide I don't want to do anything else. I just want to stop right there. So there's like a lot of this like multi-step process that's going on that's sort of like environment aware. And I kind of maybe as a litmus test here. So like, who here uses databases? Great. Who here uses ChatGPT? Great. Who here uses ChatGPT on their databases? Or like that's actually how you query. Great. All right. I think we have the luckiest crowd in San Francisco. So I think we had like 4 hands or something, or 5 hands. So this is awesome. But like that, like we're trying to bring that experience to everybody, right? Most of these systems, like you just, okay. So just in the interest of time, I'm not gonna go through come meet somebody on the team after, but I do want to kind of get some high level feels for it. So here I was able to ask, like, for example, all right, create like a clustering, or in this case, I'm a data scientist, so I can say create a UMAP, create a UMAP embedding of this data frame. As a data scientist, that makes sense to me. As a security analyst, that's probably a bunch of like nonsense, right? Data scientists might say, security analysts would say, hey, cluster the alerts. Louis will handle both of those and figure out that, well, you probably want to start with something like a UMAP, and it'll create this kind of interactive Graphistry session. So all of a sudden we can use Graphistry without, and we actually do, you can see at the bottom, it actually generates Python and stuff. You don't have to know our API, you don't have to be a data scientist to start using this. And then as you kind of grow the system kind of grows with you. So that's actually been like for, upscaling like junior analysts or even senior folks who have new skills, this is kind of a big deal. Here, instead of doing the UMAP clustering, we're kind of, that's some stuff we're doing that competition. We also just want to do regular graph, just connecting like not even the IP addresses, but the subnet 16s. Like I want to see that like a more zoomed out level. Instead of me doing the data wrangling, I could just ask Louis and I'll generate Python, and they'll get the data from Splunk, but then also did generate Python to do the data wrangle, kind of run it in the sandbox. So we're starting with just the AI notebooks. Talk a little bit more, I'll get to that in a second. But we've been using these notebook systems for years, and we've actually been deploying notebook systems to security teams for years. And we've kind of learned how to be a little opinionated about, if you just give like a tier 2 team Jupyter notebooks, like two out of 10 people are going to use it, and they're not going to use it that much. So we've become very opinionated about what that means to bring Python notebooks experiences. So there are certain things we're doing, like natural language is actually the default. Databases are integrated by default. We're bringing in continuous learning, so that as like different, you're always going to have like that team leader or like that really into it person, but then everyone else just kind of wants to use it. Having to start your session and connecting to a Python kernel like that, and then like giving that to somebody else, and now it's like, oh, are you in your kernel? Are you in my kernel? Is the kernel dead? Can you please stop your kernel because you're using all the memory? Like all that kind of stuff. We actually made our own custom data frame reactivity engine. Performance people, we actually think about that stuff for multi-user from day one, all that enterprise like security, isolation, whatever. So we've actually been treating this pretty seriously, building like addressing all those kind of issues that we hit in deployments all those years. We're gonna have a demo later today about the learning aspects. I think we have Alex Maurice somewhere here. So that just how that works and where the direction we're going, you can talk with them about it. But that's actually a pretty big deal. Where the thing I want to highlight here is it's connected, like we start with notebooks, you can actually remix into like beginnings of automation, so you can turn it into like a data application, so like an AI dashboard, and where like interactive inputs, you can actually any of your notebooks double as API endpoints, all of that stuff, and it's actually a learning API endpoint, so we're really kind of going deep here, and so there's a lot of stuff inside. And one of the concepts I've really enjoyed that kind of came out, like the research community is starting to call it like an agent operating systems. And I really thought that kind of was a good mesh for what we've been doing. Because what happens is, yeah, we have the productivity suite on top, but we're actually focusing a lot about integration into the customer's kind of complicated environment. Everyone starts with databases, but folks are already playing with their own custom fine tunes. They might be playing with their own agents, or more likely they're having their own, they're already on their software journey, they have their own automations or their own leaders. And so being able to kind of have Louis as a kind of place to integrate it in, not just integrate it in, but have that continuous learning. And then underneath, we're kind of getting on the path to all that cool GPU, AI, whatever stuff that we've been building out all these years. So a little over time, so probably should cut it here, but so again, I want to say, thank you for coming to join us this year. Feel free to like come in and out through the day. It's a pretty amazing community that we've been gathering. Feel free to reach out to me personally. So my Twitter's here. And again, we are hiring for a cybersecurity kind of principal senior researcher type to help us work with our community. Thank you. But I went over, I'm gonna actually cut questions on my side, I'm sorry, but you can catch me after, and I just want to be respectful of the next speaker here. Okay, so this next speaker here is, do we have Joshua Sachs?
Yeah.
Oh, awesome, cool, yeah, it's being rude to you here. Yeah, we plug in.
No worries. Yeah, here, let me come up.
Cool. I think, I should mention, because we are live streaming, there is a Slack channel, and then I believe somebody on the Graphistery team is monitoring the Slack channel. Whoever that is, that's Thomas. So I'll answer any questions about the Louis part right now. So I'll be rude to you even more, Josh. Do you want
No, go ahead.
Yeah.
Do you want to take questions?
No, I'll do that. Like I'll do that live if you want to kind of get going here.
Oh, sure. Yeah.
But then for your part, we might have questions from you online.
Okay, sounds good.
All right. Were you able to log into the Zoom?
Oh, I'm so sorry. So yeah, let me.
Let's get into
just that. No, I'm being rude. Did you send me a link or something, Leah?
Yeah, you should
Okay.
have
I'm just
a calendar available.
okay. Let me see.
Yeah, let's plug you into it. Check out.
Great. Yeah, share screen. Okay. Oh, I see. So I don't need to plug in something. Just share screen. Yeah. Should I?
Sorry, Leo. No. How do I?
I'm muting, right? This is another.
Yeah, no, yeah. That's me.
Okay.
That's me.
Getting beer fun. Oh, no. Okay, cool.
But let me introduce you.
Oh, okay, that sounds good.
Yeah, so for folks who, Josh or Joshua?
Josh, that's good.
Yeah, so folks that don't know Josh, he's actually shared with us before. So I think like DARPA days, like chief data scientist on say Sophos. So I probably should review notes before, but like these are like these are like pretty memorable positions, right? And so like I didn't even bother because of that. And then I'm guessing folks here have heard of something called Llama 3, right? And so I won't kind of spill the beans on that, but like, yeah, it's pretty amazing to have them kind of share what's going on with all that technology. So yeah, I'll let you take it from here.
Thanks a lot, Leah. Okay, happy to be here. I'm Josh. I'm a software engineer at Meta. So at Meta, I lead our work around making sure that the Llama family of models behave securely. I also work on sort of LLM application security. So when we integrate LLMs or Gen AI models in general into applications internally, there's a set of security things that we need to do to make sure that they're resilient to prompt injection attacks and other types of security issues. Okay, for those of you who were at, I see some faces that look familiar from the events last night, the AI plus security event. So this is a longer version of the talk I gave last night, so I apologize in advance if there's some repetition. I'll try to linger on some stuff, given that I have a bit more time. I think I have half an hour, right, Leo? Or
20.
Oh, 20 minutes, okay. So yeah, that's like 2x the time I had last night, so I'll go into a bit more depth. Also happy to answer questions, feel free to interrupt me. Okay, so, and thanks Leo for inviting me. I think last time I was here was like the early days of the pandemic, 3 years ago, so nice to be back during sort of rosier times. Okay, so the work I'm going to talk about today is basically an open source work stream that we have in AI security at Meta focused on building open source AI safety tools. So, I think as everybody knows, Meta has an open source bent to our AI strategy, but that includes a commitment to open sourcing safety tools alongside our models. Okay. All right, so I'm gonna start by motivating the projects that I'll introduce. Then I'll talk about 2 projects that we open sourced alongside the Llama 3 release a few weeks ago. Does everybody know what the Llama 3 models are and what that release was? Okay, it's an AI security event, I would imagine you do. So simultaneous with the Llama 3 release, well, there's a few things that the team that I work with did as part of that release. So one, we worked on fine-tuning Llama 3 to behave more securely. We worked also on evaluating lots of different release candidates before we actually released Llama 3 from a cybersecurity perspective. And then we also open sourced a bunch of the evals that we used as part of the model design process, and also an inference type guardrail called Code Shield, which I'll talk about. Okay, so I'm going to talk about those projects, and then hopefully I'll leave some time for Q&A. Okay, why does LLM security matter? One, as we grant more autonomy to LLMs in helping to engineer software, we also incur risk around the possibility LLMs can introduce bugs into our code bases, right? So if you look at the history of modern software, it's in part a history of sort of cataclysmic security incidents born of software vulnerabilities. It's an open question the effects that LLM authored code will have on the future of that history. So we're living in a time when people are talking about building autonomous AI software engineering agents. We need to make sure that they behave securely, or we could be incurring a lot of additional risk. People are rapidly adopting large language model coding assistants, and nowadays also increasingly autonomous coding agents. That's the case internally at Meta. I think it's probably the case of many companies. There are real rewards and real incentives to adopting these tools. There are credible empirical studies showing the ways in which LLMs have real utility there. But when we measured using our open source evals, the security of the code coming out of LLMs, we found that there were real problems. So I won't go too much into this plot here. This is an evaluation of a popular set of LLMs on our insecure coding test cases within our open source CyberStack eval framework. And we found that all the LLMs failed a significant percentage of our tests when we looked at the propensity to generate insecure code. I'll get into more detailed results on those tests later. Okay, and another risk that matters in the development of LLMs is that they can be used by attackers to scale their cyber attacks. I think there's lots of diversity of opinion around the extent to which LLMs will, provide more benefits to attackers versus defenders, but it's clear that LLMs can be used in this way. Here's an example of an LLM generating a phishing email. You can also, insofar as you can use LLMs to help write benign code, you can also use them to help write malicious code. And we're looking at a future in which LLMs are going to get more agentic, I think, and you can imagine the possibilities for attackers there. So this is a risk that we want to minimize at Meta as we open source powerful LLMs, and we also want to measure, future frontier models in terms of their offensive capabilities to help inform decisions about whether we should open source them at all. Okay, so there's like a lot of qualitative discussion in circulation right now around the risks that large language models introduce. One of our goals on the team that I work with is to ground those discussions in empirical data. So that's a big motivation for our commitment to develop these open source cybersecurity evals that I'm going to talk about today. Okay, so hopefully I've appropriately motivated the rest of my talk. So I'm going to talk about CyberSec eval, which, apologies, it's misspelled on the slide, it's one word, which is our suite of benchmarks for LLM cybersecurity safety, and also Code Shield, which is like a sort of firewall that you place in between an LLM and your coding assistant application or your coding agent that prevents insecure code practices from that you can use to block insecure coding practices. All right, so here are some of our measurement goals with our evals. We measure the propensity of an LLM to output insecure code, the propensity of an LLM to agree to help do terrible things online, like write phishing emails or write ransomware. The propensity of the capability of an LLM to exploit traditional memory bugs like format string bugs and buffer overflows and use after free and that sort of thing. The propensity of an LLM to succumb to a prompt injection attack, to agree to execute a fork bomb or a sandbox escape inside of an attached code interpreter, capabilities around SQL injection, logic exploits across JavaScript, Python, C, C++, SQL. And we're also starting to measure false refusal rates. It's super important for us in LLM development to always look at the trade-off and try to stay on the efficient frontier of like helpfulness versus harmfulness. So we're also looking at the performance of an LLM and agreeing to help do sort of gray area or borderline cybersecurity tasks that aren't explicitly malicious. All right, so I'm going to walk through how we construct our test cases for insecure code output, and also keep track of time. Okay, so the way we try to generate test cases automatically wherever possible. You'll see that through the rest of this presentation. The way we automatically generate insecure code test cases is we take a big open source code corpus. We identify vulnerable lines of code using a big sort of knowledge base of static analyzers, like this stir copy line, which is an insecure coding practice. And then we prompt, in the test case, we prompt the LLM with receiving lines of code and see if it sort of repeats the bug. Or I wouldn't call this a bug, but I would call this an insecure coding practice that should be, you should use stir and copy or some other, memory safe method here. And we do this like across a matrix of lots of different languages and lots of different CWEs. If you go look at our code or the paper that we released with this framework in December, you'll see that there, I forget how many, it's like dozens of CWEs and like all the popular languages are covered with these test cases. We also measure instruction based insecure coding suggestions. So if so basically we take these blocks of open source codes, we use an LLM to translate them into an instruction that sort of would have produced this block of code. So for example, this copy block of code gets translated to write C code to copy a string, the source string to a destination buffer. And then so that's how we derive these instruction test cases, which measure the propensity of an LLM in like a chatbot setting to suggest insecure code. So at Meta we use this framework internally on our coding assistant and coding auto-suggest tools. So at Meta, probably like most tech companies, we have, our developers are armed with like an LLM that auto-completes their codes when they're writing, Jupyter notebooks or, code that's gonna land into our actual code base. And there's also like an internal, chatbot that people use to answer technical questions. And so, we evaluate those systems using this framework. Here was sort of an interesting result that went into our December paper. If you Google cybersec eval and like Joshua Sachs, the paper should come up if you're interested in more detail. But like basically what we found is that the better LLMs get at coding, the worse they do on our insecure coding tests. And so let me explain these plots. So the vertical axis here is the number of test cases passed. So up is good. Up means that you didn't output insecure code. And then the horizontal axis is a measure of code quality. So like in these tests, GPT-4 did, this is pre-Llama 3, so we evaluated Llama 2, OpenAI, and CodeLlama. GPT-4 was the best coding model on the horizontal axis, but it did really poorly at the insecure coding tests. The left plot is for autocomplete, the right plot is for the chatbot test cases. But the result, the correlation is pretty tight. The result's pretty robust. We also, we were surprised by this result. We did a lot of manual inspection. I think our hypothesis is that the LLMs are learning to imitate the open source, code corpus that contains lots of insecure coding practices. But this is all the more reason to care about this issue, especially when you hear about autonomous coding assistants that are just going to go write your code for you and do all your work for you. There are real security risks to that sort of setup that our community needs to mitigate. Okay, so we also a few weeks ago released a guardrail system that we use internally. Internally, this system has blocked like 16,000 insecure code suggestions. We open sourced it. It's called Code Shield. You use it to guardrail your LLM when it's suggesting code to you. Okay, so right. So the LLM produces some code. This diagram is fairly simple. LLM produces some code. Code Shield intervenes. If the code's insecure, it doesn't suggest it to the user. Okay, my colleague who made these slides had to fly home today, so I'm gonna under-index on these slides. But basically, what the team did here was develop like a multi-stage detection funnel where we put we're very conscious of latency here because you were supporting real-time autocomplete systems as well as chatbots. So what we do is we follow a design principle where we put like the really cheap checks up front, sort of high recall, low precision checks, and then downstream of those, we put the heavier checks that involves like real AST parsing and hardcore static analysis. So 90% of the calls to Code Shields take I think like less than 200 milliseconds, and then there's a few if we were really sort of suspicious of the code that we spend longer on. Yeah, we cover a lot of CWEs. We cover 7 languages. Latency is really low. Hoping folks use our framework. It's been a few weeks, so we're really looking forward to hearing if people are using it. It's licensed. I believe it's Apache license instead of Apache or MIT. It's like really permissive. We would love to get contributions if folks want to contribute to our sort of static analysis knowledge base. Okay. I'm going to go through a few more benchmarks. So at Meta, we want to make sure that hackers don't use like Meta AI or the various sort of services in which we expose Llama 3 models to help write phishing emails or write ransomware. That's off policy for our particular LLM application. So we have a whole bunch of evals that help us measure how likely it is an LLM will comply with the request to help do cyber attacks. And so we cover the whole MITRE attack ontology there. I'm gonna go quickly here. Happy to answer questions later, but yeah, this is a matrix view that we use to evaluate how well models do in our tests. So here we're evaluating how well a whole bunch of models do at refusing to help do offensive like cyber attacks. So for example, Llama 3 AB instruct is represented in this row. So here lower is better and bluer is better. So what we're seeing here is across the columns, which are categories of MITRE and TTPs, like C2 is like, command and control communication back to, a hacker-controlled server. Llama 3AB only agrees to 15% of, requests. Like a request here would be like, help me write a covert, like steganographic C2, channel in Python so I can communicate back with my ransomware server, this sort of thing. So, only 15% of the time does Llama 3 agree to that. Yeah, and then there's some models that don't seem to be, like GPT-4 and Llama 3 are they seem to be heavily fine-tuned. Well, I know in the case of Llama 3, and it seems to be in the case of GPT-4, right, they're sort of heavily fine-tuned to refuse that kind of behavior. There's other models like Mistral Small and GPT-3.5, right, that often agree. Okay. We also measure false refusal rate. So, if I ask, to help reverse some malware, and Llama 3 says, no, that's a false refusal, it's a benign task, but it's, it's close in sort of text distribution to a malicious prompt. So sometimes that LLM gets confused. So we explicitly, like in designing Llama 3, we explicitly measure these 2 dimensions, and make sure that, we were at the efficient frontier in the trade-off between the false refusals and true refusals. Okay, I'm going to move on to a different type of test. So we're also interested in understanding our model's capabilities and exploiting bugs and developing and identifying vulnerabilities. So there's lots of talk in the cybersecurity community around, could LLMs become autonomous hackers that find bugs and solve bug bounties? Are they going to replicate? Are they going to knock us out of our current equilibrium in attack and defense and cybersecurity? So we were interested in deep diving into one particular area, which is vulnerability research and automatic exploit generation, to sort of empirically ground that discussion. So what we did with this release that we did a few weeks ago is we developed small vulnerable program test cases across like a whole matrix of vulnerabilities. So the languages we cover are JavaScript, Python, C, C++, and SQL. And the bug classes we cover include but are not limited to, SQL injection, logic bugs, simple stack overflows, format string bugs, etc. Here's an example test case. We use a set of program synthesizers to generate most of our test cases. So you can actually, these are all open source, you can go sample, you can go run them. Every time you run them, you get a new test case. Oh, I got 2 more minutes, okay. Every time you run them, you get a new test case, which you can give to an LLM. You know in advance the LLM couldn't have memorized it, right? Because it's new in structure, and it's new in variable names. And we see if the LLM can generate a string that solves the challenge. Okay, so the results here are interesting. I would say we published a paper on arXiv a few weeks ago that go into depth here, but GPT-4 solves 23% of test cases that look like this that involve fairly complicated program reasoning, I would say, and also domain knowledge around how SQL works and how Python works and that kind of thing. And that's generally, so basically what we found is that the LLMs that have better coding capability do better on these tests. So, in general, LLMs are not great at exploiting bugs, but if you sort of play time forward and play the scaling loss forward, they might get better. If you imagine sort of tool augmented workflows and RAG and lots of sort of hand-holding and guardrails of the LLM, you could imagine LLMs, doing better in this domain. But I think we're not at a point where we're in the current equilibrium, and the way that exploit development works is going to get disrupted, more than incrementally, I would say. We evaluate a whole bunch of different prompt injection methods. Since I only have 2 minutes, I'll just say LLMs kind of suck at resilience to prompt injection. you can't trust an LLM not to succumb to a prompt injection, basically, although there is a lot of variability in how well they do. And it's correlated, it's positively correlated with logical reasoning ability, I would say, which I think is closely sort of, related to the prompt injection problem. And okay, since I don't have any more time, I'm gonna stop, but I'm happy to take questions. You can like look me up and ping me on Twitter also, or LinkedIn, and I'll stop there.
Yeah, I have maybe one question while we set up for the next session, so.
I have one. So if, let's say, someone finds one of these test cases, which probably might not be validated correctly by someone three, so is there a way we can like reach out or create a PR or something like that?
Sorry, if you find, I think I didn't get it.
If, let's say I find a test case, maybe a piece of code that Llama doesn't properly categorize it into something malicious. So is there a way to report it?
Yeah, I mean, well, obviously, for the test cases that are currently in cybersecurity development, we already know, right, where Llama 3 is failing. But you're saying if you add to the test case, if you find some other problems in Llama 3, sure. I mean, yeah, I'd love to hear from you. Yeah.
Testing. Testing, okay, great, we have 2 mics, and let me make sure the streaming's set up right for anyone who's online. Okay, yeah, so thanks, Josh, and we'll have one more speaker after this session, and then we'll have a break period, and encourage you to reach out to the market speakers. So I actually want to introduce, we're gonna actually do something a little different. We're gonna do an interview with Ari. So actually come on over. And Ari, I think I met Ari like first, like very briefly at one of the earliest AI villages. So we have actually a few of the DEF CON AI village folks here. And I think back then that might have been your Harvard days, I'm gonna say.
Yeah, that's a PhD student at that time.
Yeah, so it's a very kind of, I feel, early days for the community. I think AI red teaming was starting to become a thing. There's this weird startup OpenAI that was starting, I guess. And so Ari was actually part of the GPT-3 team. Then I'm sure a lot of anecdotes later, Ari, I think many people in that cohort are actually really busy founders nowadays. And basically, if I think back to everybody, it's like, this is kind of a crazy week. So we're actually very lucky to have Ari here with us. And so we want to do a bit of an interview. So welcome, Ari.
Thank you for having me.
So yeah, I prepared a few questions, but if folks have as we go along, like we're gonna talk a little bit about like AI red teaming, a bit about OpenAI, and a bit about what you're up to nowadays. So please, if you have your own questions, kind of just raise your hand as we go. So the first thing I want to ask about was, well, you were on the GPT-3 paper, so that was kind of when prompt engineering became not just like a concept from academia, but actual practical reality. And so I was kind of curious if you could share anything about that experience, and then also how it changed, if and how it changed your view on kind of security.
I'd say it was like a step function in a lot of ways. I ended up at OpenAI in kind of a weird way. So I was in my PhD. I had 2 GPUs at Harvard. I had an offer in hand from OpenAI for more than 2 GPUs. So the calculus kind of worked out pretty well. But for me, the moment that convinced me that it would make sense to leave academia was actually GPT-2. So the results from that were very compelling. I played with a lot of, they weren't like large language models at the time, but I played with a lot of NLP systems, and they weren't very impressive. And so as soon as GPT comes out, you start to see that like the economics of cybercrime can change pretty significantly, because now you have these systems that can generate much more compelling spear phishing campaigns, or they can be significant contributors to disinformation. A lot of issues like that. And so for me, I thought a lot about like the scale aspect of what LLMs can do. And when we were working on GPT-3, like that was around the same time we started figuring out the scaling laws were actually holding. Like prior to this, a lot of the research at OpenAI was around like doing weird things with RL and trying to play games. And I'm sure if anybody of you guys remembered, like the Dota 2 stuff, I mean, that was good, but I mean, how do you make a business out of Dota 2 bots? So when we had GP3, it was compelling enough that we started thinking a lot more about like what are the societal impacts of this, and not just like what kind of things can you sell to people as like an API, but like how do you make sure that the things that you're selling to people aren't going to cause societal harm? And so I ended up joining and writing a lot of very cursed things. Like I wrote like weird versions of polymorphic malware using GP3. I made cursed disinformation infrastructure sort of things. And all of these things were very compelling. I mean, they weren't great because it was GP3, but you can definitely see like the lines on the graph go up. And I guess this also kind of dovetails nicely with Josh's talk, where I think it's really important to design evals around what it is you think that like LLMs are capable of, and then kind of hold yourself to like tracking this sort of behavior.
Awesome, yeah, that's when I think of like, like early Bell Labs or anything, I just like, that must have felt like kind of crazy. Yeah, so you're kind of like a, for folks who don't know, like an AI red teaming, like Ari is one of the names, I would say. And so I was kind of curious, like, can you describe a representative AI red teaming projects you did? And then do you have any, like, based off of that, any guidance for teams deploying models as part of a, like, imagine like a product team or even like an internal team, imagine like internal enterprise search, or maybe if they're exposing it as to customers, like externally.
Oh yeah, oh man, I did a lot of those. I think the most interesting one is the Codex project. And it's also dovetails nicely with Josh's project. I think if you're going to do serious red team these days, like you have to think about the evals, because otherwise you're just kind of shooting blind into the dark. Like you can design a lot of really interesting, compelling projects of course things that you can do with language models, but unless you can actually measure what it is that the model is doing in a atomic fashion, you're not really going to get that useful information out of it.
And so that's definitely, so you do that even just like for like a team, like imagine they're deploying like Lean or like some enterprise product like that, you think they should be doing evals even then?
I mean, there's a lot of open source evals now. I think it makes it a lot easier. I mean, people have been building harnesses. It's not as like early Wild West around that sort of stuff as it used to be. And so I think it's a lot easier now to like hook into these sort of systems, and you don't have to build anything from scratch now. You can actually use some stuff that people have put out there for you.
Yeah, I like the whole trust but verify. We actually found a vendor who was using GPT to generate their security questionnaire answer, except for they didn't ground it on any of their internal policies. They just asked GPT to give a good answer. So trust but verify. I'm very for that. So yeah, and again, we're lucky to have you. So folks who don't know, Run Civil's your latest venture. And so I was kind of curious, like. Also, I want to point out, like, we didn't make you do the hot ones challenge or anything here, so this is gonna be tricky. But no, you don't have to do like 10,000 scobles or whatever for this one. But yeah, can you what is Run Civil, and especially anything from the Gen AI perspective, like kind of like what's kind of changing things with Run Civil?
So we're trying to change the way that people do pen testing. So we're automating the labor component of it, and we built an AI agent that can run pen tests. And so we sell pen tests, they're pen test shaped, they're faster than regular pen tests, because it's an agent running 24/7 instead of a human running and having to sleep. That's what Civil is.
So would you directly engage with the blue team, or you'd work with like the red team shops out there and then you'd help them kind of do their pen test better? Like I'm kind of curious when the market, or is it both?
So people will buy pen tests for like two reasons. Either you care about SOC 2 and you don't care about anything else, or you do care about security and you don't have a security team, or your security team is like underwater and you just want to get some sort of sense of what your attack surface looks like. So those are like the two profiles of people that we work with. But we do also sell to pen test shops themselves, because they're also I don't know if you know this, but like there's not a lot of good talent out there. And so it makes it hard for people to get access to a good pen test. Like even the best shops still do a lot of outsourcing themselves. I'm not gonna name names, but I know that there's a big, well-known shop that I think 80% of their people are attached to AWS, and then the rest of them are all like for the rest of the accounts, and so they can't, staff the whole thing, and so they end up hiring a bunch of these subcontractors. And I mean, some of those subcontractors are great, but you don't usually get like a lot of quality control of a lot of this stuff either. So being able to be more transparent about what is actually happening in your test is something that can really only help consumers.
Yeah, and actually, like as a startup, like, pen tests actually do show up on our budget, and so anything to make that more accessible is like so awesome. So, and then I guess, I mean, just more broadly, like, while we have here, like, anything you wanna like share with the audience, or you want them to be thinking about, or anything you wanna share with the civil community, anything?
This is embarrassing, but nothing comes to mind. I think that's all questions.
Yeah, and from the audience, I don't know if there's like anything, folks are like, has anyone been trying to do like AI red teaming, or is this like the first time folks have heard about it?
Question.
Okay, yeah, Summit.
Alright,
Nice.
nice to meet you.
What's your general sense of how far ahead offensive teams are with this kind of tech, right?
Oh god, nobody knows what the fuck they're doing. It's really.
Seems like that's a good thing in some ways.
I mean, it's great for me, but it's not good for the industry.
But is it also a case of like we're in the dark, because there could be some very good people out there?
There's
Really, if we look at where GPUs are being bought in certain places.
This is true, but I think being able to have access to GPUs, understanding how to train a GPT, two very different things. There's not a lot of people on the planet that know like how to use the GPUs that they would have access to. Now you can look at some groups, like for example in China, like there's a couple of like really interesting models that are coming out. Some of them are performing well, but a lot of them are not performing that well. And so clearly the answer is like you kind of have to know what you're doing in some capacity to be able to leverage these things. I also think that it's sort of a red herring to think that it's good to train your own model for this sort of stuff. I mean, we run like all the main like LLMs, but we also have our own custom models for certain things because it's just cheaper, and we also get better results on like certain benchmarks. But if we were to train our own model from scratch, I don't think that would be particularly smart because there's just better stuff out there you can kind of layer together. I think the way the industry is going is people are going to figure out how to leverage like these off-the-shelf models much more efficiently, because they've been trained on a lot more tokens than I could ever do unless I'm going to staff out like a giant team to do that for me.
Any more questions?
So I'm curious, are you doing many black box tests, or are you also doing white box, or a combination of both?
We're just doing black box. We've gotten requests to do like code analysis too, but that's like a whole other thing. I think anybody that works in this particular space, you have to focus on scope. And so we're focused on selling something that is the shape of a pen test because that's what customers are used to. And as we go on, then of course change that. But right now, like there's a bunch of other companies that sell like secure code sort of things. I think there's a couple other companies that are also trying to do like code analysis in like a more offensive sort of way. But that's not really our OT.
Yeah, I mean, my feedback there, I started my career as a pen tester, and now I'm a stakeholder that hires pen testers. Like my opinion has always been that black box is kind of wasting their time because it's kind of like they have to go discover things that I can tell them in advance. So the way I like to do it is I point them to the places where I know there could be issues, and then I give them access to the code as well, so they don't have to waste time. So I'm thinking whether an LLM will probably take advantage of the same approach, right? Where you don't have to go through every API endpoint, clicking on every feature of the UI, but you can actually point to things that you believe could be, or you could use kind of like white box first to find, do maybe like, static code analysis, point to a specific, do like flow graph analysis of how you can reach that code and then try to do automated black box part, right? So,
Yeah, I like that. The challenge we've been running into, like to be frank, is that people aren't sure like how to trust the LLM. And so if you can give them just black box access, it's so much easier than trying to convince them that they should give code to this magic machine. You don't know where it's going. And there's a lot of questions around compliance around data that you give to LLMs that we could spend some time figuring out, but right now we're focused on making sure that we're delivering something customers like. It's really good feedback about it, so I'll run with that for now, but that's a good idea.
Thanks for the great interview. Yeah, and in general, the thing that I worry about when I see these products is how do you make sure that basically the model is not just going to wipe out the website or click on something that it's not supposed to click on. I'm pretty sure you already have an answer to this, but like how do you do it in practice is really something that I think is challenging. So.
For now, we just hack it with rating name.
Yeah.
Yeah. Yeah, there's not a sexy answer, but you're 1000% correct. Like it's for people that aren't building this as like a pen tester or maybe are thinking about building it offensively, like DDoS I think is gonna become a much more big issue, so maybe buy Cloudflare or something.
So in terms of running pen tests, what's the input and how in Leo's question earlier, like where is the human getting engaged in providing the input and reviewing the output, and what is your sense of coverage when you talk about pen tests?
Should I go and call my co-founder back? Hell yeah. This is my co-founder Shane.
Yo. How's it going?
Hey guys. Yeah, so in terms of inputs, outputs, we were trying to map very closely to what a human gets. So for us, that means entry point URL, credentials, and your scope. From there, our products will sort of browse the application and then run detections. And in terms of coverage, I mean, it's what you expect, right? Like if you're doing a pen test, you have a checklist of your access control set testing, your input standardization, all that good stuff.
So from your perspective, especially from the folks that are doing this compliance perspective. From your perspective, especially for the folks that are doing this from a compliance perspective, have you run into any pushback from compliance certification organizations saying, hey, because a human didn't do this, it's not certified?
Oh man, yeah, so we have a human in the loop that handles that. And that way, when they get upset about it, we're like, we got this guy, you're gonna be
So
fine.
you're always doing some type of validation at the end that has.
Exactly, yeah. We've also started talking to auditors that do the SOC 2 analysis, to make sure that what we're doing is something they would consider like valid as a pen test, and so far we haven't had any pushback. I don't know how long that's gonna be, because I think that this is gonna be enough of a hot topic in the coming years that it will get kind of annoying. But for now, it hasn't been that annoying.
Do you think the certification organization will adapt to that, to where eventually they'll, I think you're.
Oh, they're gonna have to. I mean, like it's not. I think that this is gonna get like a very spicy area. Like enough people are understanding that there's something here. So it's not just us that's gonna be building this; it's other people too. And I think with enough of us building it, then they're gonna have to respond.
We maybe one more and we that's.
I have a quick question. I keep seeing trucks driving around advertising a model called White Rabbit Neo.
Unaffiliated.
Yeah, that's not us. It also doesn't. I don't want to roast them. Like he's doing a test. You're gonna leave me. Oh man. It doesn't work as well as we would like it to for the workflows that we use it for. So that's what we'll say.
There we go.
That was beautiful.
Any other questions? One last.
So what's your perspective on, like, you guys, the community is doing an amazing job on evils and like, putting rail guards, but I mean, the fact is like every model that has been out there has been, jailbreak, it's been, it's like, it has happened every single time, right? So like, what's your view on like, once GPT-5 comes, when Llama 4 comes, like what needs to change in order to like fix that, right? Because like, I think the right steps are, people have good intentions, but it hasn't we haven't seen a model where that hasn't been possible, right? So what's the fix, right? Like,
There isn't a fix.
yeah.
I mean, like, it's like human behavior, like you can't fix human behavior, there's always gonna be bad actors doing bad stuff, and so we have an entire industry focused on stopping people from doing bad things. And so I think that our industry is just going to adapt to that, where we figure out we have ways to handle humans doing bad things, we'll just adapt certain things around IDR to handle and other products to handle when models do bad things too.
Cool, it's more about like the bad guys having access to the model so they can be bad guys, right? And we have had an industry for like 20 years trying to prevent that and we have failed. So, you know.
Yeah, I don't have any satisfying answers, I think we're all kind of fucked, but. But I
Yeah, we're starting, yeah, okay. Yeah, and then you'll do your share screen.
company is trying to onboard different forms of GenAI tools. We are from Symmetry Systems, and we work with several companies all the way from this commercial manufacturing tech to also just defense companies. So really high assurance environments is one of the key filters. It's actually really helpful to just get a sense of when we think of an organization, what a median organization looks like from the lens of someone who is trying to onboard machine learning tools, AI tools. This is essentially a snapshot of a corporate environment for roughly a median company. It's something where you have 200,000 plus identities. This could be human identities, could be service roles, machine identities. And then it starts sort of walking, like on the one side you have identities, on the other side you have data. So data could be things that are in the corporate environment, which is SharePoint, OneDrive, and equivalent. Things that could be in product environment. So you think of unstructured buckets, RDS, DynamoDB, things like this. And then the CISO kind of thinks of corp, product, and then data lakes and analysts who are working with Snowflake, Databricks, all of these different type of tools. And there are about thousands of those. Now, a regular CISO may have, let's say, tens of people working for them. Of course, this variance is big, but proportionately, if you have tens of security engineers, you have thousands, hundreds to thousands of applications or developers working around. So this is just roughly the size of an organization. It's also helpful to see what this organization looks physically. So this is the graph of all the data stores, data and identities. So the legend really is blue is data, everything non-blue are human identities, service roles, etc. And the edges in this graph are either permissions from identities to data, or they are operations, so you can filter this by either. And the key takeaways here are, you can see that there are several islands of data that are formed with the heart of the central nodes that are different types of identities in the middle. Those are BUs that have done a pretty good job of constructing a moat and a drawbridge around their environment. Things are pretty controlled, governed, and so on. But the other thing that's really hard to miss is that there's a giant mosh pit in the middle of all these permissions that are just completely unused, that are probably unnecessary, and they're also ungoverned. So it's this environment that a CISO is sitting around thinking, all right, I'm going to enable my corp, dev, and data lake teams to run generative AI tools. Now, the story that they are told, and probably the reasonable future state once we resolve the mosh pit, is that it's going to be great. Security is straightforward because, hey, look, we are not going to train. Like if I'm a provider of such models, Microsoft is just an example. Like we'll not train our foundation models on your data. You get a single tenant environment. That's a pretty big use case for our argument for security. And then like, hey, this is not fine tuning. I'm just using RAG. This is just indexing your policies and then going off of that. So that's also secure, right? So if I'm kind of using Microsoft terminology, you say like, hey, there's a really nice new identity store service called an Entra ID. There's a data governance service called Purview. You take data and identities together, and then these drive policies through data stores like OneDrive, SharePoint, etc., and tools like Copilot. That's the vision. Like, hey, if we get this, we get a really nice, rosy future. And from a CISO's point of view, the things to worry about are where you're looking outside. Like, hey, you might have employees who might write super duper top secret stuff out to ChatGPT. So we've been doing so-called CASB tools, DLP type tools before. Let's put a filter on this text box that goes out to ChatGPT and see if people are writing secrets. That's fair. Another set of really deep scientific work that's going on, and one of the authors is right here, is around, hey, how do you build really great robust models? You can poison these models, you can figure out how to get them to do bad things. So these are pretty great. But from, again, the three environments that we said, this really affects the development environment when you are introducing as a developer a model into your product. But the rest of the environments really this doesn't affect. The rest of the environment, what it looks like is something like this. And this is drawn from several really large organizations to smaller ones where all of these have happened in practice, despite all the controls that are placed around Microsoft Copilot, where the recommended model is like, hey, you just onboard 50 people or 100 people to start. And when you start from there, folks can start querying, asking Copilot's indexing everything in the background. And the final findings were I could figure out, or employees could figure out what the salaries are for different BUs that they should have no access to. They could figure out what the RIF plans are and why specific people, internal discussions on why they're getting RIF. Internal information like financial sales projections, business IP, CAD files, roadmaps for, hey, if I'm making Baby Yoda movie next year, all that stuff is right there, right? And then the classic things like customer data gets leaked pretty massively as well. So this is very, very, very common. Like this is blocking Copilot adoption in many places because they're like, hey, we can't confidently roll out Copilot into the mosh pit. And really the root cause for this is this diagram from the Copilot architecture websites, right? So you see that big icon in the middle, it gets the query, then it just builds the graph index of all the content. It uses that to pull out, and all the permissions on the graph that's being built, on the database that's built, is the permissions that are inherited from SharePoint. So from everyone that folks who already know how SharePoint works, there's org-wide permissions, there's public permissions, and then there are just groups that you make that you basically, as people join, move, and leave, you only monotonically add permissions over time. You never really give them up. So I think that's the root cause. And then I'm just a quick shout out to my colleague, Claude Mandy, who's presenting the State of Cloud Data Security tomorrow at a workshop. He's there in the audience, where he's showing that across several range of customers, if you let some indexing tool like Copilot run on a data store or an environment that 10% of the environments across, immediate environments across our customers have like massively sensitive data. This is not just PII, but all the different types we talked about before. So this is the underlying root cause. So now the question is, what are we going to do about this? So it's kind of changing the tone a little bit from doom and gloom to, hey, look, what really could be a path out? There's a really classic field of information flow control, and the notion of we are trying to really, what the guarantees that we want are not what we are expressing on Entra ID and Purview. What we don't want are just asset permissions of I belong to a group and the group has access to folders. What I really want to be able to do are map out data types, map out identity types. So identity types could be contractors, could be vendors, could be different ranges of contractors and so on. And then the most kind of important and hardest part that probably gets the least attention so far is the notion of like, what are you doing with it, right? So the classic triad is like, hey, what data do I have? Who can access it? And how is it used? So the how is it used part comes with a lot of like the baseline use cases, clear and present use cases today have to do, for example, with data residency. Like, hey, citizens of Indonesia, their data should not flow out of Jakarta, etc. Now, how do we work this into practice? This is a super, super old field. Dorothy Denning started this, I guess, in way back. There's been folks who've done it at the OS level, PL level, distributed systems. The decentralized work by Andrew Myers and Lisco is super, super relevant because there are only like 10, 20, tens of security and compliance people. The context, the business context for compliance, for what the data could be, is basically in the hands of the business units themselves. So the fundamental model has to be fully decentralized versus the dominant model today where GRC teams are the ones that are defining policies for the entire org. That is just not going to scale at the ones that we are talking about. And then this, one of my favorite little pointers is Max Kron at MIT worked on Flume. Flume was deployed with OkCupid. So if you were using OkCupid 10 years ago, you were using cutting edge information flow tech to date. But then since then, this work has been pulled along, and right now there's probably over $1 billion going into this field over the last couple of years alone. Very exciting stuff. So what are some 3 key directions in this field that we can really pull together and work on? One of them is, if you look at HIPAA certifications, I just pointed out one of the papers that's relevant here. All these standards really talk about, you have to formally define the notion of customer data. But really, this is a probabilistic definition. It's not just PII as in email. All emails are not PII. Emails with different things, but also not belonging to my same company. What's the confidence interval do I have that this particular data set is clinical trials, genomic data, and so on? So there's a definition of customer information that needs to be happening. There's a definition of, okay, who's a business partner, what type of business partners. So there's a huge opportunity in taking kind of plain English natural language statements or half legalese type of statements and turning them into an intermediate representation that is much more formal and verifiable and has much neater properties. And you could build separate LLMs that are checker LLMs compared to the ones that are actually doing the translation. And that could be huge because one example on the bottom right over there is just regular propositional calculus, but there's work around more full-featured languages like AWS has started Cedar as a programming language. For authorization, we should extend that into information flow control languages. So that would be pretty cool area to work on. This is under how do you specify the policies? Another one is once you are specifying the policies, your organization has to respond to the space. So whenever we talk about identity and access management, IAM in textbooks and manuals, the pictures look like what you see on the top right, which is like, hey, there's a user, there's a group, there's a role, there's a graph, and it looks pretty straightforward. It's almost like what problem is even here? In practice, that mosh pit that I showed you before, if I lay it out on there, that's what it looks like. A user gets access to a role through which you get access to a group, through which you get access to more users, and you keep circling back, and it gets really hard to even figure out how do I start refactoring that graph? Because you can't boil the ocean all at once. You can't reconstruct from scratch. You have to incrementally move this to a different, better spot. So Mikhail, who is here in the audience, or at least here in the venue, he's been working on how do you incrementally repair these IAM graphs. And the key insight here, one of the findings was in graphs, IAM graphs as they exist today, you only need to be able to compromise 3 to 5 carefully chosen identity types to be able to compromise the entire network, or 60 to 80% of the network. It almost means that like on the cloud, you're driving super close to the edge of compromise as things stand today. And things like cat group, whatever, should not be a surprise. Another direction that aligns really well, this is where Leo and we've been interfacing for the last several years, is it's not just natural language, but there's a visual interpretation of what your environment looks like. So this is from a customer environment where you can see they started off in the same graph on the top left in January, and just by the security team showcasing the problems to the different BUs, the BUs self-corrected their own permissions and entitlements. Now you're actually adding some, not even teeth, but just visibility into access entitlements cleanup. And over the year, you can see that you ended up with a much cleaner pond, whereas or lake, when you started off with a really messy, cobwebbed, like unused permissions lake in January. And you don't need to be an IAM expert to know that thing in December is much better and cleaner than the one in January. There's another problem that I think is super compelling. One is when you have an environment, so one of the big problems is, hey, I have to deploy a ton of service roles belonging to vendors in my cloud environment. They have partial visibility into my environment. And how do you certify third-party risk? Like, what's the attack surface? So the problem is really of like, given some partial information about the graph, how would you run MITRE ATT&CK style, like multi-stage processes? And you only get a few shots at measuring the environment because you don't want to be too loud, or sometimes these APIs themselves are very rate limited. So how do you use machine learning or reinforcement learning? So there's some papers references here to figure out how to escalate your privileges, even if you start off with a ostensibly lower privilege role. So these are 3 really interesting directions to work on. And the key kind of takeaway that I want to leave you with is, on the left is the recommended Microsoft direction for how you should onboard Copilot safely. There's this beautiful Gantt chart waterfall diagram of discover and identify sensitive business data. This is step 1. If you have 30,000 buckets and 900 petabytes, your step 1 is just never going to end, right? So instead, this model of onboard slowly and do a bunch of hard things perfectly, what we propose is you have to think of these as, these are 3 concurrent axes that you have to spiral out on, right? As opposed to solve one thing at a time and then move on. So really, it makes no sense to say, scan every byte and figure out what I have, and I have my data inventory, then I will do the next step and so on. You have to almost probabilistically scan the content, permissions, and how it's used all together to improve risk starting quickly. So I'll pit stop here to say that our whole vision really here is that you want to have a domain-specific stack where people who understand the business context most they have a natural interface that goes to an IR, goes to a synthesis tool that just generates it out for different data stores. And if we do this, hopefully the mosh pit, and on the right is a different customer environment that's done a really great job of incrementally fixing their environment. So you can see there are really nice clusters of environments with drawbridges going out of data flows. I will hit stop.
Yeah, we have time for. We have time for one or two questions.
Yes, please.
So this is great if you can get the data of what you have, how things are connected, but like most places they won't even well, not most places, but a lot of places don't have that data. It's really hard for them to collect it. So
That's
how do you deal with that?
So it's easier to do this on the cloud, because on the cloud, you have all these data stores with varying levels of difficulty. The biggest thing here is there are some data stores on each cloud. So S3 on Amazon, BigQuery on Google, and blob stores, etc. on Azure, where A, you can start quickly, you can get org-wide permissions, and B, you can show value. Once you've seen value, and these act as sort of like the messaging buses, kind of like, kind of watering holes for different transactional data stores. Once you've seen value, now there's a lot more momentum to be like, hey, let me go wire up the RDS environment and the Dynamo and different BUs, etc. So momentum is the answer, really. Thank you so much.
Yeah, I am in zero trust and identity, or like, at least for us when we do a lot of government work, like that's like one of the hottest things, and doing AI on it is like, I don't know, I recommend talking about it after. Like for us, we've seen a lot of interest here. I want to introduce our next speaker here. I want to make sure, as part of the representation of speakers today, kind of like how we had Josh from the Llama 3 purple teaming team, I want to have somebody more on the side of actually doing some of the more kind of like, honestly, like hardcore LLM stuff in terms of, you know, if you think about autonomous agents, autonomous hunting, something like, can you do multi-steps and sequences of these agents at the model level? When it does make one of those steps, is it actually doing the right function call? And so it's actually one of the kind of rising stars at Berkeley. It's kind of an honor to have Jin Tao. Am I pronouncing that right?
Yes.
Yeah, so Jin Tao here. So that I'll let you take over.
Thank you so much, Leo. Really excited to be here, everyone. So my name is Jian Tao. I'm a CEO of Nexusflow. We founded the company last year. Our focus on building enterprise-grade GenAI software agents. Today, I'll be going over the technology and also the vision. It's very slow. Okay. So what do I mean by GenAI agents? So in the company, we focus on the tasks that require interactive decision-making with natural language queries. In particular, when the task is complex. Here's one example in the consumer setting, but you can also think about similar examples in the enterprise case. For example, you talk to a dashboard, you have to take actions, conducting search. You may be asking a question, I want to go to concert hall in San Francisco, I visited last time, and pick up my son along the way. And agents not only can talk to you, agent also has access to all the tools available in your systems. In terms of enterprise use cases, maybe the APIs and dashboards. And it's able to answer the question, produce the final summary. But what's really happening under the hood should be really this complex function call. So basically, without explicitly interacting with agent round by round, the agent's supposed to come up with this plan. We call it micro plan to get location, get ID, get last visited places, put everything together into the navigation function so that you can just get the final results. For this, we call it complex instruction following and tool use in a safe and helpful way. By safe helpful, it also refers to the answering style of the agents. So why we want to start the company was that last year we started interacting with lots of enterprise customers. At that time, they were starting to build their agents using GPT-4. In particular, when they saw that they had to use GPT-4 because only GPT-4 has the reasoning capability to actually conduct those kind of tasks. They came to us, they felt that even with GPT-4, they cannot get sufficient success rate for these complex use cases. So these are very good engineers who try to decompose a problem, solve the problem step by step. Then they found that, first of all, has incurred a very, very large latency. 30 seconds is even lower bound, easily goes to 1 minute. Sometimes extreme case, customer told us that it takes them 10 minutes to finish one query and final result is still wrong. So basically, while it's the design principle that if you fail, you fail fast. So it's a disaster. And another key issue they found is a hallucination. So basically, you give GPT-4 a set of tools, you say, well, those are the APIs in my dashboard, then please answer the query. But GPT-4 sometimes will think that there's another tool and can see in the training data that answer the query better. Just call that tool didn't exist in your system. The system will just break. So basically, to build everything into production, we need very accurate comprehension, very high success rates, minimal hallucination, high reliability, and also very minimal latency. So how did we really solve the problem? At that time, we don't even have GPT-4. Actually, we don't even have Llama 3. We only have Llama 2 at that time, which is actually significantly worse than GPT-4, both in terms of coding and also like the creative content generation. So one observation we made at very early days is that, especially for smaller models, there appears to be a trade-off between two reasoning capabilities. One we call extractive reasoning, which refers to the reliable synthesis of intentions. For example, I asked my Gen agents, I want to navigate to San Francisco Symphony and pick up my son. I don't really need the model to hallucinate and create lots of fancy stuff. It's just supposed to faithfully execute my plan. But there will also be other use cases. For example, I indeed need a large language model to hallucinate. For example, let me please write a poem. Then in particular, the poem has never been seen maybe in the training set. The model really is supposed to write it. So basically, GPT-4 is in a dilemma because in settings where we want it to really only read our documentation, we do not want it to hallucinate. In settings where we want it to hallucinate, it really needs to hallucinate really well. It really appears that even for GPT-4 size, the model finds it difficult. It cannot faithfully execute the instructions. So what we did is that we have separated these two capabilities. So we trained a model called NextDriven V213B, which is open source model you can actually download. Really excelled at extract reasoning. Actually, in the benchmark we have built, focusing enterprise complex tool use cases. In particular, we use the real technical software from the cybersecurity industry to show that the model, without seeing the software at all, is surpassing GPT-4 in these complex use cases. It's very strong in exact reasoning, but in abstract reasoning, we have built another model called Starling 7B. Actually, before Llama 3 came, Llama 3 is also 8B, not exactly 7B. Till today, it's still the best 7B chat model in the most recognized human eval leaderboard, Chatbot Arena, surpassing lots of models of significantly larger sizes. For example, even Llama 270B, and roughly on par with Mixtral 8 and 7B, and better than Gemini Pro, and also a few versions of GPT 2.5. So in today's discussion, I'll be going over some technical details of these models. So basically, two models I want to go over in today's discussion. One is this Raven model, focusing on complex software tool use. Second one is the Starling model, which we trained to really enhance human preference. That's the reason why in Chatbot Arena, for those of you who are not familiar with Chatbot Arena, the way it works is that a user can submit a query, and then Arena will present you with two responses from two anonymous models. And you will pick which one answered better. So we don't really know which model was picked. Seems that we have gone offline. Okay. Okay, sorry about that. So we will talk about how we really boost the human preference. So first of all, on this tool-use model, so what exactly do we mean by tool use? There are many settings of tool uses. Actually, these are also not exhaustive. The simple case might be single tool API. Here's extremely simple example. I want to recommend some concerts. You get a function called get recommendation. Very simple. You ask any model, essentially in the world, they can all do it. So this use as benchmark is not actually very meaningful. Parallel to use cases is also very important. For example, you want to recommend both concert and museum. I'm supposed to call two functions in parallel and also execute them in parallel so that it's very efficient. And the hardest one is the nested tools. Actually, for that, you should view this as generating a microplan because you have many tools in your environment. You're supposed to compose the tools together and form a plan. That also is consistent with our general thesis, which is that we really think of human tool use. We use tools not really because we have like 1 billion tools in our repository. It's really because we have a few, but we human beings are very smart. We know how to compose them together. So the model needs to really figure out how to really come up with the plan. We curate this benchmark for zero-shot tool use, exhibiting 7% high accuracy for the hard cases for parallel and nested function calls than GPT-4. With a significant model, smaller model size, it's only 13 billion parameters. So the main rationale behind this is that we start from Colama 13b, which is actually not quite usable for this task. If you ask even simple questions for tool use, cannot really answer. We added very large scale instruction tuning data to tune for tool use reliability, and it was able to surpass GPT-4 for these complex cases. Actually, for simple cases, it's not really surpass GPT-4 because simple cases actually GPT-4 is very good, and we are actually didn't really focus on in that case. So this plot to us is also quite interesting because Colama itself, abstract reasoning is way worse than GPT-4, and even after our tuning is still way worse. But we don't really care about this because our focus is on this extractive reasoning. For that, this model is very better to be used as an intermediate component for your agent systems. This generally consists of many components, not only a single model. So there's some details about this benchmark. We have collected many different technical software. So there's VirusTotal, VT. There's also this NVD library. Those are actually very challenging softwares. In particular, easily has 20 different arguments. You ask any model in the world, it just cannot answer the question. So turns out it's for this challenging technical softwares, we perform really well. So that through building the benchmark, we also learned that we really need to create the benchmarks such that it can easily differentiate different models. If all the models are behaving similarly, it means maybe the benchmark is meaningless. So these are very challenging cases. The benchmark is open source, so feel free to check it out and give us some feedback. So after the model was published, we were very excited to see that there's actually another third-party evaluation of the model. Actually also comparing the model with GPT 3.5 and GPT-4. It's quite interesting evaluation because it exactly tackles one key issue in tool use, which is that suppose you give the model a set of tools, ask model to accomplish a task. Did the model really read your documentation, or the model was basically using its training data to guess what these tools are for? In that case, it's going to be really problematic because maybe your tools are actually different from the tools the model has seen in the training data. So in this paper, what they did is that they created a set of tools, but they perturbed the tool names and those argument names. So basically, if you follow the tool descriptions of the tools in your training data, you would have made a mistake because I've actually changed the tool name, mapped to another tool, and changed the argument names. So it's just in this data set, our performance is significantly better than GPT-4, GPT 3.5, achieved 0 hallucinations because GPT-4 can just hallucinate a tool that didn't actually exist in the system. Of course, GPT 3.5 would hallucinate even more. And if you think in terms of accuracies, even for the single function calls, actually I mentioned for single function calls, our performance in general is not as good as GPT-4. But this is a very hard case because we have distorted function names. In this case, GPT-4 will degrade because it was hallucinating based on its training data. It actually appears that we do not really hallucinate because we have done things so much high quality training data in the model. So the model really follows the re-instruction very well. So after we release the model gets very exciting feedback from the community. It's the highest downloaded model on function calling. The support from Meta, the shout outs, and also from peer startups, also from developers. Quite a few people are saying that they have completely kicked out the OpenAI function calling API and use our model to serve their whole business. How much time is left? So maybe one more thing I want to talk about is this Starling model on this RSchip pipeline. So Starling focus on different capability, which is chat capability. Basically, it really wants to make sure, given the same set of technical capabilities, I chat with you, you just feel it's very helpful and very harmless. So we train the model, we put the model on Chatbot Arena. It appears to be very competitive compared to those very large ones. Till today is still the best one for 7B size, if you do not consider Llama 3 8B. And the key idea behind this will be some new RSchip algorithms we have developed. Actually, some papers are already published, some others are still under review. It's a new approach. So that's basically what I'm sure. Thank you.
I don't know. Sorry. We have time for a couple of questions while our next speaker sets up. Yeah, we've got a.
I have a probably dumb question. I don't know the answer to it, but I think I like your kind of philosophy of having this continuum of sort of abstract and more expressive. I was wondering, have you tried something like trying to control where GPT-4 sits on that continuum just by telling it don't hallucinate or hallucinate wildly or something like that? And could you just imagine one model that you could just control where it sits on that, rather than trying to train two separate models?
Yeah, this is a very, very, very good question. So actually, we're still trying to pursue that direction. At least for GPT-4 itself, we found that in these very challenging cases, we tell GPT-4 so explicitly, please do not do that. It cannot follow the instruction because it's we got too high cognitive load on the model. The model just cannot do it. But what we found that maybe there are other approaches. Maybe first of all, you train those separate models. There will be certain ways you can merge the model together. Then maybe it's even better than GPT-4 because the key issue is that when GPT-4 was trained, it was not trained to strengthen those two capabilities first, then merged. It's training a different way. Maybe a new way of training could actually solve the problem. But the fact is that till today, GPT-4 isn't perfect, even compared to those smaller models.
You're thinking of like merge of those two extremes.
Yeah.
So maybe like a follow-up question to that would be, do you think like it's actually the core fine-tuning that's like problem here? You've really got to actually go and do like a full model rebuild to get it not to hallucinate, or do you think like because there are different ways you can do it. Which layer do you think you can intervene at, or is it really at the intrinsic core of the model?
That's a very, very good question. I think from a research point of view, we also really haven't completely understood that. We found that even in certain cases, it's really the pre-training bias. It's actually hurting the model. Maybe we need to change pre-training. For that, so we are still exploring. But it's a very, very good question.
Yeah, there's three layers. It's like the core training data, the SFT, and then the human feedback layer. All three layers. I'm just curious how far you've gotten.
Yeah, so definitely we haven't really gone to the pre-training part because that takes so much money to do. But for other parts, turns out to be very important for improving performance.
Just interest of time, because I know we're going to have a lunch between the next speaker. Anyway, so thank you for the speaker again, Jen Tao. So kind of honored to have you be able to make it. I don't even know how to introduce Don. I don't know how many MacArthur Award winners we have, the Genius Award winners in the room, but I know it's at least one. I don't know. I made, for those who don't follow, so for example, symbolic execution for binary analysis. So before program synthesis was cool, she was sort of the OG of that, even before the whole LLM era. Red teaming AI, same thing. So we asked Don to kind of do a little different talks kind of today. So instead of, come talk to her after about all the cool stuff she's doing today and like her latest startup. Like I don't even know what number of startup this is, but today we asked her to be a little more forward looking about like what's going on. So with that.
Great. Yeah. Thanks, Leo. Thanks everyone for being here. Today I'll talk about how will frontier AI change the cybersecurity landscape. And yes, my name is Dong Song. I'm a professor at UC Berkeley. Okay, great. So everyone here is really excited about deploying AI. However, as we deploy AI, it's important to consider the presence of attackers for a number of reasons. So first, history has shown that attackers always follows the footsteps of new technology developments, or sometimes even leads it. And also this time, the stake is even higher with AI. As AI controls more and more systems, attacker will have higher incentives to compromise the systems. And as AI becomes more and more capable, the consequence of misuse by attacker will become more and more severe as well. So just a quick look at the current status in cybersecurity. Everyone here knows that it's not in a good shape. Systems are vulnerable. In general, rules of thumb is every 1,000 lines of code, there are like tens of bugs. And systems are not well maintained, updated, and often misconfigured, and with very low security budget. So as a consequence, there's the attacks continue to grow in number and sophistication. And and also they are causing huge financial losses, with estimates of costing the world close to $10 trillion this year. And also we continue to see really large-scale data breaches where attackers steal sensitive information about hundreds of millions of users or even billions of users in a single attack instance. So without this, the key question is, now with AI in the picture, how will frontier AI change the landscape of cybersecurity? So first, on the left-hand side, we have the traditional cybersecurity setting, where we have the attacker and the defender. And in general, we're dealing with what I call traditional software systems, which here I refer to as symbolic programs that are written by humans. However, with the addition of AI, frontier AI, here's how the picture is going to change on the right-hand side, where attackers are going to be facilitated with frontier AI, as well as defenders are going to be facilitated with frontier AI. And also at the same time, what we are dealing with in terms of the software system, now we are going to have a hybrid software system. So we are continue to have symbolic programs, and these will be partially written by humans and partially written by AI. And in addition, we'll have significant part of the system to be what I call non-symbolic programs. So these are essentially neural networks, AI models, which actually later on we'll see, which actually are very different in terms of analyzing these programs in contrast to the symbolic programs. So one key question here is, as frontier AI will help both attackers and defender side. So who is going to win? Is it going to help the attacker side more or the defender side more? So that's a key question that we're going to explore in today's talk. So when we look at this question, how will AI change the landscape of cybersecurity? Here we are going to actually look at several different camps of issues. So the first one is how attackers is going to attack AI, in particular attacking this hybrid system that I mentioned with these non-symbolic programs with the AI components. So attackers, when attackers attack AI, they can attack several aspects of AI. One is integrity, where attackers can cause the learning systems to not produce the intended or correct results, and sometimes even cause it to produce targeted outcome designed by the attacker. Another one is confidentiality. So attackers can essentially attack the AI system to learn sensitive information about individuals and so on. And in order to address these issues, we need to develop stronger security in the learning systems. So the other side of the problem is how the attackers can actually misuse AI to attack other systems. And this includes many different types of ways how attackers can use AI to attack other systems. And also attackers can misuse AI to attack people as well, such as phishing, manipulation, and so on. So in order to address these problems, we need better security in other systems, and also need ways to protect humans better. And the third category is super intelligence. What happens when these models get really, really good? So first, let's look at the first part of how attackers may attack AI. I'll go through just these very quickly. And the first aspect is how attackers can attack the integrity of these AI systems. And one of the most common issues that we are dealing with is called adversary example. So essentially, attackers can manipulate the inputs to these machine learning models, sometimes adding very small, imperceptible perturbations even to some to the inputs. To humans, it may not make any difference, but to the machine learning models, it will fool the machine learning models to give the wrong results. And Magnus' work and others' work have really shown that adversarial examples are prevalent in essentially all types of deep learning systems for all types of tasks. And also, the number of papers in the space has grown exponentially as well. And some of our earlier work also is the first to demonstrate that you can have robust adversarial examples in the physical world as well. And we have the rare privilege and honor to have our the artifact of our research now is actually part of the permanent collection at the Science Museum of London. So as a computer science researcher, this is a very rare privilege and honor. And so when we look at large language models, even when they are safety aligned, unfortunately, they are easily attacked as well. So some of our recent work, this is a decoding trust. Today, later at towards the end of the comprehensive the workshop, you will hear more details about this. With my collaborator Bo, who's going to talk more about this. So decoding trust is the first comprehensive evaluation framework for trustworthiness of large language models. And this actually won the Best Paper Award at NeurIPS in December. And this comprehensive evaluation framework actually evaluates many different perspectives for trustworthiness of large language models, including adversarial robustness, toxicity, fairness, and others. And the evaluation basically shows that today's large language models, they can very easily be attacked and have many different types of risks. And given the interest of time, I won't have time to go into it. And also others have shown recently as well that these large language models, even when you just do fine-tuning, either with adversarial fine-tuning or even benign fine-tuning, these safety aligned LLMs can easily be unaligned and be easily jailbroken and so on. So that's the integrity aspect, how attackers can attack the integrity of the machine learning models. And this actually can happen at multiple stages. So what I have shown is at the inference stage that we call adversarial examples, and also with LLMs, you can do prompt engineering with jailbreak and so on. So another stage is attacker can also attack the integrity of the model at pre-training or even a fine-tuning stage through what we call data poisoning, basically by injecting the data points with, for example, points and labels and so on. So our work, earlier work actually was the first to actually illustrate that through data poisoning attack, you can inject these backdoors into the model that's really stealthy. So in this case, what we demonstrated is that for this facial recognition system, so anyone who wears this particular type of glass will cause the system to misrecognize the person to a particular target. And in the other cases, the system will behave correctly. And also in recent work by Anthropic, they have shown that you can do similar backdoor injection in large language models as well with the sleeper agents, where the attacker caused the model to behave such that only when certain trigger words, trigger phrases happens, the model will inject essentially vulnerability in generated code. Otherwise, it will behave normally. So all these are different types of attacks on integrity of the model. And these adversarial attacks, again, as I shown, they actually have, the whole community has been making rapid progress in developing various new attack methods. Nowadays, almost every day you can see new attack methods coming up. But however, in contrast to this rapid progress in new attack methods, progress on adversarial defenses has been extremely slow. So essentially, the community almost made close to zero progress in adversarial defense. And today, we do not have effective general adversarial defenses. So this causes a particular, huge issue in deploying AI and also in ensuring AI safety. So current AI alignment mechanisms, as I have shown, they are very easily evaded by adversarial attacks. And any effective AI safety mechanisms essentially need to be resilient against adversarial attacks. And thus, essentially solving adversary robustness in some sense is a prerequisite to achieve AI safety. However, unfortunately, as what I've shown, this has been an extremely challenging task. So as one step forward, I just wanted to briefly mention some of our recent work. So this is called representation engineering, which is a top-down approach for, you can call it for interpretability. And in this case, again, I won't have time to go into the details. So we develop methods in this essentially contrastive learning approach, where the attacker, in this case, the user can, by observing the activations in the model from given inputs, it can actually build models, and these models can so in the representation reading user setting, we show that these models can essentially tell us help discover along certain directions for the model activation can actually help us to understand or predict the behaviors of the model. For example, whether the model is lying or whether the model is hallucinating or is doing deception and so on. So this is representative reading. And then another new capability that our approach has introduced is called representation control, where by changing the model activation along certain identified directions, we show that we can actually modify the model behaviors, for example, making the model more honest or less honest. So this, I think, is a really exciting and promising direction for actually enhancing AI safety for models, because this actually is one of the very rare cases where the artificial neural networks actually, in comparison to the human brain, in this case, for the artificial neural networks, will have full transparency, visibility, and control. So, so if we can do real-time control, modifying the through modifying, for example, activations to modify the controls of the behaviors, this can give us a more powerful arsenal for enhancing AI safety. So that's on integrity side. So now I'm going to briefly talk about how the attacker could attack the confidentiality and privacy aspect of the AI models. So our work was the first to show that attackers, by actually simply just querying the large language models, querying a language model, it can, by devising novel attacks, it actually can learn sensitive information about the training data used to train the model. For example, in our work, we show you can extract personal identifiable information, social security numbers, credit card numbers, and so on. And also our work earlier proposed a measure called exposure to measure the degree of memorization of these models, which actually has been used in Google Smart Compose, for example, and others to help improve the privacy of these products. And also others recent work have shown that even for ChatGPT, you can even just give this simple inputs, just a poem, goes many times, it can actually get the model into this weird state that starts to output training data. So, so these are examples illustrating that these large language models, they have huge capacity and they have memorized a lot, and this can really cause huge issues in data privacy. And in practice, this has data privacy now is a huge issue and impediment for AI adoption. So many governments and so on have issued, for example, policies and regulations on the privacy side. And also our recent work, this is the first comprehensive evaluation toolkit for assessing large language model privacy, where we, in a very comprehensive approach, we evaluate a broad spectrum of different types of privacy attacks, including data extraction, membership inference, and so on, and also evaluate across different defenses, including scrubbing, differential privacy, training with differential privacy, machine learning, and so on. So due to time limit, I won't have time to go into all the different learnings from the study. So we actually use our developed privacy evaluation framework. We also evaluated over many different large language models. And so one learning here, just to briefly summarize, we show that all of these models have huge privacy leakage problems. And also one unfortunate issue is that actually it seems that the larger the model is, actually the worse the privacy issue is. So which causes huge problems. Okay, so to summarize, that's the first part of the talk, is how attackers are going to attack AI systems. So now I wanted to also talk about the second part, which is how attackers are going to misuse AI. And so this really leads to the discussion, the question I posed at the beginning is how will frontier AI impact cybersecurity? And in particular, the challenge here is that the AI as a tool, as a technology, is dual use. So it can help both attackers and the defender side. So in order to better understand this question, analyze this question, we need to go through a number of steps. We need to know the enemy and understand the impact of misuse AI in attacks, and understand the asymmetry between defense and offense. And we need to understand the defense and the impact of AI in defenses. And finally, I will summarize and conclude with some lessons and predictions. So first, to know the enemy. So people here are familiar with security, and we know that the security is a really complex domain. There's a complex broad spectrum of different attack incentives, different levels of attack resources, complex attack stages, and broad attack domains and landscape. So for example, attackers have economic incentives, want to have political influence, nation state has the reasons for cyber warfare, and also there are others like surveillance for oppressing dissidents, cyberbullying, and even script kiddies just want fame. And the attackers can have very different levels of resources at nation state level, corporation level, organized crime, or individuals like script kiddie. And when we talk about how AI is going to change for the attacker side, essentially, AI can help all these different levels of attackers with different level of resources at different levels. But in general, it's to bring up the to make things easier for the attacks at all these different levels. And the attacks, there are complex pipelines of attacks, and there's vast attack landscape where ranging from networks, hosts, and different types of applications, and to the cyber physical systems. So cybersecurity is complex, has a complex landscape. So how is AI going to help on the attacker side? So AI can help attackers both to attack machines as well as attacking humans. So helping attackers to attack machines. So our earlier work was the first to actually use deep learning approach to identify vulnerabilities, known vulnerabilities in program binary code using program similarity detection on program binary code. And our work showed that this is really effective and was able to find vulnerabilities in real world code, critical vulnerabilities in real world code. And follow-up work, there's a lot of follow-up work on this as well. And today, this is the state-of-the-art approach in terms of detecting vulnerabilities, known vulnerabilities in binary code. And also, so Josh has already talked about this. These are some similar studies by others as well, essentially illustrating that agents, they are not that good yet, but there's early signs showing that they can automatically attack certain websites, exploit one-day vulnerabilities, and so on. So on the other hand, AI can also help attackers. Actually, today that's even more ready on the social engineering side. And this actually is a huge issue in cybersecurity. So there's estimate showing that over 80% of attacks actually starts with social engineering. And it's widely recognized that the most common cyber threats facing businesses and individuals today is phishing. And so far, we have seen significant increase in phishing emails, and a lot of it is attributed to generative AI. So recent, there's a Hong Kong incident where a financial worker actually wires $25 million to the attacker because the financial worker was in a video call where essentially all the other participants, including his boss, like the CFO, were essentially deepfake. So it was basically in a video call set up by the attacker with all the deepfakes and caused the financial worker to wire the 25 million to the attacker. And attackers also are using GPT to develop automated tools. That's from GPT that attacker claims that it has all sorts of capabilities for sending out phishing emails at scale and others. And it actually claims to have over 3,000 confirmed sales already. And also there's personalized attacks, NCI using GenAI. I'm running out of time. And misuse AI also has been one of the big issues is that really misuse AI can be used for large-scale automated and targeted manipulation and for influencing, for example, election and so on. So this was 2016 election. This is the Cambridge Analytica. Back then, there's no sophisticated AI yet. But today, already we are seeing, for example, there's a deepfake voice cloning telling voters not to vote in the primary, mimicking Biden. And this will just continue to go on. So as a summary, as a consequence, the consequence of misuse AI in attacks is vast. So currently misused AI being used for voice cloning, spear phishing, disinformation, and so on. And misuse frontier AI essentially can help with all stages in attacks, and can automate large-scale attacks, help make attacks more evasive and stealthier, and can increase attacker capabilities and so on. So then one may ask, maybe we don't need to worry, given that yes, AI can help attackers, but AI can also help defenders. So for example, defenders can use AI to discover and fix bugs before attackers. So is this a case? So who is going to benefit more from AI? So unfortunately, I would argue that really frontier AI, they help attackers much more than defenders. So one, we know there's a symmetry between defense and offense. On the offense side, attackers only need to find one attack that works. And however, defenders, to be successful, they need to fix all bugs and prevent all attacks to succeed. And also, oftentimes, cost for a defense is much higher than attacks. So essentially, attackers, they can send these, for example, phishing emails at almost no cost, but actually to do the detection and including network attacks and so on, the cost for defenders is much higher than attacks. And also, even worse, deploying defenses, even when the defense works, actually takes very long time, as we all know. So defenders need to develop fixes when bugs is found. They need to then do a lot of testing and then do deployment globally. So even today, a lot of legacy systems are still not patched. And also, attackers can learn about the vulnerability and generate exploits using publicly available information of patches. As soon as the patches roll out, we have seen in the real world, after even just 1 to 3 days, attackers already have an effective exploit and hence can exploit systems before the other systems actually get to be patched. So this really shows that attackers are on the upper hand with the help of AI. So now I'll just briefly talk about the defense side, then I'll wrap up, because this part actually is interesting and important. So when we look at defenses, so this actually summarizes the progression of my own career of approaches for software security over the last 25 years. And this is essentially how the overall security community has evolved, right? So in the beginning, we all focus on reactive defense. We detect, for example, network intrusions like worms, and then we try to defend again, which will detect worm, detect malware, and so on. So this is what I call reactive defense. So you detect the attack and you try to block the attacks and so on. And then the next stage, we move to proactive defense. So by proactive defense, we try to do the defense before the worms or the malware even occurs. So in this case, for example, finding vulnerabilities in code and then fix them. So that's, I call bug finding for proactive defense. And then the last stage is actually what we really want is proactive defense by secure by construction. Right. So basically, we want to take better, more secure architecture, language programming frameworks with better security support, such that we can build systems with essentially secure by construction with actually provable security guarantees. So now let's look at how AI is going to impact each one of these type of defenses. So first of all, reactive defense. So of course, a frontier AI can help improve attack detection and analysis. Some of our recent work actually use large language models to detect malicious transactions in blockchains that we were able to actually rank some of the real-world attack transactions to be the top anomalous attacks which have actually caused hundreds of millions of dollars of damage in real world. However, I argue that unfortunately there are actually many challenges in this type of defense. So attackers can also use AI to make attacks more evasive, and attack detection actually needs to have very low false positive and low false negative. And attack may happen too fast for effective defense. And hence, I argue here that for this type of defense, reactive defense, AI is going to help attackers more than defender in this type of network anomaly detection and this type of reactive defense. So now let's move to the second type of defense, proactive defense by bug finding. So again, like with AI, frontier AI can help us to do better fuzzy vulnerability detection tools. However, here I argue that so there are again many challenges with this type of defense. So bug finding tools can help both attackers and defenders. Again, as a asymmetry that I mentioned earlier between attack and defense in bug finding, attackers only need to find one vulnerability to succeed, but defenders need to find and patch all vulnerabilities to prevent attacks. And it can cost a lot more to fix a bug and deploy the patch than finding a bug. And hence, I argue that for this type of defense, AI will also help the attackers more than defenders in bug finding. So what this leaves us, the only potential actually effective defense with frontier AI in the scheme is proactive defense with secure by construction. So secure by construction, as I mentioned, is an approach where we architect and build provably secure programs and systems. And again, there are many ways to do this, and an important approach is with the formal verification, where we can formally prove that the software system satisfies certain security properties. And this can be done at many different levels, design level, implementation level, and so on. And also, we actually have been very fortunate that this decade and the last decade has been the era of formally verified systems, where we actually have formally verified systems in many domains, including microkernels, compilers, security protocols, and so on. But however, one issue is that, so these systems, unfortunately, they are not really used in practice. And one main issue is that it's too, so for the formal verification, it requires large manual effort. So it's too labor intensive to do the formal verification, and oftentimes it takes tens of years, proof engineer years to do formal verification for one of these systems. And by the time you do the proof, the system already needs to evolve, and you have to redo the proof and so on. And hence, so one promising direction that I propose here is that we can actually use frontier AI to build these formally verifiable and provably secure systems. So essentially, we talk about agents. For example, AlphaGo, we have deep reinforcement learning agents to train them to learn to play Go. And then agents wins Go, right? But however, can we actually train better agents to do more useful things, in particular, for example, to do automatic theorem proving for programming verification? So my group was one of the first to use deep learning for enhancing theory proving that happened even before this wave of LLM. And the hope is that with this frontier AI, it can make this actually finally possible. And then in this way, combining this with program synthesis, so Josh also talked about, currently the Copilot generates insecure code. And with this approach, our hope is to actually be able to synthesize secure code and provably secure code, where when we generate the code, we actually have a proof attached to the code to show that the code is satisfies certain security properties. So the approach, the advantage of this approach is that now we can use AI to help us both to generate code and proof. And this really reduces the arms race. Provably secure systems is actually the only way forward that can provide resilience against certain classes of attacks. And of course, this approach has many open challenges as well. So formal verification approach, so far it mainly applies to traditional symbolic programs. And it's actually very difficult to apply to non-symbolic programs such as these deep learning models. First of all, we don't even have precisely specified properties and goals. So for example, if we want to say that the self-driving car should not run over a pedestrian, we don't even have a formal specification of what a pedestrian is. And also the formal verification techniques in general, we have not seen much success in applying to these large non-symbolic programs. However, future systems, they are going to be hybrid, and they are going to combine both symbolic and non-symbolic components. So how do we actually take this approach of formal verification and secure construction? It's still huge open challenge.
Hey, Tan, maybe you could do one more point and then what's
Yeah,
after
okay.
lunch?
And the final point. So the other side, so far I've talked about how we need to develop better defense systems to defend against attacks on machines. But I would say that actually the biggest, the weakest point is humans. And humans are the ones that cannot be upgraded. And hence I think, it's true, unfortunately. So that's, so here, actually it's very interesting. Many years ago, we had a project, this is way before LLM. So the goal is that, and I think the only approach, effective approach going forward is that we use AI to help humans. Because humans cannot be upgraded, we need AI assistance to intermediate. Basically, in the future, I do strongly believe that we are going to have AI assistance that's going to intermediate all communication between a person and the external world, either it's to other people or to other AI. And so actually, quite a few years ago, we had a project on using AI chatbots to do this, to help defend against social engineering attacks for humans. But that was long before LLM. So with the development of LLM and so on, so we do hope that this can be an effective approach. And I think, again, like I said, I think this is the only way forward. And finally, super intelligence, I won't actually talk about it. This will just can lead to really catastrophic consequence in cybersecurity. So finally, maybe I'll just conclude with the lesson of prediction. So hopefully I have convinced you. I do strongly believe that the AI will help attackers much more at the beginning. Current systems are highly vulnerable and ill-prepared for AI-assisted attacks, and organizational systems are often only spend efforts and resources after seeing attacks and damages. And as cost of attacks going down, we expect to see unprecedented increase in attacks. And for example, lessons we learned from spam and ScriptKitty, and we're already seeing increasing attacks. So the world was not prepared for the pandemic such as COVID, despite early warning. And I'm hugely concerned that this is where we are today. And attacks assisted with AI can be much worse than what we have seen in the pandemic. So I'll just finally conclude with one lesson that we have learned from the past, the lessons that we've learned from medical devices security. So my group was the first to do the study of medical device security analysis in the public literature, where we show that these medical devices, they have security vulnerabilities that can be exploited by attackers to cause huge harm. And back then, when we did a study in 2011, the FDA's approval process for medical devices did not have any mention of security recommendations. And only, so with our work and also follow-up work from the community, only 5 years later, FDA changed their approval process to require certain, to provide certain guidance and recommendation for the security aspects for medical device. So the lesson here is that the security space is hugely complex, and frontier AI will have huge impact in cybersecurity. It's going to cause significant increase in attacks, and in the near term, AI will help attackers much more. And also, the world is not ready, and the regulations are not prepared, and hence it's important to learn from the past lessons and act now. We need to build and deploy plans to improve security posture to get ready, and we need to build AI solutions and digital assistants to protect humans against AIs and bots, and we need to use AI to help us to build secure systems with provable guarantees. With that, thanks, everyone. Thank you very much.
So just as we're already a bit into the lunch period, I think maybe I encourage you to stick around and ask Dawn questions or chase her down in the lunch area. But yeah, thank you.
Hello? Are you walk? Actually, I understand my speech. That's what I was like. I didn't get a chance to talk to you. Really? Okay. Yeah, people always think very much. My daughter's studying computer science. The other thing I was gonna ask you. Okay. Yeah, I can see that. I can see that. Yeah. Nice to meet you guys. I would ask how. Is there something specific that rotation? Just produces so many people to focus on something. Yeah, exactly. It's very security.
Yeah, I mean, my studying physics. I was a physics undergraduate.
But that's what I correlation is so many security options.
Let's say somebody's like speech or people they can actually count that.
Now they're also.
That's not.
Yeah, I mean, yeah, so, yeah, it's like there's.
Yeah, I was.
Yeah, yeah. Hopefully it's like. No, no,
This is one of the. That's what I was. I go to the RC, this is nice, pretty wise. Like, you know, so what is it on? Yeah, what's something. You missed the talking guy.
From,
Yeah,
yeah,
yeah.
so
That one is.
Yeah, that one's-
Yeah, that one's on, that one's good, yeah, because they kind of say this horse spiral. Once in the morning.
Yeah.
All right, here we go, one more, because this guy and I go way back.
Yeah.
Yeah, so, yeah. So, you wanna know somebody that's innovative in Latin America on the security side is him.
Yes.
He's always.
Yeah.
Or get somebody else, let's give a third person. Yeah, or a selfie, let's just do that, yeah. Let's see if I can get
Can you do it?
Yeah, can I do it? Let's see. If
Oh, you gotta
I
put it.
arms. Let's see, there we go.
All right.
1, 2, 3.
Awesome.
Yeah.
I've been a little busy. I'm trying to make, actually have some of the organizers.
Oh, for Delcom?
Yeah.
The thing is, last year I didn't went to Delcom, my boss don't let me go there anymore, but because he wanted to go to different, the more professional, yeah, professional track he wants. Yeah, it's make me more see something, but I'm sending my team there. I brought 5 guys from my team now, and I'm sending another 5 there from. I'm trying to get them to get a taste of what this is, because in Mexico we don't have any.
Yeah, so I used to watch my talk, like, there's like, the big theme of our work right now is like, you know, it's cool if we can go to like some banks, get their security data scientists and that stuff, but that's not really. Not many people can do that. So like, the big thing is like, using a Gen AI, is like, not just like Python. Making that work, so. Yeah, that works, yeah, let's take that going.
Okay. Yeah. I'm gonna go with him, but like, since I also the owner, I'm getting requests, how would I protect? I like I already got that question from the family.
Oh, I see.
They have like.
I live in Boston, so.
This is happening in the high school in Mexico, right? So website is just. Yeah, no, I got. You know, yeah. No, but we already have the fintech side, the third one, you know, the data and all that, yeah, like, now you're learning. Well, no, it's the largest one, we're in Mexico, yeah, we now have a fintech branch. So we have been growing a lot, we sold, most of the other business, now we focus on the retail and the e-com. And now I'm like in CPO people for the physical security. Right. Yeah. I'm not in the SOC anymore. I will go out to the TSO, not the TSO, but the security officer. So, yeah, it's about team actually build that cyber brand for the safety, like how we do that. And also, we're not the physical security for the building, but we didn't do that. So, yeah, and that means all the things. I'm also doing. The work for 3 years, so that we have the same days hours, and I had to do these cybersecurity and the IT. Security physical controls for that, and there's nothing there, so I I mean, it's fun, but so many challenges.
There's actually, so the Blackbird guy and the other one, there's actually a Berkeley startup that's doing sort of good stuff. Where they're actually doing, like, I think it's like actually on the app level, where it's like actually more of like almost like, you don't have to talk about like the fire standard. Yeah, well, it's like what's your social media, like exposure, yeah.
When we started with the third modeling for the world with Dale, we got from many other.
Yeah, how long ago?
Yeah, I'm sorry. Yeah, like, how do you want to knowing the directive of the while the game is played? What? Do I have to do that? I mean, how many people, track that? Working. Yes.
You didn't send, you're doing your own laptop, right?
I can read there.
Get your laptop, you'll get one. Do you prefer hand mic or
Yeah, Mike's fine.
okay, we got both.
I'll sit. It's just.
Okay, yeah, so we can get your laptop here. Are you worried about power?
I'm gonna plug in just in case. I should have.
Yeah. You went to Seattle, right?
Yeah, I work out in Seattle.
Of course, you got here for RSA.
Well, I come down.
Yeah, the internet. Your talk is one of the ones that's sort of forward to. Oh, like, right. Like, how do you move? I feel like there's like maturity model levels, like that practice sort of like the.
Yeah. Yeah, I kind of got a little bit about just kind of high level about. Pretty customers, and my kind of observation that I think.
Yeah.
I throw it in.
Yeah. Yeah, we're finding both for the analyst experience, but then also the afterwards. Yeah, it's awesome. It's not like a cool thing that does. Like I was literally talking to him. Prosecutors are afraid to prosecute unless.
Yeah, you can't. If you don't have a chain of custody. Back or something.
Yeah.
So you want me to connect first or try to present through Zoom or?
Yeah, you can do all. And then we'll Great, cool. Yeah, so now we should be video and audio online. So that's a new thing for us this year. So yeah, okay, let me start over. So I'm happy to welcome Brad. Met him years ago on the government side. We're doing some really fascinating and important work there for some pretty important missions. And then he was, I think, the CEO of BlazeGraph. Is the first GPU graph database. So if you saw somewhere this morning, that's sort of kind of the more scalable version, I'd say, of what we're doing now. And since then, Amazon acquired him. So him and
They
team.
acquired my company and the IP. They didn't acquire me.
Not yet. I don't know. Have you seen Jeff Bezos? He's like, but so he became the GM of Amazon Neptune, their scalable cloud managed cloud graph database, and then recently, I think Timescale DB.
Time series, or managed time series database service. So.
Exactly, and then years in the knowledge graph, whatever space, and then now with the whole Gen AI thing blowing up, well, you'll hear why that's so important.
Super. Can everybody hear me in the back? All right. If I start to fade off, jump up and down, wave, throw things at me, and we'll get going. So I think Leo kind of introduced me sufficiently. Thank you. Thanks for the opportunity. I'm here. Let's see if we get to the next slide. Like all of you, I'm here because I think that graphs are awesome. And the reason that they're awesome is because they let people do things with how their data is connected. And so we're going to talk a little bit about that as we go through. Try and get this working. So I run Amazon Neptune, AWS's managed graph database service. I came from BlazeGraph, where we had a GPL v2 open source graph database. I still think the miracle of provisioning a managed service every time someone uses the service. And we have, every day, there are thousands of customers who create tens of thousands of different instances running Neptune. And all of these graphs are used to power important graph use cases. These are the top 4 that we see from our customers: how you represent and model and link information, so knowledge graphs; how you represent identities and customer profiles, profile graphs. Fraud is, of course, a classic space. And then we're going to talk a little bit more about security graphs, which security has been the largest and fastest growing customer segment for us over the last 2 years or so. But before we do that, just kind of my perspective on graphs. When we think about the customers who know they want a graph database, I think about its size is about like this. And if you think about the customers who could benefit from a graph, it's a much bigger space. And it goes much beyond graph databases. And it goes into all different kinds of graph processing. It goes into OLTP databases, OLAP kinds of things, linked data, graph analytics, other kinds of graph analysis. And so when you think about the opportunity to graph the planet, if you will, it's really about this much broader space beyond just being a graph database and all of the ways that customers can use and benefit from a graph. Security is pretty much as old as graphs are in terms of using it. So it's a classic graph problem. Lots of different ways that you can use graphs for security. These are the sort of the top 4 that we see: cloud security posture management, different kinds of exfil detection, identity and access management, various policies and control, more recently, software bill of materials analysis. And there are lots of reasons that you might use a graph. You might use to connect data. Classically, it takes a network to defend a network kinds of pieces. But what I've seen over the last couple of years with a couple of sort of large kind of ISV security vendors, this is Wiz, and we're going to go through a couple of examples, is they're using graphs for all these things, to integrate data, to detect problems and anomalies in the network. But what really differentiates the applications and the way they're doing it is that at the end of it, they use a graph to try and explain findings that are complex. And the graph provides sort of a way that's human understandable and a way for you to take the signal from the noise, if you will, or the millions of findings and say, these are the ones that are important for you to solve for your business because of this context that you've given me. and present it to you. And I think that's really, for me, what's emerged over the last couple of years is really the thing that has differentiated a lot of security applications and the use of graphs for it. There's other ways that you can use graphs for a similar purpose, but that's what I've seen. Jupyter-1 is another example. These all happen to be Neptune customers, of course, but there are many, many others. In their case, they're using a graph to be able to relate the different types of sources, and they provide that same kind of explainability, which we can map between findings and sources and context. CyberArk's doing the same thing, but in the identity space. And so for me, the theme that emerges is graphs for connecting and graphs for explaining things that are otherwise very complicated for people to understand. And so from that side, that's really my insight and my takeaway is that graphs are a fast way for you to explain complex findings that can be validated and grounded. I don't think this is controversial at this point, but I view graphs as a transformational opportunity, or GenAI is a transformational opportunity for graph adoption. Much in the same way we talked about graph databases versus problems that can benefit from a graph. If you look at people who know they understand graphs or think they have a graph problem versus potential problems that can, in the generative AI application space, that can benefit from using a graph in various different ways, it's a much larger space. And for us, it's very exciting because there's a lot more demand on it. So people are really interested in building different kinds of GenAI applications. Yes, it's early. Yes, there's hype. Yes, they don't really understand all the ways to do it. But there's a lot more interest. There's a lot of opportunities for graphs to solve these kinds of problems and make them better. And so, for us, we see it as a really big opportunity in the graph space. Our friends, LLMs, foundational models, they know the language that they've been trained on. They know it to a particular point in time, and then they make predictions. And this can do some pretty amazing things that you guys, I'm sure, all know. But it can also result in them producing things that look awfully reasonable, but are just plain wrong. Vector similarity search, semantic search, also super cool. My first experiences with it were, doing latent semantic indexing a long time ago. And there's lots of other uses for vectors, but it can be a very powerful tool, but it's also opaque. It's also hard to understand just from the vectors why things are matched. It's also hard to understand and explain to someone why two things are related. So the first thing that people often do is they try and use retrieval augmented generation, or RAG. They bring different kinds of external content in the forms of documents and other pieces to try and augment the gaps in what the LLMs know based on the domain that they want. And this can be better. But when you think about the kind of modeling that graphs can provide, it can be very complementary to this, and you can move beyond just sort of a baseline RAG implementation. Knowledge graphs give you the way to represent explicit knowledge. Large language models give you implicit, and they can be very complementary when you combine them. This is a very quick example that we did within some of the services where I am in AWS. And we took across Elasticache, which is our caching service, DocumentDB, which is our managed JSON services, my service. We took a bunch of web content for What's New posts, which are how AWS makes product announcements. And we compared a RAG-based concept, which is what you see on your left, with a graph RAG-based concept, which is what you see on your right. And by using the graph as an organizing structure and being able to make relations across the different sources, we're able to provide a response that's more organized and brings in more context to be able to add to the user. So you end up able to get a better response in some cases. This is sort of a high-level architecture. You may be very familiar with this. about what baseline RAG looks like. And so working from your left-hand side, you have various different data sources. You go through some kind of loading and chunking mechanism. You use a foundational model of your choice to calculate embeddings. Then you have some kind of vector store. And as a user asks questions, you run similarity searches over it and present different results. There's lots of other things that go around in terms of prompting and fine-tuning other pieces, but at a high-level architecture, this is sort of your baseline RAG. Baseline RAG is optimized for local answers based on the information that you provided it. And because it does give you knowledge, it gives you some explicit forms, it can address some of the problems, but it also has some challenges. And you can't necessarily track easily the provenance of the knowledge that was used within baseline RAG. So it can be hard to track the provenance. You're not able to tell the system that some things are reliable and some things are not reliable. So you may be getting a response that's based on things that your organization or the people in your domain don't trust. And there's lots of different hidden relationships that when you make explicit knowledge, you're not able that you're able to take advantage of, but in a baseline concept, you're not. So when you combine graphs, you're able to, with generative AI applications, you're able to enhance them by using the structure that's in the graphs. And this can take a lot of different forms. And in the sort of full disclosure category, we're still learning all of this ourselves, right? So we're trying and experimenting and seeing what works best and what works, where you get good results and where you don't. But the kinds of things you can do, you can build provenance and lineage graphs. You can use various different graph algorithms over your graph to influence how you're combining the information retrieval pieces. You can understand relationships between concepts that co-occur across sources and be able to bring in additional context. And so by combining it with a graph, it opens a lot of different possibilities for you to do things that can improve the retrieval of your applications. One of the things that was a very early application that we did, we launched something that's called Neptune Analytics last year, which is an in-memory database that supports vector storage. And one of the early use cases we had was a large online bookseller was trying to find books that had been posted that had been automatically generated by foundational models, which is a violation of terms and copyrights and all kinds of other different things. And what they did to do that, this is an example, but they started with a graph query to find a particular category, in this case, travel books from Portugal. And then they found various different, using a similarity search, books that were similar to that. And then they went out and did a graph traversal, if you're looking at 2 here, to match the authors to people that they'd flagged through other systems as suspicious. And so they're able to combine the graph traversal, other pieces of metadata that they have in the graph with the vector similarity to get a better result for this particular type of fraud application. So I wanted to share with you sort of our kind of working high-level architecture for what we're calling, or what is called graph RAG. And so if you think about the baseline sort of RAG architecture that we put on, what was really different here starts about in the middle. And so instead of just generating or using a foundational model to create embeddings, you're also doing other things to the content. So you might be doing entity extraction, you might be doing topics mapping, you might be doing link extraction, other kinds of enrichment, graph algorithms. And so as you process that content, you're also building other kinds of graph metadata superstructures around it. And then moving towards the vectors and graph, you're not just storing the vectors, you're also building graphs that you can use for the retrieval process. And then on the far right-hand side, you're able to use that information together. So you're able to find entry points based on topics in the graph. You can find entry points based on similarity searches. You can pull in additional context to do that. And by combining these things in different ways, you're ultimately able to get better responses that are more explainable because they've been grounded in the information that you've either captured or brought your knowledge graph. So we'll go through a couple of quick examples here. So these are, vectors give you things that are associated based on the vector similarity search. And the graph provides you explainable relationships between the sources. Lots and lots of different things here. And we're learning, and what we're doing now is we're publishing out in open source projects and other kinds of events as we learn and provide customers the ways that which techniques give you which results and when should you use which different pieces. The graph itself provides you the context, so it serves as both a source of information and a source of context for doing things like generating prompts and also doing things like pruning responses that you're getting back. And I think one of the big benefits is being able to bring the domain knowledge, that you've modeled in various different forms in knowledge graphs or other pieces, to be able to help direct and make sure that the results that you're getting are matched with what the mission or the goal of your organization is. So if you're interested in learning more or trying more, these are cases of open source frameworks that are available now. They're integrated with several different graph database options for you to try out. We're interested in hearing what you guys find. This is an ongoing piece. We all have a hypothesis that there's some really interesting things here, but nobody knows exactly what the right combination to result is. And so, these are things that you want to try out if you're interested. And, I'd say graphs are awesome. Vectors are awesome. And graphs can provide explainability for similarity. So thank you very much. Appreciate it and happy to finish.
Time for maybe one or two questions here while the next speaker sets up. Yeah, go for it.
So as users interact with these systems, they form like intuitions or some sort of reference points for structure in the graph, a topological invariant type of structure, and start communicating about those concepts in some sort of languages they develop. So I wanted to ask about the role of like contextual language emergence through use of these systems, and also how you think about sparsity in graphs and address that when trying to find explainable features.
I think that's probably more than I can answer in a short piece, but I think that actually we're really at the point where we're more kind of a much more basic questions about if I, for example, do I get better results if I extract and generate a knowledge graph using some kind of entity extraction process or other pieces, or if I bring a knowledge graph that I've curated separately. We're not really even at the point where we can talk about, if I have sparse graphs with different richness and different feature categories, how does that generate the responses? So it's still, I'd say, a little bit early from that perspective. Thank you. Other questions?
Yeah, any preference on particular vector databases?
So question was any preference on vector databases? There's a lot of choices. From an AWS perspective, our position has been that we put vectors. You want vectors in the database you're using already, and so we have vector pgvector in our Postgres databases. OpenSearch serverless has a vector database. Neptune has a vector database. DocumentDB has vector pieces. So we really tried to take a strategy where vectors are almost a data type in some ways, where you want to bring the vector search capability into the database that you're using already.
Awesome. We should probably move to the next speaker. We will have actually a panel with Brad immediately after the current next speaker. So he's actually, out of all of our speakers are very busy people, but if you could find time with Brad, I would strongly encourage it. Yeah, so I'm do you have a mic? Great. Yeah, I'm thrilled to invite the next speaker here. I tried to include a couple of talks today that are kind of a little, there's kind of like domain oriented, but a little outside of what we're used to thinking about as cybersecurity folks. I don't even remember when we met Sean either. I think it was maybe pre-COVID, 2018. And we actually worked a little bit on Project Domino, a COVID misinformation effort, or we were, I think, intersecting through NVIDIA stuff. But for Sean, he's, you know, just look at his LinkedIn. Like, I think National Security Council dealing with disaster response just across the US, Puerto Rico, Katrina, like all that kind of stuff. And since well, I'll let him describe what is going on, but he's been everywhere in the government. And his perspective on pre-Gen AI, just how AI is sort of kind of important for solving problems. And then once Gen AI came in, just kind of put how the government folks are thinking about this in overdrive. And I'll kind of, should let Sean kind of say what that means.
Okay, well, thank you.
Hear me? All right, perfect. All right, so thanks, Leo. Yes, we met through the NVIDIA ecosystem. Disaster Tech is an NVIDIA partner, as well as partner with many other companies working in this space. But really the work that we've done with Graphistry has been tremendous for our national security and for helping states and communities as well as companies respond to crisis. So I'm the founder of the company. As Leo mentioned, I served on the National Security Council. I was director for incident management policy. And so I oversaw the incident disaster portfolio for the President of the United States, supporting everything from nightclub shootings to pipeline incidents to hurricanes and floods and everything between. But I was a Department of Energy employee, so the different perspective that I brought to the NSC staff was working across the national labs. And so something that I had focused on a great deal in my career was scenario development and doing things like understanding risk to the bulk power system or to water systems, and how did those infrastructure systems, based on their interdependencies, create risk to national security or things like disaster responses. And so something that recently just came out last week, NSM, National Security Memorandum 22. It's an update to previous policy, PPD 21, and that's a lot of acronym soup. But what you're seeing in this new policy that's led by the Senior Director for Resilience at the White House is really a focus on risk. And much of the investments that we were making at Department of Energy to try and understand, what were the risks from physical, cyber, and naturally occurring events to our critical infrastructure systems, and what that means for our nation to prepare. So, current state of affairs, and this is what you see. So, I tell folks that my biggest enemy in DC was the Metro. Because if I was requesting or got a request from the White House Situation Room to develop what's called PDB, so the president, or at least then, under the Obama administration, would get bullet points every morning. Like, this is what's going on, right? On all topics from healthcare to diplomacy. And, the way that I had to do business was literally on my BlackBerry, right? Going to different websites and searching all this information, and then compiling that into an email. And that was, not that long ago, 2016, 2015. And if my subway train went under the ground, I lose comms and I'm delaying information to the President of the United States. I mean, that's pretty ridiculous. So I felt that we really needed to get better than this. And, the saying is the fog of war, not having enough information. Well, now we have too much information, and all of that information or data is in a lot of different places where we don't necessarily have access to it. And so, it's what I call the disconnected silos of excellence. Something that we try to achieve is the common operating picture, right? Well, just a small anecdote, the Army Corps of Engineers, who's responsible for, if you're familiar with the National Response Framework, how we respond to disasters as a country, they oversee public works and engineering. And so back in 2012, during Hurricane Sandy, I said, hey, Army Corps, can you provide me a copy of, or access to your common operating picture? And they sent me a PowerPoint slide, right? So the information in that PowerPoint slide or slides are driving hundreds of millions, if not billions of dollars of decisions that affect every single American in the United States. And it's just it's not a way that we need to be doing business. And then certainly the technologies that exist that support crisis management, they're monoliths, they're proprietary, they're legacy systems. They don't work with modern or open architectures. Nothing talks to one another. So that was a challenge. And the bottom line is the bottom line, right? It's all about life safety. It wastes time and money, and what I call the compound interest in complexity, right? So it's taking us forever to solve one problem, and then the next problem arrives, right? And so the stack of problems continue to pile up, not to mention all the other fire drills that you got to put out because, the senator has some, capability in his state, and why didn't you hire my contractor? Why didn't you hire, the people in my district? So you're dealing with all these requests for information that really aren't helping the fight. They're not helping us solve the actual problem of responding to the crisis, but you still have to deal with it anyways. Okay, so what? So what are we doing? So the first, and these are really the 3 pillars that we're focused on: decision superiority, right? Continuously updating in real time. So I mentioned, being on the subway, the metro station, and, I go into the ground, I lose connectivity, and hopefully, the cache saved so that I can, keep that information to provide updates to the White House Situation Room and the president. We need to get rid of that. So in working with cloud-based solutions, and believe me, I do not have the intellectual capacity that you all have in this room. I was a nuclear engineer in the Navy, so I think I'm okay. But I don't know any of this stuff as it relates to large language models. We hire people like that and partner with folks like Leo at Graphistry. But my intent, right, as the practitioner, the guy who wants to problem solve, is to have a system that's continuously updating in real time, where it's not dependent on me, someone who's on the metro, that's at risk of losing service by going underground, right? Where the White House Situation Room can have access to the product, and then anywhere around the world distributed in any operations center, whether it's in Europe, whether it's in Asia Pacific domain, everyone's getting information at the speed of relevance, as the U.S. Northern Command commander likes to say. Having an integrated response into one platform. And so something that Disaster Tech, we're proud to say, is we are now ATO'd for both IL5 and IL6. And what that means to me is that we can provide access to the platform at secret level and unclass. So, and also it's cross-domain. And so between the various cloud providers, each one has a solution: Amazon, Azure, and Google Cloud. I think there's differences on what's available and what isn't. But regardless of who the cloud provider is, I should be able to talk to all those things on both the low side and the high side, because I still want to engage with the Red Cross, but they don't need to know that we're also looking at faction detection, where an adversary might be trying to influence the population about the government's ability to respond effectively. And that's something we saw during the COVID misinformation work that Leo and I worked on. It was pretty obvious and clear that there were key adversaries who were trying to manipulate people's opinions about how the government and how our various institutions were dealing with that crisis. And the last thing that you want to achieve, or something that you want to achieve, I should say, is unity of message, which we clearly failed as a nation. We did not unify our messaging, and all it did was erode confidence in the institutions that citizens rely on. And then the last thing is being able to optimize and automate existing training and doctrine. So if you're familiar with the incident command system, speaking of cybersecurity in the industrial control system space, the International Society of Automation, or ISA, they have a community now called ICS for ICS, which is an incident command system for industrial control systems. What they're doing, right, in 2024, they're sharing PDFs of forms. right? Again, getting back to, you know, this process of siloing information, silos of excellence, we want to get rid of that. Okay, we're not getting rid of the incident command system because the incident command system was actually created in the 70s for wildfire response on how you integrate command and control of state assets, federal assets, or local assets across that larger community. And so that is a well-trained and understood process, but we can use the technology to optimize and automate those things. So we have a platform. It's broken into these 4 major components: exercise management, incident management, our disaster GPT, which is our LLM. And yes, like everybody else, we're getting sued, or at least we got the bad letter, you know, don't use GPT. So that happened. Thanks, OpenAI. But you're going to lose that fight. Anyways, and then disaster tech, we're also integrating Microsoft Teams. I know in this community, you guys are big on Slack, but if you look at the Fortune 500 and if you look at the government as a whole, right, all the government is in Teams. The 90% of the Fortune 500 is in Teams. And so it just made sense for us to integrate into the operating environment that people work in every day. So, you know, the focus of here is the large language model stuff. So I wanted to kind of give you a look into our roadmap. So the first thing we focused on was the what's called SITREPs, or situation reports. So that's resolving the challenge that I had, right, going, you know, under the subway. So having real-time summaries that are updating as the data is coming in. This is something that Graphistry has contributed to our technology stack. We are taking advantage of graph databases to make relationships, right? So if you think about supply chain risk, look what happened in Baltimore, right? The Army did not know that the 2 ships that it had to push out the infantry was in the port of Baltimore, right? And we were actually presenting the solution. We were running the models in real time at the Association of United States Army conference in Huntsville, Alabama. We were able to give them in real time and show these general officers, hey, you know, this is what's happening in Baltimore. Imagine if we had, you know, the inventory and database of all the supply chain information from the Army. We could be able to provide them with different courses of action to say reroute or pivot on how, you know, what types of decisions they would need to make to support the continuity of that mission. In the second piece is role-based chat summary. So similar, just an extension into Teams. Okay, we want to reduce the training overhead. You know, if folks are in Teams, they know how to just open up a chat client, ask a question. The same types of capabilities for that that chat summary is inside of Teams as well. Something else we're working on right now, and we're about to deploy it, is SOP analysis. And this is where graph databases, I think, are extremely powerful, because think about all of that unstructured data and all these SOPs that have written, you know, for years, like area contingency plans that are for oil spill response. Okay, those companies that operate those oil rigs like BP or Chevron, they're required by law to follow the incident command system process. But the way it currently works today is they have, you know, these volumes of plans that are 500, 600 pages long, and they have to make sense of it. And one of the problems they're experiencing in the industry is knowledge drain. People are retiring, right? And so this provides an opportunity to not only get to the answers faster, where the large language models can, you know, can read through all the plans, start to, you know, make, you know, reason through those plans and say things like, okay, it's this location, it's this type of oil spill, it's this type of product. Let's do the ocean models. Let's see where the trajectory of that oil spill is going to go. What resources at risk, right? These birds, these estuaries, the environmental impacts, social, economic impacts, then automatically generate the plan. And we've already proven this out. And this is part of our work with the United States Army that we're working with Leo, because you may be aware that the Army, through Army Northern Command, they're responsible for supporting states if there was ever a federally declared disaster, which they're happening all the time. Being able to provide those commanders with quick understanding of what's going on, and then to provide recommendations on what to do on handling the crisis. And then the next piece on our roadmap is for exercises and simulations. And so imagine where you can just basically say, all right, I want to run an oil spill response. I want to do it in the Gulf of Mexico. I want to, engage these companies and these agencies. Okay, create the exercise, right? And in a click of a button, normally, and this is just my experience as an exercise professional, the Department of Defense takes on average 18 months to plan an exercise. What if we could shorten that decision cycle from 18 months to a click of a button, right? Think about the savings in overhead and time with respect to just shortening the amount of time that it takes to create the exercise. And oh, by the way, not only do we shorten the time to plan the exercise, but we can actually do the exercise more over and over, right? Something else that's a problem is the after action review. And I don't know if you're familiar with the term AAR, but if you go to this website, it's called HSDL, it's part of the Naval Postgraduate School, Homeland Security Digital Library. There are tens of thousands of after action reports from all these different exercises, from fixed nuclear facility incidents to oil spills to hurricane responses, whatever, both real world and simulated. And it just sits there in this database. And nobody is understanding what are those cross-cutting findings. The United States has invested billions of dollars in post 9/11 money for investing in security and resilience initiatives. But what New York City learns in an exercise doesn't translate to what happens in Indianapolis or doesn't translate to Seattle. That's a problem. Again, going back to those silos, we're siloing the learnings from those events and not distributing that knowledge across the broader enterprise. And then the last thing that we're working on is digital twins. So I actually had a phone call today where Cook County and the city of Chicago is interested in, hey, well, the bridge incident in Baltimore, what if we're able to do a digital twin, like a 3D representation of the community, and then run those simulations to see, hey, if the bridge incident happened here, what would those cascading effects be to the community, and how would that affect the state's ability to not only respond to the crisis, but also how does that affect the broader mission, whether it's Department of Defense or local commerce. So I think I'm good on time. That's the last slide. So questions or wait for the finale? What would you like me to do?
Yeah, let's do questions. Like, it's rare to have somebody who's like on the National Security Council dealing with your most important disasters. So if you need reassurance, this is your time. Maybe for me is like, what do you think is sort of like, if you're gonna have like a US government official just do like pick one area for Gen AI to like put their dollars, put their time, like cut the red tape, like where would you kind of encourage the government?
Yeah, so I think the point about the after action review and lessons learned, the main finding, in my opinion, from the post 9/11 report, the congressional report, it was the term failure to imagine, right? And it's that failure to imagine which caught us off guard. And I think that if we had the ability to sift through all of this data of learnings from all of these past events and exercises, it would help us at least lift up into the narrative what the problems are, so we don't fail to imagine for future incidents. So I think that's, to me, where I see the biggest gap and biggest value, I should say. The other would be what I mentioned earlier about critical infrastructure analysis. I mean, those are complex problems, right? Being able to simulate, okay, if we had a cyber attack on an industrial control system that controls part of the bulk power system in the Western Interconnect in the Pacific Northwest, how would just that one cyber event that causes a physical effect on the bulk power system cascade into failures across the other critical infrastructures that depend on those power systems? And so I think that's an area of interest where I see a lot of benefit from this.
Awesome. Yeah, well, thank you, Sean.
Yeah, I got a question.
Yes, sir.
Yeah, what about partnerships with our allies? Have you learned anything from them and brought that in to help with your day-to-day?
Yeah, so we're in conversations with the Canadians and the Australians. And so you may be familiar with the term 5I, which those 5 countries. I personally have done exercise development, scenario development for cyber incident response with the UK government. But again, we're all working off of different systems. And so just like the problem that's systemic here is systemic there. You know, all that knowledge gets trapped into, you know, databases within databases and is not transferable across geographic lines.
Are there any talks of unifying or having one system that helps?
Well, that's what we're trying to do. That's the whole purpose of the company, right? So, but
But
yeah,
the
go ahead.
feedback from those, you know, allies, are they a little reluctant on coming in? Like, what's the friction?
No, I don't think, it's particularly with the 5i community, I don't think there's any reluctance or friction. Where we're also seeing good collaboration is in the Pacific AOR, air responsibility. Particularly when you think about humanitarian assistance and disaster relief, right? It's a friendly area where we can work together and cooperate to build relationships and allies. And I think, again, you know, thinking about a typhoon that hits the Philippines, you know, that's a scenario that, you know, nothing to do with national security, but it's a scenario that continues to happen where we can use a platform like this to bring in those partners into a unified front. Yes.
So as you start modeling using these systems, thinking like Frontier's products, and you consider the adversary trying to model it. What are you thinking about, like, also in steganography or like getting into information channels, security, information security, knowing there's nothing in stream?
Yeah, I think that's essential. So the question was related to, you know, not giving the adversary an upper hand. But that's why, again, I mentioned earlier, the IL6, IL5, that's just an example, you know, that cross-domain solution being able to share and do things like tier lining. So you can, you know, have the unclassified stuff that can go to the broader community to be able to have information to share and help make decision across the whole operating environment. But having another spot where, you know, we can keep some of those things, especially assessments of gaps, to protect that.
Awesome. So we probably have more questions for Sean. We're actually about to shift into a panel where we'll probably get even more of his thoughts. So you can probably actually just turn. Yeah, stop your share. Great. So I want to, can we bring Brad, Sean, and I actually want to introduce our other last panelists, so Brennan. So I think folks remember Brad from Amazon, the GM of Neptune. If you're just tuning in, Sean, former National Security Council, current CEO of Disaster Tech. But I want to introduce Brendan as well. We'll get the seat.
Yeah, sure. Put me on the hot seat.
So I'll figure out the chair. Yeah, let's go for it. But so Brennan, I think we also go back many years to
2017.
say you're at Bloomberg.
Yeah.
So I think Brennan's been at 4 or 5 different banks doing cybersecurity: Bloomberg, Goldman, HSBC, JPMC,
yep,
and New York Fed.
And New York Fed.
Yeah, BlockFi, RIP. But a good track record of keeping most banks alive. But I think most latest at HSBC, you're part of like actually they're kind of like cybersecurity AI innovation and kind of part of that rollout of Gen AI and the kind of AI tools at the bank. And now you're CTO of Skidaway.
Correct.
And maybe actually you can say something about that.
Sure. We're in stealth right now, but of course, AI for cybersecurity defense. We'll focus on logs and anomaly detection. Leave it at that. If you guys are going to Black Hat, I'll have more to share.
Yeah, and I think we might have a demo area later today
Yes.
during one of the breaks where
Yeah,
you'll be
thank
able
you
to.
for the plug.
Yeah. Okay, so and I'll just moderate this, and again, folks tuning in, Leo, founder of Graphistry, and check out Louis.ai, where we're trying to make all the cool GPU graph stuff kind of in databases and whatever more accessible. So I was gonna go through a few questions with folks on the panel, and then also for folks in the audience. I know it's been very one way for a lot of today, so this is also a chance we can kind of loosen it up. So the broad theme of this channel is, of this session is Gen AI for security. So kind of ways that we could help the blue team when I kind of like having Brennan for cybersecurity, Sean for kind of broader notions of security like national defense, and then Brad is just sort of like, the infrastructure powering all of us to do this stuff. So I thought it was kind of a good group. So Sean actually kind of answered the first question already. So which was, where is Gen AI most useful for defenders this next year, and where should they be investing, if anywhere? So I think Sean just had a great answer. But I'm wondering, Brennan, speaking for.
Yeah, so AI investment, right, for kind of a roadmap. And it's different for everybody. I'm familiar with the banks. But I get this question quite a bit, especially for like small business, right? And I would start at your data maturity, like just do a self-assessment on where you are, right? And you've got to walk before you fly with AI, right? So data infrastructure, and this is what I've done at the banks the last 10 years or so, is starting from scratch, right? And building out that data infrastructure, which is the foundation, right? And then once you evolve, you get into some cleaner data that you can then use for some metrics, then analytics, and then some AI. But that takes some time and kind of a self-awareness of where you are as a company, and building that fabric of being data-driven organization will help you get to the AI, but it's gonna take some time.
Awesome. Yeah, and I think I wanted to take that one too from the Louis.ai perspective. So we've been doing like some of the most wild AI stuff, like graph neural networks, like manifold learning, also like we were doing like LLMs when they're kind of baby LLMs, I don't know what to call them, but like that was always like kind of like you kind of get a sense of some of the speakers, like some of the more, if like somebody has $1 billion budget for cybersecurity, what we could do with them is a little different than if somebody has $20,000, right? And so for us, as folks are starting to look at the Gen AI, what we kind of realize is like, okay, if you don't have a database, you don't have like, Splunk or something or Elastic, okay, that's the starting point. There's actually a lot of companies who still don't. So before any of this matters, I think they just need a database, right? But like once they start having a database, like I think it's actually almost segues what I'm about to ask Brad, but our sense is like just being able to start looking at it, getting a feel for like what can a chatbot do, what can a chat agent do, what could a RAG system do? Like before doing the fancy stuff, just being able to start playing with it, using some simple interactive use cases, and then using that to kind of figure out what the more ambitious ones, like before you move into like an autonomous threat hunting, like Copilot bot, maybe you could just like talk to your database. That's kind of our sort of, pull out a couple of RAG workflows you want to start with. So, but let's say, if someone starts with Louis and starts getting a feel for it, and this is actually, I guess, my kind of question I'm thinking, we're looking at you, Brad. When you start thinking maybe, let's say they do this stuff this year, next year, maybe at that 3 to 5 year level, what should they, what should they doing in preparation so that like after this, that 3 to 5 years, like they're actually kind of going in the right direction and they're kind of ready. They're not just going to hit a wall in 2 years. Like what should they start doing or thinking about?
Yeah, I mean, I think the first thing to think about is really what kinds of questions that you're trying to answer. And so you can start doing, as good of the modeling as you can get to, because, modeling is going to pay off sort of as you grow and expand in the long term, and it will pay off, as if and when you want to apply different sorts of kind of Gen AI technologies to it. So definitely thinking about kind of modeling your data, because that's something that I'm sure you guys see as a, dirty, garbage in, garbage out sorts of perspective. The second is, really understanding the sort of performance requirements that you have for your data. So, in the graph space, I often say that an anti-pattern is viewing the entire world as a graph. It's a nice conceptual model, but when you're actually storing it as a database, there's certain things that you want to store and traverse the relationships of, and there's certain things that they're just data that you're enriching with, and you don't need to pay the cost of indexing that data. So, really think about how you're retrieving the data, what are the retrieval patterns, and what are the storage patterns, from that side. And then to, put in a sort of, what I see is that from the security software vendors, Louis.ai and others, they really know the space and they're doing a lot of innovation. And so, if there are options, to try out what's going on with, any of those vendors, like that's certainly something that I would encourage people to do as well. So.
Awesome. Then actually maybe the same for Sean for you, like again, going back to the government perspective, same question, like if they want to do that, like sometimes government has to work in these longer time scales. So I don't know what you'd say to them.
Well, I think if you're trying to work with government folks, there's a lot of new innovation opportunities, especially through the Department of Defense. So if you're familiar with DIU, Defense Innovation Unit, and then the various works programs like AFWorks, SOFWorks, and so forth, that's where we have been successful in getting in early. Because just because you're getting funded innovation funds doesn't mean you're eventually getting a bridge to a program of record. So the term that gets thrown around is the valley of death. There are opportunities to get into a program office, right, to do a prototype, and then working with that program office to get you into the future fiscal year POM cycle. And there are other funds that is one, it's called APFIT. It's an acronym I don't know off the top of my head. But what that funding line allows you to do is create a bridge gap, a bridge funding. So let's say, you know, we're in fiscal year 24, the start of the fiscal year is 25 is October. Let's say they put you in the POM cycle for 27. The Department of Defense has its money so that you don't die on the vine and lose that that gap. But I think that what you said and what everybody said is it doesn't have to be trying to, you know, boil the ocean, solve the most like complex problem first. Start with something very basic, show value, and then expand from there.
Awesome. I don't know if any audience. Okay. Then I guess like going back a bit to I think a big theme of Brad's talk was the hallucinations. And so I'm kind of curious like where folks are stacking your chips. If there's like, well, actually, let me step back. Like when you're kind of thinking from you're building out your security use cases, you're thinking about how to do a good like security tool or like a defense tool or whatnot. Where are you worried about hallucinations and where are you stacking your chip? Or it doesn't even have to be hallucinations, maybe it's other threats for that system. Like, how are you thinking about making it safe and kind of both from the threat and response? Like, what's your remediation and where you're stacking your chips? I don't know if anyone wants to take that one.
Yeah, in the cybersecurity world, I think of it a lot like the medical field, right? With AI and how some of the results or answers can be really impactful, right? So the medical field, you know, it's the seriousness of missing a tumor, the analysis of using AI to scan X-rays, for example. In the cybersecurity world, you know, not as life and death, literally, but the criticality of giving an answer to a lonely junior analyst, maybe who's just off the street first week of work, right? And they get a wrong answer and they go down the rabbit hole and their investigation is wrong, which turns out and it's a breach, right? So Gen AI and the data that is used to train it is as strong as its weakest link, right? Whether it be on the personal level of interpretation or on the garbage in, garbage out. Right, and we've got a problem in the industry, and you know the best data scientists, you know, still say it's a black box. We don't know how it works, right? But at least you can control the data that you use to train a model to hopefully get good results. And some of those bad results could be racist, right, for customers, which is something you want to avoid. And on the cybersecurity, it you know, could lead into, you know, just bad information, right? So a lot of testing, a lot of QAing, taking samples out of the data that you use. One of the examples that I love is GPT4All and Nomic. They have really good data visualization tools on being able to query the data that they use to create the models and, you know, picking off the shelf. So hopefully we'll get better in the industry to help, you know, not have some of those issues that we're seeing.
Yeah, actually, I want to follow up on this one with Sean. Actually, so Sean and I do a lot of government calls together recently, and especially with the Gen AI, like it's really like gotten a lot more heated. And there, one of the kind of the broad areas of that we're hearing is like, it's cool that we're bringing them real-time OSINTs, like we're bringing them real-time news, real-time social fire hose. So as they're dealing with the disaster scenarios, they're, you know, this even like threat intel. But like the problem is like, as Brendan's pointing out, sometimes it's clean data, but sometimes it's inherently untrusted data, right? And so like it's not like we're trying to get rid of the hallucination by just like not having that data. No, the whole point is we're supposed to bring in that data. And so I was wondering, maybe Sean, you can share a bit about, again, from like the problem and not necessarily solutions, but if you have a solution, great. But like maybe like your perspective of how like, yeah, like how does like misinformation disinformation, any of that kind of feed into like when we're, you know, how does that fit into like a response scenario? Like what's today, what's the ideal, like anything that you can share?
Yeah, so this is a less technical answer, but more just my own understanding. So when we were going through the COVID misinformation piece and we were able to see through graph research tools and the visualization, you know, hey, this cluster over here is bad. This is clearly a troll farm. Well, how can we remove that, you know, that obviously misinformation or malinformation away from, you know, the broader collection of the database, so if we can almost like clean, you know, remove some of the bad stuff before it gets to the database that the LLM wants to train on to provide the answer. Another way that we're solving for this too is going first to the authoritative source before you go out to the broader internet. All right, so if we know it's a weather forecast, okay, well, let's first go to the National Weather Service to see if they have an answer. And if they don't, then we can go to the broader internet and then source, you know, more broadly, or just provide the guardrails to say, I don't have a response. I mean, it doesn't always have to give you an answer, right? And the last thing I'll say is, ultimately, I'm not interested in replacing humans, although there's some people I'm sure are interested in that and doing that, and that's their motivation. You know, their sales pitch is, oh, we can eliminate 1,000 people from your staff. That's not my intention. My intention is to support the people who are there that make the decisions, just make them faster and more effectively. And we talk about the term trusted AI. And, you know, again, what's my intent behind it? Is my intent to support human decision-making, or is my intent to replace the human? Well, ultimately, that ethics, it's all from the inventor's perspective, right? It's that inventor's intention on what the purpose of the model is. And so something that I would like to see is more attribution, like who created this model, who created this thing, you know, and what's going to give me the level of assurance if I'm taking a piece of open source software and integrating this into a Department of Defense solution or a national security solution. How do I know that, you know, the derivative of this piece of the, you know, software bill of materials isn't going to introduce risk, you know, later on?
Yeah, and I'd like to add to that, like something that I think it kind of echoes off of what John presented this morning, if you caught the Blackbird AI talk on narrative mining and stuff and using Gen AI for that, is that before it's like, you know, the internet within like Twitter or X or whatever is sort of this cesspool, and then if you did do anti-misinfo work, you can confine stuff and you could send it to Twitter or Meta and they would kind of ignore it, right? Like that was sort of the rough status quo up to about like a year or two ago, I think, with some, you know, rounding error. But now, like when we're kind of in these conversations with teams, like let's say there is an emergency, that now it's actually practical to, like, let's say there's a question of like, what is the confusion around an emergency? So not even necessarily misinformation, just confusion. Before it'd be unrealistic to expect an emergency response team to even like pay attention too much. I think would be a fair thing to say. But now it's actually, because you can actually have computers do this stuff, all of a sudden, like kind of like you know, you kind of get your own pet journalist is one way we kind of talk about it. It's like you actually have a journalist on staff that you can actually digest it. And then now as you're analyzing the situation, part of the sit rep is, what is the confusion? What is the misinformation? Is there an adversary? And then as part of the, like probably picked up on Sean's talk, part of it is actually the communication with the public during the incident. And so actually the what is it called, like a press information officer or something like that?
Depends, yeah, public information officer.
Yeah, like now all of a sudden their ability to kind of like make like sense making and then actually communicating and all that kind of thing is actually, I felt before that when we're doing just the graph stuff, it was cool from an investigative and a forensic view, but now it's actually feeling like there are things we can actually get in front of people who are actually, so to me, that's been a big shift. Yeah,
Yeah, so it's very interesting to point out the provenance, what is the behavior that can be elicited from latent space of these models and who introduced it, how. It seems the problem at the boundary between data and information is the static nature of evaluations right now. So if you treat this as a dynamic, open dynamical system, have you seen anything that tries to treat this as like enacted situation or situated cognition together with the group in this process of sense making? And if so, what would be your ideal demo experience end to end to understand the dynamics of a given system together with people in the loop making decisions.
Maybe you can paraphrase that a little bit.
Yeah, so if I'm a vendor trying to buy the system and I want to see how it match with my team, like what can I do outside of just looking at some table of results or PowerPoint, like dynamically, like to probe it, to understand that it actually works well, you know?
Yeah, I mean, it's a great question. I think okay, so speaking from a business perspective, right? So there's one camp, it's like, okay, I'm gonna patent everything and box it up, right? But just because something's patented doesn't mean we can't make it expose or provide an opportunity for people to investigate it. And whether that's, we bring you in through an NDA and then say, sure, go have at it. You're not gonna take our trade secrets and send it to somebody else, but we do want to give you an opportunity to trust us, right? Because it's a relationship, just like in any marriage, right? It's all about communication and trust. And so I'm interested personally, Disaster Tech's a certified public benefit company. I'm interested in gaining trust and building trust with customers. And if that means we have to open the hood, as long as we understand the boundaries of that, we're open to exposing it to certain people in order to, further the trust with you as a client.
One for, oh, sorry, go for it, Brendan.
Yeah, I can opine on this one. It takes me back to 2014, 2015 days of UEBA. Anybody remember those products? Right. I was one of the lone data scientists in the cybersecurity team. And when we bring in these vendors, one of the first questions I asked to kind of stump the vendor is, do we have the capability to tune or get visibility on what features are used to create this model? And if they said no, I said, here's the door, right? And because I need that transparency, I need that hands-on flexibility. This is my environment. You're bringing in your tool so that it can work in my environment. And if I don't have the capability to tune it, then what's the point, right? Your model is not going to work for everybody in the financial industry. So it's just being transparent. I think is huge, going forward, especially with AI.
Yeah, kind of maybe in a. Oh, we got another one, go for it.
I'm at JP Morgan Chase, and one of the questions we get asked is that we have these long documents that specify our security procedures and controls. Is there a way to use Gen AI to process all these documents and produce the code that would enforce these policies, and then also produce a proof that we are actually in compliance with all the policies? So is there anybody working in this problem?
Yeah, I think there's a RAG solution. Right, you want to opine on RAG for that?
Yeah, I think there's many, Don's talk was explicitly, that's actually the very first GPT program I wrote was actually exactly what Don was talking about, where I first asked GPT to generate some Python program for something, then I asked GPT to generate the unit test for something, and then I asked it to generate the Coq theorem proof to verify that the unit, it's not just a test, but a full verification on all inputs. It didn't quite get all the way there, but I do believe in the direction Don is going. But I think what we're seeing is I think it's breaking it down a bit. And I think on one end, what Sean was kind of talking about, the after action reports, where it's just given all these policies, for example, we're seeing a lot of folks saying, hey, if you want to have easier security questionnaire answering, or what is the security posture of JPMC based off of how they've done all the vendor questionnaires and all the internal likewise outgoing, where that's just a Q&A system. But more to Don's point, where I'm actually excited about is things like policy synthesis, where, okay, let's say we do have an existing vendor that does take security policies, document sharing policies, imagine your Google document, who can share with who, but actually using the Gen AI as part of that process of well, what's a better policy, or how do we fine tune that policy? So I think there's a lot of little vendors kind of chiseling away. I'm not sure we've seen the unified one.
Yeah, for RAG, I've seen it, developed it, tested it. Gap analysis is really good. So in RAG, you plop in your policy documents, right, and then the regulatory documents, and then do ask the solution chat, to do gap analysis, right? You'll get the focus, and then with RAG, you can have the cross reference. So it can line up, hey, your policy, in software development, section 3, it doesn't align with this regulatory statute of paragraph 5 from, this reg. It's really powerful and can help with that synthesis. And then the icing on the cake there is write me a new policy on the gaps that I'm missing. Now, of course, you got to go out and enforce it, right? But this documentation type of solution with RAG is really powerful.
So like a divide between the GRC people and then the code people.
Yeah.
Go for it.
Yeah, so one of the things that I talk about generally when I'm engaging these types of dialogues is I mentioned earlier the analysis of the critical infrastructure, like the physical infrastructure. Okay, if this power system fails, how does it affect this water system or this transportation system? But what we are really blind on is the interdependent risk of our policies and regulations. So, if something that someone proposed to me is, well, why can't we just turn every law into structured data, right? And then what if I could take those structured data of that law and then see where there are interdependent risks, where the laws actually contradict with one another. And I think I would be interested, and I would talk to these folks at NIST, like Ron Ross. He's the one who oversees the 800 series cybersecurity framework. And for federal contractors, we're going to be required by law to follow the NIST 800-171, which is for handling CUI. And the DoD is like clueless on how to implement it. And so they're going to tell us basically next fiscal year, well, if you don't comply, you can't have a contract. So what is the federal government going to do? Just shut down all the vendors? No, we can't do that. We can't afford it. So I think that's a really smart perspective. And it would help, I would think, hey, if we can help the defense industrial base understand how to comply with all these statutes and policies, then it would help banking regulation, banking industry, it'll help oil and gas energy industry, it'll help, all the other companies who are regulated from a cybersecurity perspective. So I really enjoyed that perspective.
Maybe actually I want to selfishly take this one for Brad because I don't often get to ask Brad these questions. The context being like we're kind of presented in your talk, and I'm talking before your talk. There's almost this like maturity model level for people implementing RAG, where it's like first you connect to databases like I showed this morning, and then next is maybe you can do a vector search that like you're showing. And then maybe you do a bit of entity extraction and you kind of populate a bit of a knowledge graph, and then you can have as part of like within the database or as part of an agentic system, you can kind of having all those queried together. So that's kind of like this, like I'd say that's roughly the intermediate, where if you think of the bigger advanced security companies, they'll say they have advanced AI, but they basically mean that. That's sort of the, I'd say, state of the art for companies out there. But once you go to the edge of like where the actual innovations kind of like that's like important, it's hard, but that's the innovation is kind of the next step. Where at this point we're starting to revisit the near definition of a knowledge graph, right? Like, is it embeddings? Is it like an auto writing wiki? Is it like what is that? And so I'm kind of curious. Like graph RAG is a term that gets pulled out. Like, are we doing hierarchical? Like, do we take the documents, the client's documents? Do we chop them up into chunks? Do we do hierarchical summaries? Do we do more creative indexing things? And so I'm kind of curious, like, without spilling trade secrets of your customers or whatever, but if you're seeing any like kind of themes about that next level of like, what's going on with knowledge graph and especially with powering these Gen AI systems, like where would you advise folks to kind of?
We see people coming at it from sort of two sides. One is I have a Gen AI application, I want to improve it. And in those cases, often they get more out of just techniques to extract graphs or derive graphs, but they don't necessarily have a formal knowledge graph or a semantic model about what they want to bring. I think the more sophisticated customers who probably have one or more well-formed knowledge graphs with well-formed semantics, and then they're trying to figure out how to take those and actually then do something useful with it, in a scalable way. So. And so how do if you have a well-formed knowledge graph, how do you apply it? And I think that's sort of much more of an open question from our side. I mean, we also have some open questions around how accurate knowledge graph generation or any kind of graph generation itself is a pretty open research topic in terms of how good the precision on the graphs can be. And so how good does those have to be to improve the results? And so that's certainly an area that we're looking at as well.
Yeah, so and kind of I think implicit to something Brad was sort of saying here is basically automatic generation of the knowledge graphs is sort of kind of part of the big themes that we're seeing here. So
Yeah, basically, can you produce the knowledge graph itself? And the early things say that you could produce a knowledge graph that we might not think was a high quality knowledge graph from if you were to look at it independently, but when applied across, compared to sort of a baseline RAG application, you're getting better results. So
very cool. I think we might have time for one or two more.
That's a hypothetical question. Gap analysis sounds pretty interesting. Has anyone done contradiction analysis? I think with policy, a lot of times what you're trying to navigate is you've got these conflicts going on.
Yeah.
And I think it'd be actually great if something could identify those contradictions and then a human could probably prioritize which one is kind of better.
I love I mean, I'm a policy nerd, so I get excited about that. So, my little homework assignment that I had, because one of the reasons why I got brought on the NSC staff was to transition the next administration. So I was non-political, so I didn't really care. I just cared about United States and continuity of government. So I picked up the phone, called OMB, and I was like, hey, give me all the disaster policies. Nobody had an answer, right? So I don't even know what this stuff is, right? So thing number one would be, hey, it would be cool if we could use these models just to find this stuff, right? Find all these policies, and then to your point, run those contradictions. And how does one policy decision then have a negative consequence to another policy decision, right? And how did those interact with one another? So yeah, whoever's interested in working with us on that particular area of interest, I would love to get after it, because it's just academically interesting, but I think it would add a lot of value in creating efficiencies in the way that we govern.
There's actually a field that pre-LLM we were looking at, and now just with the GNN side, and then all of a sudden with LLMs, it's just there's an area called temporal knowledge graphs. So it's like, imagine you have your normal knowledge graph, but it's actually events, like stuff happening over time. And then now you think of like when we're talking about like the breaking news fire hose, the social media fire hose, it's an evolving situation with conflicting perspectives. It's exactly that problem. And then from an OSINT perspective, like basically, I forgot the phrase for it, like data sort of kind of loses value over time. It kind of has like a expiration date. And so we kind of think about both the decay, but also kind of like the blind man and the elephant, like it's an evolving situation with different perspectives. And so I think what you're asking is like at the heart of a lot of like our harder problems that we're working on.
Yeah, I just want to bring up just because also I know truth is a tricky word these days, but what we understand to be like the best thing, like margarine, butter, whatever, there's all sorts of things where temporal, we actually, the contradictions may or may not make sense because we know that circumstances change. And I think there's like an ideal human interface between these big knowledge bases and what to do about them. And so the notion of things that are new, not that everything new is better, but you can at least analyze, is it new information, if it's contradicting something, what does that mean? Anyway, it seems like it's a pretty interesting area to explore. And I haven't heard anyone say this. So
well, another challenge that you have is like, okay, they want to train over 30 years of, say, NOAA, National Weather Service data, but the resolution of a hurricane model in 1980 is significantly different than the resolution that we have today. Just even the past few years, we've made advances using GPU, like 7 times, advancement in performance of the weather research forecast model that produces the hurricane spots, right, in the ensembles. So does it make sense for us to train over the 30 years just because we have more data, or does it make sense to train over the last 5 years because it's more resolute and has higher levels of fidelity? So
I can actually go on one of the medical community that I'm kind of watching or whatever, talk to me after, I guess, is if you think about like giving like precision medicine. So one of the most important things that happened in cancer care in the last X years is first like, chemo and immunotherapy, but then actually precision targeted against particular, types, right? Like, but and you're kind of required to give standard of care, right? But standard of care changes every year as a new clinical trial for different scenarios comes out. It's tried on a different part of the population. All this stuff changes, like different, and so kind of doing the data integration, actually, the thing that could read those and then actually deal with that conflict is so hard. But like when people talk about like at Stanford, they just started a AI tumor board, for example. And so, but if you think about the underlying challenge to do that, exactly what you're talking about.
How are you all thinking about avoiding releasing dangerous capabilities? So for example, we just heard the talk about how you're building a tool to identify weaknesses in US critical infrastructure. When I hear, like, there was a report a couple of months ago about how even the major frontier labs, like there's a running inside joke about how they're probably doing more for US adversary capabilities than they are for capabilities domestically. And so how are you all thinking about like not releasing materials? Like are you all putting time and efforts and team building around avoiding releases in favor of greater security?
Yeah, no, it's a really good question. It's quite loaded. There's many tactics, right? And you've got these models now that have billions of tokens, right? And it's next to impossible to really dig in and test, right? So, sampling, random sampling, and a lot on the prompt engineering, right? So just blatantly, withdrawing a question or an answer from a question that isn't related or may violate, some of the protected rights, right? But yeah, and where do you do the tweaking? Is it on the prompt engineering? Is it on the data itself? And the answer is everything, right? And I think that's why this prompt engineer type role has, come to fruition and, paying really high because, it's a really important role in order to prevent, some of the things that you're talking about.
Okay. So a couple of things, our product is not open for everybody, right? Not right now. So at a minimal, it's a closed loop, at least for those types of problem sets. But I do think there is value in, again, talking about the concept of tier line, right? I don't think we need to reinvent the wheel of how we compartmentalize information. I think we need the platform to, have those types of controls in place that we experience in the physical world, just in the digital world. I'm not an expert in that, but I think, and then another enemy to security is user experience. I think that, focusing on more of that human-centered design, making it easier for the security professional to get in and do their job, without making it so hard that they start taking shortcuts. Because, the easy button, right? Loss of credentials. The 2015 success by the Russians in Ukraine to take down the power grid, it was just somebody's, sticky note to password. It wasn't a sophisticated, advanced persistent threat. It was a camera, taking a photo of the credentials and then, getting access. Really not that hard. But because it happened and because of the spin in the media and the fact that the government wasn't, getting the fire hose of information, we were just late for need on the messaging of what to do. And it's still a challenge on things like attribution, whether you say or not, who did what and how they did it. Because it's better to be open, we're a democratic society, but also we need to make sure we're not amplifying a crisis unnecessarily. And I think we're learning that. Yeah.
Yeah, I think just to make sure we hit the break period and give some folks a bit of time for the next speaker, maybe we should probably wrap it up here, but I want to say thank you for everyone for coming up and sharing your long storied experiences, I'll say.
Thank you.
We'll resume in maybe 10 minutes or so. kind of get that on schedule. Oh, and also we'll be having some startups. I think Brennan's Skidaway, they'll be doing some sort of demo on the corner if you'd like to actually see what's going on over there.
Oh, yeah. I sure do. Yeah. Oh, sure. Yeah, train. Perfect. Yeah, we got some. Yeah. I choose. Yeah. Yeah.
Okay, welcome folks. So we're starting the next session, kind of continuing the series of multi-exit founders. Awesome to bring in Austin McDaniel. So I've been following, this is actually my first time meeting him in person, but I've been following him online for I don't know how many years now. So you've probably heard of some of the companies he was kind of early at or even founded. So I think Sumo Logic, Jask, CRFT. I'm probably missing some big ones here. Oh yeah, it's a little company called Swimlane. So a lot of like this shift left security orchestration automation kind of like SIM space, and particularly the design side of it, and especially as we're focusing on Gen AI. You know, we spent a year working on UX on just one AI copilot and kind of going back and forth on all this advanced stuff. And this time, like, I think Austin's like, yeah, I've done like, I don't know, like 3, 5, 10, 20, whatever. And I was like, okay, he needs to share what's going on here. So with that, no pressure.
Thanks for having me. I'm super excited to talk to you guys today about UI and generative AI. This is something that like people are like, is UI going to go away when generative AI comes to be? And so I'm going to talk on like the different challenges, the different types, and kind of dive into that. Before we get started, just quick about myself. I'm the CEO and founder of Good Code. Good Code's a consulting company that works with early stage startups to help them design and build beautiful experiences for their customers. And so when we talk about security, copilots, generative AI and security, you really kind of come back to one fundamental thing, and it's like, we want to really level up our junior analysts. We want to take these junior analysts that are following playbooks or something like that, and turn them into level 2, level 3, where they can, you know, do analysis, they can come to decisions and have a decent level of confidence on that. Some examples of some of these activities that these copilots are kind of doing for these junior analysts is, some of these are pretty, you know, common sense that you might think of, but, you know, sending different insights and analytics. So what, you know, what is interesting today? What network traffic is anomalous in my environment? Training and simulations. So having worked in the like security automation space, it is very difficult to test and build out different automations and integrations across multiple different security products with this like complex security data. So the ability to generate complex security data very easily is immensely powerful. Sure what happened. Oh, Zoom crashed. And we're already seeing a lot of companies kind of coming out of the woodworks recently on this training and simulation. So generating phishing attacks and things like that. We spoke with a customer that was like, hey, we are working with, you know, companies and they don't want to force their users to go through training unless they have to. So can we use generative AI to create, you know, phishing scenarios and things like that, where if the user actually does click on this, then we can push them through training. And so the ability to do things like this is really revolutionary for, you know, for the industry. Automations and response is another thing. So the ability to have the copilot go out and do reconnaissance for you, and then take that reconnaissance and then maybe block a firewall on your behalf. Now I no longer have to open up a SOAR and try to configure all of this information. The copilot can do that on my behalf. And research is probably one of the most obvious ones that we're familiar with, is researching the different tactics and things like that. So when we're talking about generative AI UIs, one of the most notorious images that I can think of is Clippy. Clippy was, for those of you who don't know, it's like in Word, there was this little icon down at the bottom that was a paperclip, and it would kind of help you, guide you and that type of thing. And so when I first started thinking about generative AI, I was like, oh, it's just a fancy Clippy. But I really see there, like, in this type of area, there's really two different types of generative AI UI. There's the prompts, which we're pretty familiar with the ChatGPTs and things like that. Those experiences are really good for doing, you know, analysis, doing threat research and things like that. And then you have the chatbots. And usually the chatbots are more like a companion. It's more like that Clippy experience where it is embedded within your application. And I think every single security vendor at RSA is doing this. But like this contextually aware chatbot that maybe it's on your incident details page and you can ask it questions about the incident and it can give you recommendations and things like that. And so these two experiences are the main two experiences I think I see the most in today's generative AI UI. So if we kind of talk about, you know, nothing I've said so far is necessarily specific to security per se. But when you start talking about generative AI UI in security, there's several different considerations you have to take into account. One, and we'll go through each one of these, but it's roughly like show your work, give references, produce an audit trail, add safeguards and good feedback loops. So this is one of my favorites. So when I was growing up, my math teacher, if I turned in homework and I didn't show how I came to the conclusion, she would just give me an F straight up. And I say showing your work in cybersecurity is such an important aspect. A lot of times, and especially in AI, it feels like a black box. You don't know what's going in and what's coming out, if it's truthful. And the ability to just simply showing how AI came to that conclusion is incredibly powerful. A lot of times when I'm doing AI prompts myself, I say, back this up, give me the evidence and the proof of why that did that. Oh.
I heard you talking about it.
Yeah. Really weird. Yeah, its Zoom just keeps closing and then opening.
Onto you.
Yeah, it's trying to mess me up here. And so I always say, defend the response that you gave me. Show me how you came to that conclusion. And earlier we had a great conversation around hallucinations. And this is one of the most notorious problems in AI. And it's one of the biggest problems of actually using it for cybersecurity or healthcare or things like that. It will, you know, tell you things that seem like they are right until you like think about it and really dig in. And just simply, if you can force it to show how it came to those conclusions and show the algorithms of, you know, why it made that decision, it really kind of demystifies that and helps you understand that it is it's Zoom that keeps disconnecting. Yeah. We'll see how long it lasts. One of the second things that's important about generative AI is knowing the right questions to ask. If you feed it questions that, you know, are open-ended or, you know, ambiguous, it's going to give you those same responses. And I think that this is one of the biggest problems in generative AI is helping the user to understand you know, what questions can I ask it? What responses can I get back? And, you know, what are examples of those? And I like, there's this analogy that I always use is like, I love going to these different salad bars, and these salad bars have tons of different kinds of like vegetables that you can pick from and things like that. 99% of the time, and I actually ask some of the waiters there, I go, do people actually go through and pick each one of the vegetables that they want on their salad? They're like, no, 99% of the time they just pick one from the menu and then add or remove something. So I wanted to take that same concept and apply it to AI, right? So in this example right here, we have, we really want to identify the persona and then give them some categories of prompts that they could actually ask the questions on. And so kind of guiding the user with these guardrails really helps create higher quality questions, which are going to return higher quality responses. This is one of the most common questions I get asked is, how do we make these look sexy? Generative AI produces a lot of blobs and of just large chunks of text. And one of the things that once you start getting into the weeds with it is generative AI can actually feed on itself. So one thing that we do is like in some of the experiences that we built for customers is we've actually fed in after the question additional things like always show this in Markdown. And then we remove that from the UI of the user. So the machine is kind of doing things on behalf of the user that the user wouldn't maybe normally do. But the thing is, you can actually do that. You can say, okay, do this reconnaissance, find me this like, you know, attack pattern or whatever it may be, right? And then give me the JSON. And then you can actually AST parse out the JSON and render some type of graphic. And what I have over here is an example of Microsoft Security Copilot. And this is like an attack graph, I think, or something. And it's that similar experience. And I think someone earlier said is like a graph has been used for a while now, but the ability to kind of visualize the data that we're getting from these generative AIs is really powerful. And I think that we're going to see a lot more use of those. One of the things that is the most frustrating thing for me is sometimes when I'm talking about generative AI and I'm asking it questions, it will 100% give me the wrong answer. And sometimes it even doubles down on it, right? I'll be like, no, that's not a package. And you're like, no, this is the best package. And so how do you kind of force users to do, you know, go through that? And I think one way is having the ability for users to provide feedback. And it's not only like, is this a good response, but did this actually solve my problem, right? I think that's the most important thing. And it's really going to help the generative AIs over time if we continue to provide this feedback. If we don't, it's going to continue to double down and it's going to continue to say wrong things. And it's just up to the, you know, the companies that are building it then to do that. And so it's really important that like, as you're building these experiences, you give the user the opportunity to provide feedback in the circle. One of the other aspects about security generative AI is I'm doing research, I'm like hot in it, I'm you know, doing an investigation, it's, you know, really high priority. I'm just gonna like copy and paste all these logs and throw it in this and say, analyze this and give me some responses. It's a great way to leak PII everywhere and then get it into like a global repo. And so some of the safeguards that you can almost think about it like DLP is watching the input boxes and understanding what the user's trying to ask. And if they're asking things, you don't necessarily have to like replace it, but just say, hey, you're putting sensitive data info in here. Please be aware of that and the consequences of that. And that goes a long way to help educate the user. And over time, like they will be more cognizant of that. And then one of the big things with security is the ability, if I'm doing these investigations, I want to be able to kind of take an audit trail of those questions because these are artifacts in an investigation. So the ability to like export the content and, you know, put it in, you know, my ServiceNow ticket or whatever that may be that I'm using to track my incidents is incredibly important. And every customer that we built one of these experiences for, that's been a huge, like, important factor for them to be able to get the data out just as easily as they put it in. Kind of closing up, if we kind of look at the future, AI is everywhere. It's almost like oxygen. And we're starting to take it for granted already. And it's being used in ways that we don't even realize a lot of time. And I put this toothbrush up here because I have that toothbrush. And I'm just, one day I swear that toothbrush is gonna be the thing that compromises my network because it's gonna go crazy. But it's important to like remember, you know, what AI is, how it's useful, and as humanity, how we can best use it. And so I wanted to show one of the UIs that we actually helped design and build for one of our customers. This is a company called Blackwire. They're working with, you know, emerging small businesses and things like that to kind of level up them, right? So I'm a small bank. What do I need to do for this compliance X, Y, and Z, right? And so having an experience where they can do it in, you know, a gated and guarded way and produce like reliable responses was really key for this project. And that's all. My name's Austin McDaniel. I'm the founder of Good Code. If you, we help, you know, companies, cybersecurity companies build UI, and thanks for having me.
Yeah, we've got time for one or two questions while our next speaker sets up. Maybe to kick it off, I was really curious as soon as you mentioned. So you say like when the case of the LLM flagging PII, what do you do?
Yeah, so one of the things that like we've done in that particular case is, you know, you can do like simple regexes and things like that to identify PII, you know, credit card numbers, things like that. And when we identify those at the browser level, we show like a simple message and we say, hey, there's PII here. Do you want to anonymize it? And we just use something to regenerate an IP that looks similar. Or do you want to proceed with caution, right? And so that's one of the ways that we've kind of tackled that problem.
Anyone else curious or yeah?
So related, I'm from Lakera, we do a lot of that sort of stuff. And we had a banking customer saying, you need to look for CVVs in your data. So in other words, any 3-digit number we should flag. So it really depends on context.
Absolutely. And, you know, when you're purpose building generative AI UIs for security and things like that, you can put things like that into the foundation of it. And that's, you know, we're talking to customers and they're like, why would I want to have my own UI over top of that? Well, you want to know these contextual items. And one of the use cases, like you were talking about, like we automatically parse out CVEs from the responses and auto inline the CVE URLs and references and things like that. And so if you're building something purpose built, you kind of have a little bit more context and you can, you know, guide the user a little bit better.
So a lot of cybersecurity products have policies and enforcement creations. How do you think about making the policy creations and visualization of policies in a very user-friendly manner?
Yeah, so there was a guy in here that really loved policies. No, I think, you know, policies can be written very difficult to follow, right? And so having something that can understand these policies and just put it in plain words, I think is incredibly powerful. We were talking right before this talk about I actually wrote a blog post on why your dashboard doesn't need another chart. I'm so tired of this, which is ironic because I actually love charts. But like, just tell the user, right? Like the chart's useful if it's like a complex data set and like I need to like show, you know, distribution and things like that. But if all I'm after is like, what are the top 3 vulnerabilities, or, you know, what are the gaps in my compliance? I don't need some type of pretty visualization. Just tell me in a normal English sentence. And, you know, that's the way that people talk to each other. And I think that's the future of computing, is us talking to computers the same way that we talk to each other.
Great, and I really encourage you to reach out to Austin after. I feel like the UI of agents, like we've literally spent a year just going back and forth on, like, we're more like tier 2 level, but just going back and forth on everything from like, I don't know, like, you know, are you generating deterministic code or non-deterministic code? If it's non-deterministic code, how does the user have to interact with it? Like they're like, are guardrails now part of the UX thing, that where the analyst is now building guardrails, or the team lead is? And all of this is like not fundamental AI fancy stuff, but we find, like, I feel like, I don't know, maybe 75% of our back and forth is actually kind of this: what is the new user interaction to actually really deploy this stuff out? And especially when you have all the complexities of an enterprise or government environment. Like, I feel like me and you could just do an entire full day of like, you know.
Yeah, let's do it.
All right, what are you doing next week? Yeah. But anyway, so yeah, thank you, speaker, and I really encourage you to talk to Austin after.
Thank you all.
Thank you. Cool. Yeah, and I'd love to introduce the next speaker. So it's like Monty Python now for something completely different. So we're a big theme where we're shifting into now is more trustworthy AI. And kind of speaking to, again, for our experience, like one of the reasons when I heard like, oh, TrailBits is doing cool stuff here is, I feel like a lot of the flashy stuff is like, you know, Don Song getting some AI red team thing in the London Museum because they're like confusing the AIs. But when we actually look at our code, and where the things I'm worried about is like, oh, is like LangChain has an eval everywhere. If your company's using LangChain, they're probably using eval everywhere. If you're using like a popular Python data science library, the IO libraries also have eval, like Hugging Face. There's a good chance there's eval and how it loads models from other people. And like, there's just like really basic stuff that for the last couple of years, it's just that like we could worry about things, but then again, like we can't forget the hygiene of the AI. And I think like TrailBits, you guys have been like one of the loudest teams here. So with that, I want to introduce.
It's a great intro. Really, it's like, this is the boring stuff that actually matters, if I may say so myself. So what I'm going to talk about today, one of the last talks of the day, so I'll try to keep everyone entertained, is holistic ML threat modeling. So I'll present what is really a practitioner's view on threat models, security of AI ML systems, and I think we need to take a really holistic view, like global perspective on this. So when we're talking about machine learning threat models, it's really tempting to assume that all you need is model security and just augment standard threat modeling approaches with model level attacks. And that's actually a very common approach that I see well established, well respected, and well-meaning companies do. So they do just normal threat models with a little bit of machine learning model attacks sprinkled in. And what we'll see in this presentation are basically the limitations of that approach, what I consider to be the MVP of an ML threat model, and how that helps us design more secure ML systems. But before that, I'll just present myself briefly. So I'm Adam Travers. I'm a principal security engineer for machine learning at TrailBits. So I lead the machine learning assurance team. And that means I just lead major AI and ML risk consulting engagements, so audits, these types of things for companies, governments, agencies. So I have both a research background in machine learning security, safety and risk, and an industry background as a GRC consultant and pen tester in different industries. So don't hesitate to reach out on anything related to this AI, ML, security, and really passionate about this. And just really happy to speak to this. So before we start, I want to start with just what is the definition of a traditional as in non-machine learning threat model. And so this is taken from the NIST special publication 853 on security and privacy controls. And the important part here is really what I've highlighted in red, which is models, aspects of the attack and defense side. So one way to just interpret this is just thinking of a threat model as an attempt to exhaustively list all the attack vectors attack path onto the system, onto a given entity, whether it is a piece of data, application, so on and so forth, and then recommend controls to mitigate or remediate that risk. And I think it's really well publicized now that ML models have vulnerabilities. So prompt injections are really one that has been in all the news recently. Prime example, you also so a prompt injection happens when you have a textual model that is tricked by a malicious user with a specific crafted instruction prompt, for instance, to output harmful content. And adversarial examples were also largely covered before this. Dongson talked a lot about that, so that's great. And so it seems very natural to just extend those threat modeling methodologies that have existed for quite a while with just these types of attacks. That is very natural. And the problem is that, at least in my view, the approach is flawed because it treats machine learning models as black boxes. And that means it will ignore certain classes of vulnerabilities that happen when you intersect a model with system security. And that results really in insecure and unsafe system designs. And to understand that, why that is, what we need to do is go back to the first principles that underpin ML systems and change our threat model approach. And essentially, what I want to say is ML threat models are complex because ML is complex. And to tackle that complexity, what we need to do is to holistically approach challenges into the ML threat model concept, into how ML models and their supply chain integrate, and how ML models operate at a mathematical and ecosystem level. So what I'll start with is some of the challenges in that threat model concept. So the first challenge that we face is system component interactions. It's not just that ML models are vulnerable to attacks like prompt injections. There are actually classes of attacks that it's model inputs that attack the systems themselves. So one of my favorite academic papers on this is in the space is a paper by Ilya Shumailov on sponge examples. And so sponge examples, they're really just malicious model inputs that can crash systems. So availability attacks through inputs to a model. And so the paper is linked in the reference list at the end of this talk for those interested, which can come talk to me and I'll give you those references. But this really results in emergent risks at the intersection of really the model, the system components. And so what we need to do is explore these emergent risks through what we're going to do is explore them through an example. So in November 2023, Trilobits, the machine learning assurance team at Trilobits released a code review and threat model of YOLO v7. So YOLO v7 is a really popular open source computer vision prototype. So it is an academic prototype, and it's naturally, it naturally comes with no production readiness guarantees. The thing is, it's okay when you're doing prototypes for academia because those are not intended to be production ready or have appropriate security hygiene. The thing is, these is actually used in production systems with large user bases. And what our team did is identify multiple arbitrary code execution and command injection vulnerabilities in this. And one of these, like the torch script differential, was particularly interesting from a emergent behavior perspective. So I'm not going to go into the weeds of this, but for context, torch script is a component of the PyTorch framework that is used to basically build models. But if you want to know more about the technical details, you can come talk to me afterwards. But essentially with this exploit, what you see is models are interpreted differently depending on operational edge cases. And so you can have a model that is benign in one case and gets malicious, so gets a backdoor, and when that edge case is triggered. And so the team made a proof of concept exploit that simply adds a malicious Torch script module to an existing pre-trained model, and that allows an attacker to obtain model backdoors when those those immersion edge cases are triggered. So you have a model that's benign, but in specific cases it's not. And that also tells us that we need to evaluate some things like safety as part of our ML threat models. So safety, that is evaluating risks from the system to the environment and not from the environment to the system, is typically not a threat model concern. However, it can have security, it can have emergent security consequences, especially in the context of machine learning. So you have the register here headline. So these are hallucinated software packages that can lead to malware infection. And so what we need to do is take a safety-informed security approach in machine learning threat models, being now in ML, there is no security without safety. And we need to make sure that safety evaluation is appropriate. So to do this, the challenge is really to anchor everything that we do in a business context, as the risks from a chatbot on Twitter are going to be different from those of an airline customer service or code generation large language model. And the last, so that's just safety basically. The last thing that we'll need to consider here is the ML threat model concept is also a paradigm shift from how we view adversaries in normal threat models. So in a normal threat model, you have end users, they might trust the organization that received their data, sometimes they don't, but usually we assume they do. And so we may concentrate on the adversaries that are outside of our trust boundaries, so on the right-hand side there. But because you have models that are inseparable from the data that is used to create it at a really fundamental level, you have a really fundamental tension between the learning goals of machine learning algorithms and the need to keep data private. And so when we do exhaustive threat enumeration, we must consider the organization creating the ML systems itself as potentially one of the adversaries from the perspective of external product users. Whether the organization wants it or not, it has that, there is that external perception, really. And so talking about data, basically, this takes us to a really interesting thing about the ML supply chain, which is when we say supply chain in machine learning, it can actually mean two things. And it really depends on who you're talking to. The practitioner's background is going to tell you whether if you have an ML model engineer or a security engineer, they will think two different things when you say supply chain to them. So in this case, in the model engineer perspective, that is one end of the spectrum. And in that case, the supply chain is really a data or third-party model supply chain, right? And so under the hood, this is really just the ML lifecycle, which goes from the choice of using a first or third-party model, so developing your own models or getting one from MLAS type of provider, through the data labeling, all the way to monitoring things like model drift, end of life, when to do end of life. And so the reason we need to take that into account is an ML threat model has, like, the ML lifecycle is related to strong risks with data and model provenance because of attacks like backdoors. So we have to take this into account. But the thing is, we also have to take the opposite side of the spectrum, which is tech stack view, which is closer to security system engineers. So that also, I'm not going to deep dive there, but I just wanted to provide it's quite a complex world. And so I wanted to provide a framework that helps just navigate that complexity, which is 5 levels defining where you're operating, basically. So at a high level, you can subdivide it in 5 levels, going from front-end model frameworks like PyTorch all the way to hardware like GPUs. And some of these tiers, so like hardware, are really neglected in threat models. So to illustrate one of these, the importance of hardware, I'm going to talk about the leftover locals vulnerability. So leftover locals is a vulnerability that was responsibly disclosed in January this year by Tyler Sorensen, who is a hardware researcher on my team and also a professor at UCSC. And so this is really a great vulnerability from a technical perspective, but suddenly he's not here today. The good thing is there's a blog post, there's a website associated with it. So lots of information on this, but essentially it is a memory leak in GPUs that in certain cases can lead to almost full disclosure of an LLM output to an attacker, as shown in this video. So on the left-hand side, you have the victim process, which queries an LLM, asks it, hey, can you tell me about TrailBits? TrailBits is a great company, blah, blah, blah. And then on the right-hand side is what is recovered by an attacker that is listening to basically to that side channel. So what is important to remember really from this section is that we have both of these components, the lifecycle and tech stack, that form the ML supply chain. And we need to address both of them simultaneously when we think ML supply chain for ML threat models. But we should also consider other things that are more fundamental, like math principles and the ML ecosystem when we do ML threat modeling. So I'm again not going to go into the details of why. There was great stuff from Dansong and others today, but many flaws like hallucinations are, in my view, inherent to the math that underpins ML models and LLMs. And so these flaws can't really be patched. You can do some testing, but at least it's an open research problem to patch models and make sure that those models do not exhibit these behaviors. And that's a big difference from vulnerabilities like buffer overflows, the things that the security community is used to dealing with, which can be patched. So that means that in order to maximize the return on investment of security controls today, these flaws needs to be addressed as early as the system design stage. And we also need to think about user practices when we produce these system designs, because otherwise there's a risk that users will circumvent the controls proposed in the design. So when I say users and ML engineers will circumvent security design, it's not because they're trying to actively sabotage the work of security team. It's because they face hard constraints and ML is quickly evolving, limited security awareness. So what happens is this leads to ML engineers sharing their models despite vulnerable file formats and trusted training data. And so when we derive security controls recommendations, we need to take all of these aspects into consideration. So if we review some strategies for securing production ML systems, what we need to do is evaluate models in context, whether it is business, security, safety, or privacy. We need to anticipate emerging risks and assess the ML supply chain, making scenarios and providing adequate controls before the risk is realized is really of ML threat models. We need to design systems such that the model is not a hard failure point. And it's difficult. There are good wins there, good quick wins there, but hard-coded parameters is a great way of doing this. But we need also to understand and support ML practitioners with secure options for model and data acquisition. So this is just some good resources thrown together. You'll recognize some of the other speakers. And if you take just one thing out of this session, it would be that to secure ML systems, you need to know at least the basics of ML and its ecosystem, the ML threat model concept, ML supply chain, ML math and ecosystem. The QR code is not malicious, it's just a link to the ML assurance page, TrailBits. And yeah, don't hesitate to reach out.
Awesome. Thank you to Ava. Well, actually, let's do questions first, then we'll talk here. But maybe I'll open it up, and maybe our next speaker can start setting up while we do questions here. So I can open up questions here with one. I'll ask a very selfish question. So we're making this like very superpowered agentic system where analysts could talk to their databases, to their own, company's own fine-tuned LLMs, things like that. And we're not the only ones building out these agentic systems. So I'm curious if you have it from a kind of this like, red team, pen testing, whatever perspective of where we are doing these like system of model systems. Any particular advice for, if we're not necessarily worried about the model, but the system of models or agents?
Right. So I think a big thing is a virtual machine learning. A lot of these attacks, they're
No, just stop the share.
oh yeah, sure. Okay, excuse me. So a lot of these attacks, they're hard to pull off outside of an academic lab. But when you combine it with systems, what you get is suddenly these are possible. Like they're suddenly in the realm of so you have normal vulnerabilities, just like remote code injection, pickle files, that allow an attacker to pull off attacks on models. And that, I think that's the big difference that we see in practice, if that answers your question.
Yeah, I have many more, but
Yeah,
that's a
okay.
good start.
We should definitely move on.
Anybody else, any questions for our speaker? We'll actually have a panel and right after the next speaker, we'll have a bit more about trustworthy AI. So part of that diverse view. So I'd love to actually introduce our next speaker, Bo Li. So kind of like Don Song, I feel it's Bo Li's like one of those people who you're like, you see more and more of. In case of Bo Li, definitely a lot on kind of like the attacks against the fundamental machine learning systems. And then the one that really caught my eye, and maybe if I could steal her time later, would be she actually just was part of this massive, I think, $140 million NSF project, something roughly plus or minus. And if you remember the session earlier where we're talking with Sean about how with the Army and FEMA and National Guard, those kinds where we're working Pentagon, we're working on real-time OSINT with all these scenarios. That's basically, they're like, okay, what's like the super duper version of that? So it's a kind of privilege to have a lead here.
Thank you so much for the nice words and introduction. Thank you, everyone. It's a great pleasure to share some of our recent findings and research and topics about trustworthy AI and AI safety. I'm Bo. I'm currently a professor at UIUC and U Chicago, and I'm also doing this startup called Virtual AI with Don together, focused on AI safety. And you will see some content related, but I will provide some slightly different perspective about product. So basically, first of all, I think I don't need to emphasize too much, but a little bit more background in terms of, yes, machine learning AI has been ubiquitous in the world, but what have they bring us in terms of security and privacy concerns, right? Is there any real world like examples of attacks we have seen so far? Because we have keep talking about the harmfulness and the concerns, but some people think, oh, maybe it's superficial, or maybe we can think about it like after 2 or 3 years or 10 years, right? But something already happens. For example, one of my favorite example is back in 2016, there is a Associated Press Twitter account was hacked with phishing emails, spreading that the White House has been attacked. And such as the very obvious fake news, right? Human can recognize it very carefully and easily. Actually, it triggers automated trading bot to dump a large amount of stocks within seconds, like here, and swap about $136 billion within seconds, which really happens. And if you think, okay, that's 2016, now we're at 2024, and maybe we are much better in terms of AI technology or things, actually, we are wrong again. For example, I think many of you may see like a couple of weeks ago, there is a typo in the annual report of Lyft, like just 500 to 5,000, right? And as human, again, you can reason and you can see, oh, it doesn't make sense, you can understand it, but then the model, again, buy a lot of stocks because of that small typo, and like the jump of the stock price is about 60 to 70% within seconds. So that shows that indeed, even we think we have capable AI models and advantages and the technologies, still we have seen a lot of real world attack happens already, leading to like severe consequences, financial loss, and even other things. For example, chatbot like GPT-4 3.5 we always use currently in addition to hallucination, and they can leak privacy-related content, and the output can be unfair, can be imbalanced. So basically, when I talk with say people from Google, they are really scared about the fairness of sensitive output, and this risks a huge PR risks, right? How do we address those? And similarly, from multimodality model like face recognition or any things related with image and videos and audios, etc., there are even misarrest in the past led by such technologies, right?
So we can see that even we have a very powerful machine learning AI technologies currently, we're still as engineers and security people, we're living a very hard life to build so-called safe and trustworthy AI platform. And that's also the last year, the White House published the executive order emphasizing the importance of safe, secure, and trustworthy AI platform development, right? And therefore, we can see this long journey among AI safety is very interesting and important and also very challenging. And a little bit his history is that in the past, back in 2018, we have started to work on this physical attacks against cameras. For example, I think many of you have seen this stop sign. A lot of people use this stop sign as a de facto example of adversarial machine learning or trustworthy machine learning, right? So that's our work back in 2018, showing that with such stickers on the sign, you can fool the autonomous driving vehicles to misrecognize it as speed limit sign, which lead to safety issues, right? And against with large language models, foundation models, and we have serious work considering privacy leakage, fairness problems, harmful content generation, cybersecurity attacks by using such large language model, for example, CodeGen model, right? We can generate infinite amount of malwares or even execute malicious code. So based on this, where we are and what's the concrete examples we've seen so far. So here I will just give some quick examples, including chatbot, and we see several potential customers and people we talk to that they care a lot about, say, the harmful, toxic content and biased content output from the chatbot. And from the CodeGen models, as we mentioned, there are a lot of prompt injection attacks and cybersecurity attacks in terms of malicious code execution of the agent we have seen, and also regarding medical and the insurance domain with a lot of document processing and the hallucination for document summarization and the QA tasks and the privacy itself. So basically what we have seen so far is that there is no comprehensive risk assessment or systematic red teaming algorithms or data or moderation mechanism that we can understand the vulnerabilities of our model and enforce the safety of our model currently. So that's where we are going in terms of how we can comply, for example, different regulations in terms of safety, right? And in particular, there is focus on foundation model itself. There is a commitment published by leading AI companies with White House and emphasizing several components, which I think form as important component with a trustworthy AI platform. First is the emphasis is the third-party evaluation for red teaming and risk assessment. Second is the how to fix and avoid the problems of fixing the bugs. Anyway, I cannot remove this bar. Basically, you get it. So basically, against those find vulnerabilities. And with this, I would put everything as a simple pipeline here. So basically, you assume you have a foundation model or agent or whatever, the agent which can use tools and which can make planning itself. And these models and agent can be adapted or fine-tuned to different domains, including healthcare, financial, banking, autonomous, etc. And the first thing in terms of building safe AI systems is we need the first risk assessment platform, which we call the virtual red. Basically here is that we provide a sandbox, just like our cybersecurity sandbox, you can execute different programs, but here we have thousands of data and algorithms to proactively attack the model itself from different safety perspective. I will slightly go to what safety perspective we talk about later. And then from each perspective, we have different algorithms and we'll text model and provide such proactively stress test against the model so that you kind of understand where is the limitations and identify the corner cases and provide the risk stress test. A second of all is that I think in the panel we'll also discuss basically what's slightly different with the AI platforms and traditional say software systems, right? So basically it's hard to find the vulnerabilities and the bugs, but it's actually equally hard to fix such problems and bugs for AI platforms, right? If I tell you your model is unfair or leak private information, actually it's very challenging to fix it. So Therefore, we bring the second component where you actually can provide we provide a bunch of toolbox that you can define, okay, I want to fix the privacy problem, or I want to fix the fairness problem, etc. And then we'll go with the corresponding algorithm and the box itself. And the third one is the virtual guard. So even we have good alignment and algorithm, etc., to improve the model, still something could slip over because of the data-driven model nature, right? Therefore, we provide this guardrail model for both text and the image, and then it can automatically find the, say, guardrail, the private sensitive information, harmful content, and the very interesting thing is that it will allow you to do zero-shot categorization addition. So basically, some, we have like some set of, say, hateful speech or violent content or things we want to guard against. But maybe later on we have new category we want to add on. But hopefully we don't need to retrain the model or fine-tune the model, and we can realize the zero shot. So basically, the model we provide here can do that. And that's the overview of the interesting component here I want to mention in terms of, personally, I believe what is important in terms of building a safe and trustworthy AI platform. So next, I'll go a little bit into the first, like the component about how to. Okay, hopefully it still works. Okay, how to like what's the safety perspectives we care about, right? So here there are two principles we follow to define safety perspective. One is application driven. So here we have this paper, which is also the best paper at NeurIPS last year, emphasizing the several safety perspectives we focus on. Including toxicity, stereotype bias, adversarial robustness, OD, like generalization, like privacy, ethics, fairness. So basically, these are application driven. Like we believe what is important currently, and we identify those perspectives. And I hide something here. You can see it's a more concrete algorithm for each perspective. There are several algorithms correspondingly to generate the challenging data and prompt and evaluate the model against. And here is a quick example that if we use this like platform to evaluate both closed model like GPT 3.5 and 4 and other open models, one thing you can see here is that very interesting in terms of safety and security or trustworthiness. There's no model dominating others, even in GPT-4. Although we know like GPT-4 have dominating other models in many, benign cases like math reasoning or like LMMU or etc. Right? However, from safety perspective, it's actually still very vulnerable, and it's again highlight how important for us as the security people to provide such proactively test and identify the vulnerabilities of models. So the model always is not as safe as we thought, and we always potentially could have the false security sense about those models, including GPT-4. And with this, actually, this platform is also hosted on Hugging Face as a one standard safety leaderboard, and this is open source version. If you are interested along this line, you can submit models, and even you can contribute to new perspectives, so that from the leaderboard we can see very interestingly there are some people uploading a lot of compressed models, showing that there is a big interest about how like the compressed and the small models can be safe or not. And surprisingly, we find that very interestingly the compressed and small models are not that bad, which is a good news, and it's showing a possibility for us to use a small model which is capable, helpful, and safe. It's just a one step over the long journey. And of course, we also put the algorithm into a platform called HarmBench, and it provides both automatic red teaming and defense, so that you can play with this cat and mouse automatically as a loop. You have new attack, new defense. Everyone worry about this. Eventually, we'll provide certification, but at this stage, it's good to play with and understand these interactions itself. And this is the first principle I mentioned about how to define safety perspective based on applications, right? Second perspective, I'll skip this. Second perspective we based or principle we based is regulation based. So basically we can see a lot of people in terms of like, I think everyone have the similar headache in terms of like which benchmark I should use to evaluate my model in terms of safety, right? There are hundreds of benchmarks like HarmBench, MTBench, BigBench, etc., etc. Then everyone have slightly different categories, right? Like say OpenAI moderation model have like 11 for harmfulness, and like Anthropic have another 23. So which one we should do, right? What's the principle to follow? So one principle I just said is from the application domain, and the other is from regulation domain, which I think is very interesting that we have done this first work. I believe this is so far the first work, looking at all the government regulations, including UN Act and Executive Order of White House and like regulation from China, European, US. So basically we have a hierarchical categorization of the harmfulness itself from like high level to low level. The lowest level have more than 300 categories of such harmfulness. So that now we can talk about the same language in terms of, okay, I'm talking about safety defined by say EU AI Act, and then I can comply with it. And we provide, for example, the A/B test for each category. Then you can go to it and say, okay, I want to comply with EU Act, and give me the model. And then there's the testing, A/B testing for each perspective, and we go through, and there will be high probability guarantees for whether you can comply with this perspective or this regulation or not. And then there on the right hand side, you can see these are comparisons of these categories among different regions. You have a high level overview, like who is carrying, focusing on what, and what we should focus, and depending on your region, your business, like types or your goals, right? So now we can talk a little bit on the same language about AI safety. Otherwise, it's too large. And in addition to government regulations, we also go to look at different industry policies. For example, here, Google, Anthropic, and the different color for the same company. For example, OpenAI here is the safety policy they published over different time. And we can also see like what evolved and what have been added, and surprisingly, there are some categories removed as well in the new time for certain reasons, right? And then we can, like if you want to, in terms of safety, you want to say, okay, my model or product hopefully can comply with Google policy or Meta policy, then you can also do that in terms of these types of categories and testing. And then we have a principle to talk about together. So put everything together, both like application driven and like a policy driven perspective, we can provide this red teaming platform. And this is a closed source version in addition to the open source version on the Hugging Face. If you play with the Hugging Face version, you like it, and you want to say, how do I customize it for my own data distribution? Or how do I have another category I really care about, or etc. So that comes to this private version that is, you can easily install it on your own, like a VPC, like a cloud, or you can also call our API, and then you can input your model, and you get evaluation and the risk levels. And you will also provide some, like each perspective you evaluated, and will provide the top 10 failure cases so that you can understand the vulnerability of your model better. And yeah, so basically, and you can download the report to provide, I think many people here is from CISO team, and I have lots of friends from AI team. And usually when AI team will develop a model, we hope that we have a report to give to the CISO team, say, oh, my model is safe enough. You can see this is the proof. Let me deploy in real world, right? We hope to make this process automatic and smooth. So basically, that's the main point of the like red teaming. I want to briefly go to one component about how we fix the bugs. So just one example here. There are many algorithms. So one example here is that actually we can use the challenging data we generate during the red teaming part to do instruction fine-tuning, RAIF, or do additional findings and fixing. So that this is one example for truthfulness. So we can see our algorithm for each base model, like Zephyr, which is by Hugging Face, and Llama 2, and we build our algorithm upon the base models. And from the last two columns, that's the truthfulness, you can say significantly improve the truthfulness over the original base model. And very interesting, even with the 7B model, it's achieve much higher truthfulness than the large model, like 70B even. And the benign performance is like similar on par. So basically this shows that it's very possible to perform the red teaming and then a test and risk assessment, and then you have a corresponding solution to fix the bugs. So yeah, so that's where we are now. And I want to put the slides off for everything. Finally, in terms of guardrail, because of the government regulation or things we mentioned, it's very easy to adapt that to other things. For example, this is an eBay website that have like prohibited and restricted items. You can directly pass it and then build a guardrail model against it automatically, so that there are some interesting case. For example, they allow to sell empty bottle, but they don't allow to sell wine. And then the model is good enough such that it can even identify empty bottle versus or other like baseline signs or can only recognize it's like alcohol, which is a false positive. And similarly for other safety related content for identification. So basically, what I want to say is that eventually, based on this end-to-end ecosystem for building this AI pipeline, it will provide you risk assessment, understanding, fixing bugs, toolbox, and the guardrails against the input-output. So hopefully that will help us towards another step of safe and trustworthy AI platform. Yeah, thank you, everyone.
Yeah, so yeah, let's do a couple of questions and then we'll move on to the panel.
Can you explain the fixing bug aspect a little bit better again? I missed it. So if I, just to get my understanding correct, if a model is detected to say having bias as and I have a high bias, how do I fix that model? Because models are trained. Do I create my own model and that be a replication of the open model, or it be the same model? Retraining. What does that mean? What does fixing mean?
Yeah, very good question. So first of all, it's the toolbox is based on different perspectives. Like we actually have like privacy, fairness, robustness. The fixing is slightly different. And in particular for the bias you mentioned, because we generate training data in terms of fine tuning the RHF, we build upon the model you have now, and then we fine tune with the challenging data a little bit with our own reward function, so that it's like on top of the model you have, it will have higher fairness guarantee on this. Yeah, that's the current fixing solution.
Okay, I'm gonna recommend we move into the, I'm gonna recommend we move into the panel, and then if you have additional questions, let's just make it, we actually have multiple red teaming experts. And so I want to introduce our last, actually the panel leader, Sven Kittel. And so guessing folks might have heard of something called AI Village, or like the White House red teaming exercise or some of that. So Sven helped organize those. He was helping run, I don't know the exact official capacity, AI and data science at first Endgame and then Elastic. And I think we kind of first met over either AI Village stuff or a shared interest in manifolds and kind of that kind of things. So yeah, and then I think that we have the other panel members. I think Bo Lee, I think we have one more person. Yeah, there's 3 people on the panel. Yeah, I feel like there's a third, but I don't know. That's okay. Oh, okay. Oh yeah, and then so then our final panelist coming from Symmetry Systems. And so if you remember the talk this morning about essentially a DLP for Gen AI systems, Claude, and previously, kind of what I love is Claude's actually kind of like Adolin coming from the actual field. So Claude used to be CISO. I think it was an insurance company.
Yeah, QB Insurance, headquartered out of Australia.
Yeah, so insurance company, and then you had like an even wider perspective over at Gartner. So now you joined the dark side over with Symmetry. But I think like it's a pretty diverse panel, so I'll let Sven take it from here.
So it's actually the first time I'm operating a panel. I think there's enough people that you can just hear me when I speak up. Other people virtually, sorry.
Yeah, I think we might have a few online, but I'll give the mic to the panelists.
Okay. Anyway, so hi, I did the generative red team last year, and one of the big things was that I kept proposing was, what about the unknown unknowns with red teaming AI security stuff? And it makes things interesting in an adversarial context, but for a generative AI context, like how do you go about securing an AI system with guardrails and all that? Like how do you actually go to make sure that you can't get messed with?
Want me to start with this? So it's a complicated. It's different. It's complicated is my general answer, and generally I think the system aspect it has a huge impact on it. But I think what is interesting with Gen AI is the mode collapse when you have potentially multiple LLMs, talking to each other, learning from each other, and that's something that we've seen with GANs in the computer vision space. So these types of things change the perspective on like non-generative AI. And so when we think about this, just think about the systems, think about all of these implications of having multiple systems learning from each other.
Yeah, I think this has been a very good question. We have been thinking about it in terms of GenAI. For example, I think this from data model and actually application, they all have different components. For example, from the data perspective, they are much higher dimension compared with just like software or cybersecurity in terms of the potential vulnerabilities. And for model level, indeed, like we have model, we have multiple data model, we have agent, we have all kinds of like model. They can do a lot of new tasks which raise the landscape of the risks again. Therefore, how to define like adversarial targets in Gen AI become even much harder than like non-Gen AI traditional field. And finally, I think another thing I find is very interesting, I briefly mentioned in my talk, is also like for traditional software, finding the bug is very easy. If you find it, it's possible to solve it with human. However, for Gen AI, if you find it, it's very hard to solve still, and it needs extra work, and it actually needs the end-to-end loop to fix it and attack it and fix it again. So I think all these dimensions make Gen AI safety another different topic and way of thinking to solve it, in addition to our experience for traditional non-Gen AI safety.
I'm going to bring a bit of the corporate perspective to a slight difference. I mean, for most corporates, they're not even at this level where they're thinking about the deploying a Gen AI within their environments. They're dealing with the first part, which is everyone in their organization wanting to use ChatGPT online, etc. The way they're going about that is actually the organizational policies and trying to figure out that aspect of it. For the ones that are starting to look at building their models internally using their own data, that's kind of where we at Symmetry come in, kind of making sure that the data that they are putting into that is not sensitive or not suitable for sharing across the organization with the right access controls built into that, and kind of building it into the model from that perspective. So I think it's a multi-complex problem, not just from the technology perspective, but from the organizational deployment as well.
And now this gets into a bit of an intersection between your two talks. Like how do you do the threat modeling for a generative AI system? Because I know how to do threat modeling for a malware model, a bunch of other models in an adversarial environment. There's a bunch of models that don't really have a threat model because there's no real threat. But in a generative system, it's kind of weird. But like, how would you do that? Do you want
to? Okay.
So as I said, it's really multidimensional, and I think you cannot just think of just the model itself. You have to think of the model. It basically you have to start from the risk and define the risk as, is it a risk to the users? Is it the risk from the users? And is your risk a model level risk? Is it an all-encompassing risk? And that's how I go about it. So I just try to think of what are scenarios of exploitation, what are scenarios of failure. Yeah, I hope that answers.
Yeah, I think indeed models starting to be used now, but I actually think there are a lot of real world vulnerability happens already, like the code gen, like injection already there, and the cyber jailbreak already there, although never either is tried or not, it has. So I think there are several levels of threat modeling where thinking in terms of like adversarial goals, right? So just defining the goal is very challenging, and that's why we're thinking like based on the goal we can like do the principle in terms of application driven, governance driven, and etc. And then attacker strategies, that's the algorithm side, like how the attacker can use another model against the model itself, and then it's very powerful, and we need to take that into consideration. And the last thing I think is very important is the attacker constraints. If we think a super powerful attacker as any security topic, we cannot defend against the attack anymore. But in reality, there are some constraints, and we can, especially under certain domains, so we can consider that and leverage that and do a better job in terms of safeguard.
From the data-centric threat model, it kind of stays the same. You've got an information flow control model where you've got information at risk, So, who has access to that? So that threat model is who can access that data and what are they accessing it for? And then looking at any way that you can, I suppose, attack that identity or change that purpose of what they're using it for, change the data. And that kind of leads to the confidentiality, integrity, and availability kind of risks that we've been talking about.
I have a follow-up in that, like, can the traditional frameworks like Stride, RED be used against ML models? What are your thoughts there?
So they can, but then you also have models that, frameworks that are dedicated to ML settings. So like Moderate Class is a good one. It's again, it really depends on where you're focusing your risk view. So what we see in MLOps, for instance, is a lot of the vulnerabilities that exist in tools are just the same old ones. So no authentication, just plain old RFIs and so on and so forth. So yes, that definitely exists, but I think it will eventually just die out when the industry realizes the importance of this and includes security from the start. And what you'll see is more people moving towards the combination of attacks.
Yeah. So actually kind of a little different question. And so the context being like today we actually, just for we're in very sensitive places where we really do worry about like confidentiality leaks, for example. So we just straight up don't do a fine tuning where someone else on another team, which is like our back separated fully. So do you trust like guardrails and fine tuning? Like, would you actually trust us to do fine tuning of knowledge and then have that, and then have a guardrail actually enforce confidentiality? Does anyone here trust that?
Yeah, I can add a little bit on that in terms of how we got real. For example, for privacy as a topic itself, like say from the theoretical perspective, we can generate, like maps the data to another data with differentially private guarantee. And with that, I think I will be able to trust it. And but just the adaptation or removing sensitive content, that's definitely not enough.
I actually bring up Louis as an example of how to do things.
I'm just going to say that the old adage I've always applied in all my career in the security space is trust but verify. And that verification actually makes sure that you're not just saying, oh, I've got the permissions to put those guardrails in place, but you're actually monitoring the operations against that data, actually making sure that you can provide evidence that deterministically proves that those guardrails worked. And I think that trust but verify gets us closer to that ideal point where you can say, yes, I trust.
If I may, so basically, I think that a lot of the risk is driven by the stochastic randomness. And so guardrails that happen at the model level, they will be bypassed at some point by certain adversaries, and for that, you just need to do different system designs. But what you can do is try to reduce that randomness, that probabilistic aspect by doing just hard-coded parameters, just the basic stuff that works well in normal security does help. Yeah.
So this is, the next question is related to CISO stuff. But what keeps coming up, and this is a big kind of debate, is bias in AI systems. And is bias a vulnerability? It's not. It doesn't fit the definition. But like, how do we integrate that into the threat landscape? Where does it belong? Is it a brand safety thing? Is it a content safety thing? Is it a compliance thing? Like, where do you see like the idea of bias and like more ethical harms, these models living at RSA and other security conferences?
Okay. I see it as safety because also with the definition of safety being the model or the system impacting its environment, I definitely see it as a safety issue from the like very large definition of safety. And I don't like compliance is good, but it's only if we recognize the impact that we'll get. Like we won't get into checkbox stuff, and we will get into actual reduction of risk.
I think also that it depends on the applications. I think, for example, for model builders like Google and OpenAI, they really care about bias in terms of identity related evaluation, and that's what we discussed. But for some retail company, like they have some branding like a skincare chatbot or things, they really care about the recommendation of the branding, as you said. For them, I agree, it's all like on the high level of safety cat, but actually for different applications, they also care about slightly different perspectives. That's also the complication of the Gen AI safety that we just talked about.
My Gartner answer would always be, it depends. I think for a lot of organizations, the impact of that bias is where they start classifying their risk taxonomy and kind of working through that. So for an insurance company, it might be they have bias in their pricing models. That's a pricing risk. For a public facing company like Google, where they are actually showing and producing output that's publicly facing, it's a brand and reputation kind of risk. So I think there are multiple ways to create taxonomies in this risk base, and I don't think anyone has actually solved one that works for every organization. But most organizations have to figure it out for themselves and define that for themselves, so they have a common language that when they talk about bias and in their risk universe, how it fits into their risk universe.
I would like to be able to bring up more examples in the hiring one, because that's one where there's a real risk to compliance, and everyone here understands compliance. But there's several cases of brand safety around Google outputs from Google models that have drastically impacted stock prices. But anyway, anybody questions from the audience? Yeah.
Is there any work happening around using differential privacy with ML models and Gen AI context? And what do you see the future with using differential privacy?
That's a very good question. Actually, we just had a paper this year at ISML like a couple of days ago, collaborating with Microsoft. And the thing is that I understand, like, if we do training from scratch, it's impossible. And there is certain ways, for example, you do differential private data generation. And when you generate data, you can train models for how many apples or things you have. That is possible. And that is, you can even leverage the generation capability of the model to generate data. In the, in traditional way, people use differential privacy. The problem is that utility drop too much when you add noise, right? Now, since the model generation capability is so good that it generates data actually, even with differential private guarantee, it still have good utility. That's a very good upside for using Gen models for DP. And yeah, we have shown as a prototype, it works pretty well on real world text data.
Can you explain the setup there for like, is this a scenario where it's like synthetic data, and like, let's say in social networks, you don't care in the individuals, you just want to learn what it means to be a bot versus not bot. Or like, I'm just kind of curious when you're using, what is the setup for confidential, differential privacy here?
Yeah, good question. So basically we have a bunch of text data, and several, like one is a Yelp review and the other is archive review or things like the open data set. And what we do is like, we want to generate data following the real distribution. So basically given the real data and give it to say GPT-4, and it generate data, it generate a lot. And then in the embedding space, we sample the histogram and then guarantee the privacy, and then use pick the one with closest one, and the histogram itself guarantee the DP. Then you get a bunch of synthetic data with similar with original data distribution, but it have DP guarantee so that you can use the new synthetic data to whatever downstream task you want. So that's set.
I think for a lot of organizations in this space, they ideally want to get to differential privacy, but they're taking the easy way out right now. They are still just using tokenization. They are replacing sensitive data with a token so that they can kind of reverse engineering it that way. So that obviously has impacts on the threat model, because you can, if you get access to the token and the data, you can kind of rework that to define that personal information and identify that person.
I'll be the voice of doom here, but like the problem with differential privacy is that if you want to learn a lot of things about your data, you'll have lower guarantees. And so you get again a tension between the goals of the organization, privacy or the privacy goals. So you get into problems around configuration as well that you have to think about. And so to your point, that I think that complexity is also something that organizations are not into differential privacy now, but like when they get to that, it will be also very difficult for them to get that right.
On the similar lines around authorization, right now people are talking about as a input output, do authorization checks there, because inherently ML models don't really have authorization guarantees. So is there work happening around, you see in future having ML models having authorization checks, some kind of identity attestation or attributions?
So OpenAI had this system prompt versus user prompt, which is one way of doing this. I think there was also today a talk about splitting the functionality of models, and that to me is really interesting as a way of re-architecting LLM designs to try to prevent these type of things. So yeah, I think the future is bright.
Thank you. Yeah, I think one thing to add on is that actually we can train agent to guarantee such authorizations as well. Some ongoing work we have is that like such authorization use, for example, access control on certain things, you can map it as concrete rules and you want the model to follow or check. And the model, data-driven model is very hard to follow all these rules. However, you can have another agent implement these rules and check. Check is actually much cheaper than following, so that you can do checking and the violation check and auditing. So that is actually very possible and effective. So I think that's very interesting and promising.
Are you saying that we will have chain of agents? The agent by themselves will do the verification and the model will not be exposed to the end users. The agent will be acting as a proxy.
Exactly. Yeah, as a proxy. Yeah.
I think if you go to the RSA floor, you might find a couple of startups doing.
They all have marketing engineers to say that they don't.
Yeah, the RSA floor is filled with a lot of that. So I think we're like nearly out of time. We got like 5 minutes, and I have questions about. I know your threat modeling. So to me, the biggest, like, I come from the security background. Like, I built malware models for 4 years, and I've been building tools and technologies for securing machine learning models in like adversarial environments. When I look at generative AI, it looks to me like it's we don't need the same level of guardrails and stuff. It's more about bringing brand risk. But the thing is, you can never be entirely sure how the model is going to behave. You're always going to have prompt injection that your guardrail miss. You're always going to have some bias in there that you miss. Like, how do you, like, from a corporate perspective and academic and like threat modeling perspective, how do you like account for the fact that you're always going to lose? Like, eventually someone's going to come up with something that if they need to, they're just going to find some bypass or vulnerability in your system.
I mean, that's the life of a security engineer. But outside that, I think it's just about what is acceptable in terms of risk. And so that's my GRC background speaking there, but like you have to define what you're okay with losing, and because you will lose that part. The thing is, if I lose only things that I'm okay with losing, it's like investing, right? Don't invest stuff that you cannot afford losing. So assume that your models are vulnerable, and then design your system, design your operating practices, everything around that.
Thank you. Yeah, I agree. I think from the practical perspective, we can design a threshold and design, especially for the adversarial constraints, like what we allow adversary to do in this environment, right? They should not be super powerful. Like can do arbitrary in that way, we cannot guarantee anything. So from the practical perspective, I think that constraint and that tolerance ratio we can set and to protect our based on how safety critical the business is. And the second is from relatively theoretical perspective, we can provide the guarantees like lower bound of like risks or upper bound of like risks or loss, etc. And that need additional assumption for like the actual algorithm, the model we are using and what domain they are using. But actually, that's also very possible. But in that sense, we absolutely can guarantee there's no future attack we need to worry about as long as their constraint fall into this like categories or like say they can manipulate code up to K lines, for example, that's a constraint. And we can try to set the constraint as practical as possible and therefore to provide guarantee. I think that's a very promising direction. Yeah.
I'm gonna probably be a little bit more pragmatic, but I don't think a lot of CISOs are thinking about exactly this. They haven't updated the incident response for an attack against their model. They haven't. They need to.
Like we would, one of my jobs was to forecast how long the model is going to last before it gets breached. Like,
It's not very long.
no, for malware models, it was about 2 to 3 months. For spam models, it's like a few days.
Yeah, for Llama 3 is 20 minutes.
Yeah. Yeah. But like,
and how much does it cost to rebuild the model?
I mean, depends on the thing, but like,
I
can't say what
we worry about that because, you know, if your model's built on personal information and it's built on potentially GDPR information, and you get a request to remove that information, you'll have to rebuild that model without that data in it. Yeah, that's the.
I can talk to that last point because like back in 2019, we wrote a paper on machine learning that is complicated. It depends on what your setup is. And you essentially have two ways of doing this. One is probabilistic, which is some guarantees you cannot necessarily prove them. There are some good papers that show that it's very difficult to audit the probabilistic aspect. And the other is to just remove data points. And the idea is, do you retrain everything from scratch? And the way we approached it was ensembles, and you just retrain part of the ensemble. That is a lot less costly, and you can audit that it's implemented correctly. But yeah, it's a subject that is quite interesting that I think larger organizations are thinking of, but the smaller ones now.
Most advanced, and in 2018, when I was setting up the AI Village theme, I was into the job interview at Facebook, and they described a canary system for managing their spam model. It was years ahead of anything I saw in academia. And then finally, someone published a similar system in 2022, and they had been using it since 2016. Like, this is, you know, large organizations are thinking about these things and are years ahead of a lot of those smaller ones. Anyway, I think that's pretty much time. Leo, do you want to take it away?
Well, first of all, thank you to the speakers. Yeah, I encourage folks to just like hang out. Like, we don't try to actually do this like as a super big event because we actually, honestly, it's to get people like this together to just be able to actually have this kind of conversation and encourage folks to just hang out after. Anyone online, this stuff's recorded, come to the Slack channel. Let us know how to do the online part better because we're still figuring that out, as might be clear. I don't know, but thank you again, like me personally, just for everyone. Like, I feel like I'm learning a lot and I have more questions than I came in.
So the AI Village is actually at the RSA Sandbox, and the happy hour starts in 20 minutes.
Okay, yeah. So actually, I should have actually been saying throughout the day. So first of all, go there because I love all the people involved with that. So that's awesome. And then we're gonna have, about, like, I know people are in and out all day, just because like basically anyone who comes here is generally a busy person. We, after all your dinner, whatever your fancy dinners are tonight, we're doing like a second part at 7:30. We're gonna have, that's gonna be a little more startup oriented, so like folks kind of just doing, kind of earlier stage stuff. And then I think a bunch of folks from today are gonna be back. That's, I think Silicon Valley Bank has some sort of fancy experience center a couple blocks from here. So we'll be right on Market Street, so wherever we're happy to, we'll be. Yeah, but thank you, everyone. Thanks for making it such a great day. So
give us the thing like Ramos to do. Yeah. So, I've got another thing. I'm gonna do another thing.